All right, fire away. I know there's going to be a lot of questions.
Well, I'll start with you call it magnification, but to me, it's more like stretching, which I don't think anyone has ever denied that you can have this kind of stretching that occurs in different atmospheric conditions. If you were to look at the horizontal size of these objects, if you were to look at the horizontal side of these objects when they seem to have stretched and count the pixels there, that would be a better argument for atmospheric magnification, as you would expect it to increase in size in all dimensions, right?
Yeah, oh no, I agree with you there because I said earlier when I mentioned this that I had a discussion with Jesse about it, and he mentioned to me like, "Oh, do you notice it on the horizontal as well?" And I'm like, I think so. I don't know. Let me go check a whole bunch of comparisons that I've got, and it's kind of hard to compare in a way because the difference as well can be, well, the conditions are slightly different. So, maybe you've got different shadows and all this sort of thing. But I would say in general, if there is a difference, it's just a matter of a couple of pixels, whereas the stretching side can be many pixels. So if there is a slight magnification horizontally, it would only be a couple of pixels. I haven't noticed it to be many. It's mainly is like as you're saying in the stretching side. I don't disagree with you there. That's it. So obviously we're all in agreement. The Earth is clearly flat. Then everyone just seems to agree. Thanks for coming. Welcome to Flat Earth, everyone. But yeah, from this we can also work out an entire perspective horizon model because that's how observation works. Doesn't matter how high we go, the same thing happens. This visual ramp that we see still happens. The horizon is still the dividing line of perspective, and everything just has to go to zero. So technically, what's below your feet is zero. At the horizon, it's still zero. When it gets beyond the horizon to the other person, it's still zero. And we have this adjustment. So it's going to raise up, or appear to raise up, I should say, in inverted commas. It appears to raise up in inverted commas, and then it then appears to drop in inverted commas. But all it's doing is it's appearing to go up as it rises with you, and it's still at zero, and then it must drop back down to zero. So as it gets further away, it's dropping back down to zero. So it's always at the zero level. It's never not at the zero level. And so we can actually create an entire working model from this over a flat plane.
I have something to point out, or slash a semi question, if you don't mind. But Essie can go first.
No, you go ahead, bro.
It's gonna take maybe a couple minutes, so if you're just quicker, you can go ahead.
Well, yeah, I wanted to compliment him because I think he did something that nobody else has done. I've talked about it many times when he showed both perspectives, one boat from one side and the other boat from one side looking in the middle. That was beautiful, bro. Beautiful.
Yeah, thanks. And like I said, I'm going to be doing another one of those as well, where we don't have a mirage in the middle and from a further distance. And so I know that from that area, which is Hallett Cove, which is 12.6 miles away. So I'm pretty sure that when I get to that area on a day when there's no inferior mirage, that there should still be a horizon between us. I'm hoping that there still is. I'm hoping the horizon is maybe, anywhere between that sort of 7 to 8 mile mark. So either way, both of us will have a horizon and there'll be no miraging. So I will still see it go up, and then before it even hits my horizon, it'll probably get to his horizon and he will already see it going down. But then what we're going to do is I will then quickly drive to the other jetty. The boat will come back. So the boat's going to go to him and back to me, and we'll get it going both directions. I'll drive to that other jetty. I'll get the boat to come to that jetty, and then we'll get the boat going from jetty to jetty, where there will be no horizon in between us at all. And I will see the boat appear to rise up all the way to his jetty, and what he will see is the boat appear to drop. And so this is where, like, it's just a crazy thing of the way the observation works. And that's where I used this one. That's where I showed this, and the other guy sort of didn't really kind of get it, where we have this. right? This would be the day between jetties, where if it starts, oh, sorry, my thing's lagging. If it
Just
starts,
hold on for just a sec. When he says jetty, for those that came in late, he means a pier.
yeah, sorry, a pier. Yeah. So, like if the horizon is actually going from pier to pier, jetty to jetty, and it's all the way that distance, when that boat starts off at me, I will see it low. My friend on the opposite side will be seeing it up high within his vision. This is all just visual. It's not real. It's not really high. It's not really low. That's just how we see. And then as it moves towards, for me, as it moves towards the horizon, moving towards him, I will watch it go up and he will watch it come down. Right? All these things that I've described, like I'm only going to get the visuals for this so that I have the visuals. I already know that this is what's going to happen. It's not even a question to me that this is what's going to happen. I know it's going to happen.
Can you pull up some of your slides that had the perspective lines drawn on it?
Hold on, I'm not sure which ones you would mean. You mean where I had just like a perspective grid? Or you mean like
Yeah, where you were showing the perspective lines and the shifting of the perspective lines.
Oh, the shifting? Okay, hold on a second. Like say from here?
Right.
Sort of
Well, you can pick those. I think the problem that you have, your perspective simply states that things that are twice as far away are half the size due to perspective. And if you don't have any lines in your picture to determine the vanishing point, then those lines are essentially completely arbitrary. You can't see a vanishing point anywhere in that picture to be able to draw any lines of perspective.
Well, the vanishing point's always your horizon. The horizon is the vanishing point. I don't have to
Well,
have.
no, because if you have things in the background, obviously that's not the vanishing point, right?
But there's nothing in the background.
In this picture,
So,
yes. There is no vanishing point in this picture that you can point to.
so we can go to, let me find it. And it'll be the other way around. All right, I'll just find the other one. Sorry, I thought didn't I have that? Was it this one? Oh no, that's that. Oh, here we go. I knew I had it there. So here, right? You're
Yeah,
saying
there's
that
no vanishing point. There's no vanishing point in any of these pictures for you to be drawing perspective lines. Let me give you an example.
Yeah, I know exactly what you're talking about, but what you're talking about are arbitrary lines drawn to a point. Okay, like
If we
I
look
said
at
to you before, a perspective grid could actually be drawn across that entire horizon. It doesn't have to go to a vanishing point. A vanishing point will happen when you have something like two straight lines heading dead straight in front of you going to the horizon, then you will get a vanishing point.
But if you have no parallel lines to reference in your photo, you have no way to know what the angle of those lines is supposed to be. Compared to look at the picture that I just posted in the live stream text, you can see that we have parallel lines to reference because obviously those train tracks are parallel in reality, and so we can reference those to find where the vanishing point is and also where to draw our perspective grid, right? Because we've got a point of reference, but that doesn't actually exist in your photos. Your grid is just completely arbitrary. You're guessing that angle because you don't have anything in the picture that's actually parallel into infinity to be able to draw that.
Yeah, but it's all kind of arbitrary, right? Even drawing lines directly
No, because if you
is
look at my photo, it's not arbitrary. You can follow those lines and see where they converge, and that's your actual vanishing point. Because we have an actual parallel, we have in real life parallel lines in the picture. That's kind of like our guide.
Can I just jump in real quick, Paul?
Yep, but I'll show you. Yeah, sure, go.
Okay, so to the gentleman who's speaking, if you were to take away those two parallel lines, your vanishing line, your vanishing point would still be the same straight ahead of you at the point where the convergence of those two parallel lines happens. That's your horizon. That's the division of the floor and the ceiling. So simply because it seems difficult for you to understand that if you don't have two parallel lines going to that point, you're still going to have that point in your distance that you're looking at.
Is that Travis I hear?
Yeah, that's
And
me,
then
SC. What's going on, brother?
What's
We
up,
miss
bro?
you,
Good to hear from you.
Travis.
Like, I think we all agree that if I take a picture of my living room, there's no vanishing point in my living room.
no, but you still have perspective, right? You're just trying to say that perspective is this arbitrary thing where we must draw a
You
vanishing
still
point.
you still
Now,
have perspective.
hold on. I'm not finished. Let's have a look at your picture, right? So your picture is still describing exactly what I'm showing and what I'm saying. See, can everyone still see my screen? We see this, what I call a sleeper. I don't know what you call them. In Australia, we call these things sleepers.
Railroad ties.
Railroad ties, all right? So see how this railroad tie appears to be below this railway tie, which appears to be below this one, which appears to be below this one, and so on, and so on, and so on, until we get to a point where we can no longer see them because they blend in together, because this is obviously, but if we were to zoom in, we would keep seeing them, right? So this is still doing exactly what I'm explaining. We have lower to higher. This is still the same thing. And as Travis just explained, here we have a vanishing point, but take these two things away. The horizon is your point of vanishment. Everything will start to disappear from there. So just having these train tracks and going, oh, we must have a vanishing point on a horizon. No, because then otherwise, what are you saying? When you go out and take a picture of a horizon, there's no such thing as perspective over that entire, when you're looking out into the distance and you see this visual ramp up in front of you, perspective doesn't exist there because there's no particular vanishing point because we don't have two lines going directly to each other. That's ridiculous. That's just a moot point.
Perspective
It's a moot
exists.
point.
I think the problem is, like, if I take a picture from 5 feet in front of my couch against the white wall, there is no vanishing point, right?
You
If
don't
you were
need a
to draw
vanishing point. You have
lines, the
perspective.
lines would still be completely parallel. They wouldn't be angled at all because we're not looking far enough into the distance, right? Because perspective just means things twice as far away or half the size. But obviously, in the
Just
case of
real
the
quick,
couch and a
though.
wall, there's very little depth in that picture. There's no really depth of frame in that picture. So there is no vanishing point.
Right. So then, in my opinion, you're bringing up something that is not equivalent to this discussion. So why are you distracting us from having a positive discussion about what we're looking at in the distance, not sitting in your living room on your couch?
He's not distracting us. It's a fair
Well,
question.
when
Thanks, Jake.
we're looking at things that are being within the global paradigm, we consider that they're being obstructed by the curvature of the Earth, which is essentially like a wall or a hill. That's not the vanishing point, right? That's an obstruction in the same way as the wall behind the couch in the picture in your living room. That's not the vanishing point. That's just an
Then
obstruction.
we're not talking about the same thing, man. Stop wasting our time, dude.
Yeah, go
Exactly. And
on believing in your ball. Sorry, Travis.
okay, so let's just say if we just look at something like this, just as a in general, what? So you're saying because there's no vanishing point on there, then there's no perspective? Because what I see, right, is I
So
see
there's always
these waves
perspective,
here. Hold on, I'm
to
still
be clear.
talking. Excuse me. I see these waves here lower than these waves, which appear to be lower than these ones, which appear to be lower than these ones, and we can keep going all the way up to the surface, right? But now here's the sun. There's perspective going like this, right? Of the way that the rays are coming through here. We see perspective here. That's not a vanishing point though, because see how wide it is right there? They're going up to there. They're not a vanishing point there. It doesn't you don't have to have something go to a point for it to be anything to do with perspective. Perspective shows us that everything that is below or closer to us will appear to be lower than everything is further away from us. Okay, so what you're talking about within perspective is just like how perspective affects the size of an object. I'm not just talking about how perspective affects the size of an object. I'm talking about how perspective affects our visuals in relation to the horizon, not just how it works on making things see or seem smaller in the distance. We're also just talking about, then you're talking about angular resolution as well. Okay, I'm not talking about angular resolution here. I'm just talking about how the horizon and perspective work together to give us the world we see. We're not talking vanishing points. It's a moot point what you're saying. If you don't understand that, maybe go back and watch it again.
So to be clear, I don't disagree that there's perspective in every picture. Obviously, there's perspective in the picture you posted, but there's not always a vanishing point.
You
I
don't
would
know.
say that in the picture that's posted there with the crepuscular rays, I would say the vanishing point, if there is one in that picture, is going to be those crepuscular rays that we know are parallel, right? You agree that those crepuscular rays are actually, that there isn't a sun, that I can't just get on a boat for 45 minutes and then the sun will be directly overhead, right? You agree that that's an optical illusion
Of
there,
course.
right?
Just like the
So
horizon is an optical illusion.
yeah, just like the train tracks, right? You can't, right? And so in this thing, I would say that if there is, because obviously they're kind of disappearing into the clouds there, but I would say that if there is a vanishing point, it's going to be kind of where those crepuscular rays meet would be the vanishing point, not the horizon. That is actually much closer to you in that picture than where those crepuscular rays converge.
Yeah, well, I'm talking about what's on the water, not what's in the sky.
But would you agree that in that photo, where that horizon is much closer than where those crepuscular rays converge?
Oh, where they converge? More than likely, yeah. But I don't know whether or not.
So the vanishing point in that picture would not be the horizon, because you said the vanishing point is always the horizon. I would say that in this photo, the vanishing point would be where those
Well, no,
crepuscular rays converge.
you're talking about the vanishing point of the rays. I'm
That's
not talking
because
about
they are above the floor. What Paul said
we're not talking
earlier
about that.
still what Paul said earlier still stands. When you're looking at the horizon, that's the limit to the surface. If you're seeing crepuscular rays coming at you, you're seeing from the horizon, because that's where they're originating, something above the surface. That's still your vanishing point, dude. That's still the extinction of your ability to see into the distance. That point called the horizon.
Yeah, I know. I did have some.
I think those are some great pictures you got there, and I don't think there's much disagreement into what we're seeing. I just think that our explanations will just disagree between the globe and the flat, but
Well, the only thing that I would like you to consider is the fact that neither Paul nor I ever have to appeal to curvature to explain what we're seeing. So the point of agreement that I hear you agreeing with is that you're agreeing with perspective, you're agreeing with refraction, you're agreeing with everything that makes you feel comfortable, except for the fact that we don't ever have to appeal to the curve ever. And exactly how Paul has done so, I think, expertly in this presentation, Paul.
Thank you
I
very
guess.
much. And
Go ahead, Paul.
no, you're right, man. Go.
Oh, I
What
was
were you
going to
saying,
say we have to. I would say that you would need to appeal to something to figure out why, on the clearest day, when the water and the air temperature are close together, and we get the sharpest image with the least amount of stretching and distortion
Can you show
from
us
the
what you're talking
atmospheric
about?
refraction. Sure, but if we look at the slides
No, I
that
don't want you to.
show this.
I don't want you to describe something to me. I'd like you to show me exactly what you're talking about in the exact conditions that you're describing.
Sure, I'll bring it up. Hold on. I think that Paul might have a slide ready to go, so we're not waiting for it. Can you show me the slide of the black swan, that where the crane is not distorted? Do you have that picture in your slide? I think we saw it.
Yep. Hold on.
Drop. Where you go?
Sure, there we go. So, and I don't know. I've seen a clearer picture of the black swan than the ones that you have there. Let me see if I can find one. But what you would have to explain is, on the pictures that have the least amount of distortion visible um, on the oil platform, why is it being obstructed at all? Actually, I don't think you have the. I don't think you have the one where it's showing mostly obstructed. Do you, Paul? Let me pull it.
No, but like I've just described for the entire presentation, whether it's obstructed, when it's obstructed, it's due to the dividing line of perspective on both sides. So again, this image is what gets used 99% of the time. Okay, this is the one that gets used, and as you can see, the image on the left there is actually an image in an inferior mirage. So the one that you're going to show is an image which is getting closer to a superior mirage type event where the cranes are starting to warp a little bit, right? So we have a little bit of a temperature inversion layer up there, but the temperature inversion layer is affecting what's happening above the surface. It's not affecting what's happening on the surface, right? Where here, you guys are ignoring the fact that that image on the left-hand side is actually in an inferior mirage, which then drops all the image behind it. Right. So you can't turn around and say, well, explain this crane here and how we have this warping here. And on this other day, we don't have the warping. So therefore, this one's the better one. When we get shown this kind of thing, where we get shown an inferior mirage on one day and a non-inferior mirage on another day. Okay. That's the same equivalent. Right. So you're basically going to show us one where the cranes are a little bit warped and then comparing that to ones where the cranes aren't warped. It doesn't really matter because that is an inversion layer above the surface. That's not affecting the surface. It's not, if it was affecting the surface, we would see the actual entire oil rig being warped, but we're not. We're only seeing the very top part of it in the crane. So again, it's a moot point because then you go and show us a whole bunch of things in an inferior mirage and tell us that's the curve of the Earth.
So in the picture that I posted there, the platform that's at 9 miles there, that's on the left, versus the one on the right, which is at 6 miles, you would say that it looks like it's pretty much underwater simply because of some type of refraction that's causing it to sink into the water.
Say probably yes.
Because if there is so much refraction there, I would expect that the platform would look very much distorted, either stretched or compressed in some way. That's causing that effect.
An inversion in air, kind of a waveguide of the image, maybe.
Yeah, but what I'm hearing right now, unless you've spent the amount of time that Paul and I have, is you're just spitballing ad hoc ideas in your mind about, well, if this. Like, get out there and make these observations yourself. And what I think you're going to see is you're going to be blown away by spectacular beauty that you've never really taken the time to appreciate, first and foremost. Second of all, if you approach this with an open mind, I think that you would come away with just as much criticism with the science as Paul and I have. It just does not match up.
Yeah, and so the other day, or let's just go into that one that you showed in the first place anyway. This is really no different than what I was talking about. If you were on the opposite side of that horizon and you were looking at this image, that one that you're looking at behind, this image would look the same. You would be looking at an oil rig closer to you, down low, and the oil rig further away from you, that's on the horizon, up high. It's just perspective. We are looking at perspective. All you're doing is proving my point. This is what it is. This is perspective. Now, what was I going to say? I think I lost it. I went into something else, so I lost it.
Yeah, we don't disagree there. The only thing we disagree about is why that one in the background looks like it's half underwater. I think that's the only place we disagree.
Well, it looks like it's half underwater because the horizon has been moved close, right? That's all it is wherever the observer here and wherever the horizon is, that horizon is now closer to the observer. If you were to move that horizon further away, then now that oil rig out the back will all of a sudden be in the highest position and the one in the front will drop down lower.
Okay.
And the thing is that we don't just have one black swan, right? It's not just like we're cherry picking or like you're cherry picking, because Paul and I and Sky Free and Wide Awake, we can all show you these same effects at every distance from a half mile to 20 miles. What Paul says stands. This happens all the time.
It's really just a function of the horizon and how perspective and the horizon actually work together. So even no matter what, so even if you just look at that picture that you posted, right, we see that little piece of water there, we can still see that ramping of the water. No matter what, you're always going to get this visual ramp, and that visual ramp is caused by your height above the surface. So as soon as you raise above the surface, even if it's 1 millimeter, so you get 1 millimeter above the surface, you now created a 1 millimeter ramp, visual ramp. Okay. And I'm doing visual in inverted commas, right? So you'll now be able to draw a perspective grid within that little 1 millimeter visual ramp that you just created. You'll have an entirely new perspective right there. You could get a horizon at just a few meters away by just raising up like, half a millimeter to a millimeter. You will all of a sudden get a horizon that's only about, a few meters away. And then you could draw a little perspective grid through that entire 1 millimeter of ramping up.
Here's the problem that's undeniable, though. If this was simply what all that was happening, you wouldn't be able to explain why that the brightness of the day is pretty steady for almost the entire day, and then as soon as the sun goes over the horizon, within minutes the sky around it gets darker, and in the wintertime especially within 20-30 minutes it's hella dark. And if
Okay,
this was
hold on,
just and if the
man. Like,
sun
I'm
was just
lost.
being obscured, can I just finish real quick?
I'm
If the
lost in
sun
what you're saying, dude. Like, why are you bringing this up, first of all? Like,
because that appears to prove the fact that the horizon isn't just merely some type of a effect that's being caused
okay,
by
great. Is
fraction,
this
but
coming,
that it is
right?
actually acting as an obstruction to the light.
Right. So is this coming from your mind right now? Have you researched this? Have you studied this? Or are you just spitballing once again? It's
I've
like,
been in flat Earth and done observations since like 2016, so I've been in it for quite a while myself, probably longer than you
okay,
have.
Plus, everybody knows it gets
I go
dark at
back.
night.
Yeah,
This
but
is on the
that's just
coast, right?
attenuation of light, right? That's just attenuation of light.
Yeah,
correct.
but we're talking.
The attenuation of light. The horizon is the extinction of your ability to see into the distance. The horizon can be brought closer to you through refraction or removed farther away from you through refraction. There's no need ever to appeal to anything else other than elevation, distance, refraction, and your 20/20 vision.
But in the flat Earth, the sun is still way high overhead. It should still be
That's
lighting up
got
the sky.
nothing to do with
What
this,
is
man. You're
happening in
wasting
those
your
few
time.
minutes? What is happening
Attenuation
in
of
those
light.
few minutes from the moment that the sun disappears under the horizon? Within minutes, you notice the horizon getting darker and darker and darker and darker. When on the flat Earth, the sun is still way high in the sky. The you can
Okay,
say that some kind of phantom organa is causing the sun to get obscured by the water, but it won't explain why the sky is getting darker like very rapidly within minutes, and within 30 minutes in the wintertime, it's hella dark.
okay. Can you show me
No.
what you're talking about? I mean, I hear your words, but like, show me what you're talking about, man. Because I've
You've never seen a
photographed.
sunset? How long have you been on the earth? You've never watched the sunset and how quickly the
Right.
horizon
See.
gets dark after a sunset? I need to show you
Okay.
that
So.
the sky gets dark after a sunset?
Okay. So is the problem right now the fact that I was just standing out here in New Mexico filling my tank, and the sun was going farther and farther away. It was dark above me, but at the horizon, it was bright white, orange, and purple, and then it started to bleed into the night. So I'm not sure really what you're talking about, because I watched that the entire 10 minutes while I was filling my tank, and the horizon never got dark until the sun finally goes away. But again, it seems like you're just trying to hold on to something that is very simply explainable. And as long as you understand what's being said, I don't really care. But right now, you're just spitballing, saying, I don't like what I'm hearing. And what about this?
That's not true, Jake. Don't take that what he said. You're being honest. You're asking great questions, and you don't deserve the energy he's giving you.
Yeah, but it's still just attenuation of light, right? So the light can obviously only get through a certain amount of, in inverted commas, the atmosphere. In no difference than light going through the ocean only gets down to what, just a few hundred meters, right? The attenuation of light then stops it and it becomes dark. Well, obviously, our air in the atmosphere, in inverted commas again, it's clearly not as thick as the ocean. So it takes a much further distance. But either way, when the sun gets far enough away, it is still going to attenuate that light. And obviously, it's at a relatively or pretty much a very predictable point.
Yeah, the problem is we know from the irradiance, like if you look at the output of a solar panel with a 2-axis tracking mount that keeps the sun's rays at the ideal perpendicular angle to the panel, you will have a complete flat output, which means that the sun's irradiance is constant from, depending on the summertime, it could be from, 9 a.m. to, 8, 9 a.m. to like, 5, 6 p.m., where the output is completely flat, right? And if the sun was constantly moving further away, we would expect inverse square law to apply. So we would only see a peak, right when the sun is at its closest, and then it would immediately fall off. But that's not what we see, right? We see a consistent amount of irradiance throughout the day. And only when the sun starts to get low enough in the horizon where the air will attenuate the light do we start seeing a drop off in the output. Although it's still a relatively small drop off until you really in the last hour, 45 minutes or so. And then the drop off that when the sun goes over the horizon is just incredibly dramatic compared to, and keep in mind, it's supposedly moving away at the same steady rate the whole day, right? I don't think that it's a
You
very
mind if
good
I ask a question
explanation.
just real quick? I'm sorry. I just have one quick question. Are you talking about a sunset when there is a mirage, or a sunset without a mirage, or a sunset with a Fata Morgana? Because I'm a little bit confused because I've seen so many sunsets. I'm not really sure which one you're talking about. So again, would you please show me what you're talking about?
Literally any sunset, as soon as you see the sun disappear, where you don't see a point of light coming from it
Okay, so wait a
anymore.
minute. Again, so any sunset. So you're saying that a sunset with a mirage and a sunset without a mirage and a sunset with a Fata Morgana or a superior mirage, those all have the same appearance? Is that what you're saying?
Well, you can sometimes get you can get some interesting effects right near the horizon, and that might change the sunset time by, uh, a few seconds to maybe a minute, 90 seconds
Okay,
at
I'm sorry.
most.
Maybe you didn't hear my question. Are you saying that you're going to see the same sunset with a mirage as without?
Well, I don't know what you mean by the same. The same in what way?
You
Talking about
said,
the light.
did you not say that all of the sunsets are basically the same? You could just go out and look at any sunset and you could see the sun do this.
No,
Except that's
what
not
I
the
said is that we all experience the same thing, which is as soon as the last bit of light from the sun goes over the horizon, you immediately start seeing within minutes how quickly the horizon darkens. And this is more prevalent in the winter because the sun will have a less of a horizontal track in the wintertime versus the summertime, which tends to keep the sun closer to the, depending on your latitude, closer to the horizon for longer. But if we're talking about in the wintertime here, where the sun has a more vertical path through the sky, you will literally see within minutes drastic differences in how much light is coming from the horizon. I don't think that's well explained by the idea that the sun is simply being obscured by refraction.
Yeah, but we're not talking about the sun right now. You're bringing this up, so whatever.
Yeah, are there any other questions on the actual presentation? I mean, because that's going off into some other areas there. I mean, I understand, Jake, why you brought that up, but were there any other questions that folks had on the actual topics on the presentation?
Negative.
I think Gatebreaker, you had said you had something. Was it related?
I
Was it
have
related?
one, but I'll just type it out to plain truth.
Just
Okay,
make
so
sure you please tag me so I don't miss it. But if anybody, I think I did put in the chat a video that I put together on the horizon, and so I think it's pretty helpful. It's very specific about the extinction of the vanishing point, which happens to be above the horizon when you have an inferior mirage.
yeah. 100% it would be above because the inferior mirage will always drop the horizon.
Looking through
How
that
far
ether
up are you
band.
for your video? Oh, sorry, bro.
Everybody drink.
Whereabouts did you put your video, Travis?
Oh, did you say something?
Yeah, I was looking for your video.
Oh, well, I'm on my phone right now, and so there's the little chat on the bottom. So it's the chat of this live stream. I don't know what else. Like
Oh,
Divergent Droid posted a couple of comments underneath it, so he found it. But you've already seen it, man. You've already seen it.
yeah, yeah.
Yeah, I'll repost it. I just went and grabbed it. I just reposted it there.
Right, yep. Yep, good video. Yeah, this is the thing is that, like Travis has been describing a lot of these things for years and everyone's just been basically gaslighting him. And I would say that we are in pretty much agreement on what's going on. And it's funny how the people who have actually been out there and really gone out and looked, and as long as you go out there and you're not looking with a preconception of it already being a ball, then you can't help but come to the same conclusion. Right. And it's only if you actually go out there looking like, oh, I'm going to proof the globe. Oh, look, see, that thing disappeared once it got to the horizon. Boom, globe proven. End of story. Thanks for coming. Like, that's about as big a fallacy as you can possibly derive. You see something go over the horizon, if the Earth's a globe, you'll see something go over the horizon and disappear. It disappears. So, disappears over the horizon. So therefore Earth's a globe. That's just the biggest fallacy around. What else actually happened? What else could be the story? What else may have happened for that to happen? And I think that I've shown some pretty good evidence for what's actually going on.
Yeah, that like a planar perspective grid essentially accounts for the factors without any actual curve. And it's really interesting, yeah, being able to see it from both, 180 degrees from both ends. But is that, I mean, the way I worded that is that like that a planar perspective grid is all that's needed? Because I know you'd mentioned that during the presentation that there isn't really a need to bring in a curve, even though a curved effect could be interpreted by just maybe one or two parts of it. If somebody just takes one limited component or, even cherry picks one observation to say, oh, look, that's, connected to what a curve would be. But when you, when you actually look at a wide range of the observations and looking in multiple scenarios and being able to identify, the miraging and refractive effects, that really there is no place or requirement to insert a curve because it's all happening within that planar grid of perspective.
Yeah, exactly. So, like I showed, when we have like a really close horizon, our perspective can only go to that horizon. Your perspective can't go beyond the horizon. That's where we'll go into, obviously, and if there's mountains and stuff, then that's your perspective of everything above your eye level. As it gets further and further away, dropping down to your eye level, and due to the horizon being the furthest visual point that you can see the surface, if something now gets far enough away, it's perspectively still going to drop to a point where it appears to be on your horizon, even though it is maybe 20 or 30 miles behind the horizon. It's going to keep dropping down until it reaches the horizon point, because that's still a part of perspective, just as we see an aeroplane fly off and then reach that point there as well. And then it will just disappear from there. So all those things are still going on behind the horizon. We're still having that entire perspective happening behind the horizon. We just don't see that happening. We just see the horizon, and it's like a wall of water or a wall of land that's come up in front of us, and we can't see beyond that. How can you see through water? You can't, obviously, right? We can't see through the ocean. We can't see through land. So once it hits
Hey,
that point, everything's got to drop off.
Hey, Paul, just real quick. One of the things that came to my mind when you were talking was how the horizon with an inferior mirage, if you're out at sea, you can get a boat that looks like it's actually floating above the horizon, right? That's the exact opposite effect of just uh, the horizon itself without mirage, where the perspective requires that it goes lower. But when you have the horizon brought closer to you and lower, then when the target, like a boat, goes into that event, it is also required and bound by the laws of perspective to keep climbing higher and higher and higher, so that if it gets far enough away from the horizon, it'll look like it's floating in the air.
Yeah, it still will to that point, and but obviously due to the inferior mirage and the way that it's mirroring, it's going to start to disappear at a faster rate. So obviously, if the horizon is 3 miles away because of the inferior mirage, well, within just a few miles of it getting away from you, as you know, it's going to start to disappear. But on a totally different day, it may get those few other miles away with no inferior mirage, and you see the entire boat the entire way. So the inferior mirage, from what the way I would describe it, is that because it brings the horizon closer to you, it's still showing us exactly what will happen beyond the horizon with no mirage. It's just going to show us that at an earlier point because it's brought that horizon closer to you.
Yeah, and the video that Geo reposted, I actually have the two comparisons. One of the same corridor with a boat in an inferior mirage, and then another day the same corridor, no inferior mirage, straight down to the shoreline, all the way across, and everything looks completely different.
Yeah, exactly. And I think, like I mentioned to you one time as well, that so when we have an inferior mirage and where we say everything's more stretched or kind of magnified, and it seems to just magnify in the stretched area, but what we're actually getting is everything looks closer, and that's why everyone says that it's sort of magnified. But the inferior mirage seems to, due to it causing the horizon to be in a much closer position to you and having all of that image over that entire distance. So let's say the mirage is at 3 miles and the land that you're actually looking at is at 10 miles. You got 7 miles in between there and there. Now you're actually starting to see that image from 3 miles away. So everything looks closer to you. When that horizon moves to 10 miles away and your perspective changes to everything and everything's got to compress up into that perspective grid, now you see that image that'll compress and look smaller because it actually is further away now because you're seeing all the way to it. Whereas beforehand, your image was starting at 3 miles. Now the image of that thing doesn't start until 10 miles. So you're actually only seeing it at 10 miles rather than starting to see it at 3 miles. Did that make sense?
Yeah, I followed you.
Yeah. Because everyone, like, how we always go, oh, that, when you have an inferior mirage and we go, oh, yeah, the horizon looks magnified. And because we're seeing all that water and we're actually looking at water that's 3 miles away or whatever it is. Like if you're at 6 foot, maybe that horizon's only a mile away rather than 3 or 5 or 10 miles away. So now that horizon is actually only 1 mile, maybe it's even closer than a mile. So you're actually looking at water that's only a mile away. And when we're zooming in with a high powered zoom camera, a mile away is nothing. So it looks really big and magnified. But it is also, I think it actually is also slightly magnified in a certain sense due to the way that the light is now starting to bend at a much earlier rate. I think we also get some form of magnification, whether it be magnification on like is it the X and Y axis, like vertically and horizontally, or whether it's just vertically. Um, I think mainly it's just vertically, but we're still getting some form of magnification when we're seeing closer. It's like it's brought the lens closer to us. And now everything becomes clearer because, as you would probably know, quite often on the days when you have an inferior mirage, it looks really clear. Everything looks like clear and large and it's right in front of you.
Yeah, it still amazes me that we hear this no magnification BS from people who just don't look through the air. But I mean, Paul can show it. I've shown it. I've got videos on it. The atmosphere absolutely magnifies and diminishes, stretches and compresses, brings closer and moves farther away.
Yeah, exactly. And yeah, like I said, it's when we get those inferior mirages, it appears like it brings everything closer because in some way it actually does. Because that inferior mirage starts at only just a few miles away. And like some people, I mean, Sly Sparkane's got a whole video going like where he's on a slight hill and he shows an inferior mirage and he goes, "This only can happen on a curved surface." Well, that's just ridiculous because the air, it's kind of still like water, right? Now, whatever this gravity thing is, that is still going down. So that air is going to concentrate in the little pooled areas. It's concentrating in, if it's on a road, it's concentrating in the dips. It's going to go into the dips and it's going to pool in those dips. When it's on the ocean, it's in the trough of the wave. It's never on the peak of the wave, it's on the trough of the wave. And that's where we're getting the inferior mirage. It's happening in the little pooled sections. And you can see that over a many miles of flat road. We don't get that over, like, most of the time when you get the inferior mirage on the road, you're getting it over that entire long flat road. And then you're getting those little pooled sections everywhere until eventually it becomes one mirage.
I'd like to
Right,
ask
which
something.
To be clear, though, on the globe side, we have never claimed that stretching and compressing on can occur, right? Even going all the way back to, you remember the long range Chicago skyline photos where they said, "Oh, you shouldn't be able to see this from the top of the sand dune," but we can tell that by how stretched the buildings were, right? That there was quite a bit of refraction going on. Our contention has always been that there is no proof of atmospheric magnification in that is commonly used to explain why the sun and moon don't change size throughout the day. It's never been shown, and
we're
Paul
not
agreed
talking
here.
about the sun or the moon, dude. Stop doing this, man. We're talking about looking out to the horizon where the magnification happens. We're not talking about celestial observations. Stop wasting our time.
Are
Yeah, and
those
if we
not
look,
objects in the atmosphere that move into the horizon?
We are talking about objects that both Paul and I have observed out in these observations. Those objects, we can show you magnification of those objects that we are talking about. If you want to start your own presentation and talk about the magnification of the sun and the moon and blah, 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 then do it. But that's not what we're here for.
But Paul just agreed with me that there was no measurable increase in size on the x-axis, so you cannot call that magnification.
I tend to disagree with Paul on this instance because I have certain footage that I feel the magnification happened on both axes. So I stand a little bit off to the side still.
no, well, and like I said as well, that I think that we can get, I'm not 100% sure. It's just, I know that I do have some things where I can measure that the pixels are slightly wider on the horizontal, but for me, it's kind of at a different time. And then there's like there's different shadows and stuff like that. So I can't say conclusive, like 100%. I've got an image where this one is definitely wider than this one. I can show that you will get days where compression happens so much and it really compresses the width of things. And then you could have different width from one to the other. It's just in pure magnification on the x-axis or the horizontal. I can't be 100% on that, so I wouldn't doubt that Travis could very well have things that he can show that.
Just real quick, Paul. Another thing that I thought of when you were talking was to suggest for you that when you go out, get a snapshot of maybe a 53 millimeter or whatever you think the eyeball can see, which is going to be a wide angle horizon shot, right? and then zoom into your target and get your close-up, you're going to see more difference in the positioning on your close-up, but you're going to see the same difference on the horizon position. If you take a shot every single time before you start zooming in, get your what I can see with my naked eye look, wide angle, take that shot every single time, it's never going to be in the same position.
Right. Yeah, I'll have to check that out. Now, I did a interesting one the other day where there's been a couple of times now when I have measured the temperature of the water. So I've got a little setup now where I can do that. So I measured the temperature of the water, measured the temperature about a meter or so above the water, and then measured the temperature where I was on the jetty. And the other day I had it where the temperature of the water, the temperature of the air, and the temperature of the air where I was all the same, 15 degrees. But yet I was looking out at an inferior mirage. Well, that shouldn't happen. It was quite a large, like it was a pretty decent inferior mirage as well. It wasn't small. It was a pretty decent inferior mirage. Now, according to what we get told, that shouldn't happen. The air temperature has to be cooler than the water temperature or the ground temperature to create an inferior mirage. But yet I clearly had them at all the same temperature. And I've actually just recently did one. Sorry, Travis. I just recently did one as well where the air temperature was warmer than the water temperature, and I still had an inferior mirage.
Yeah, I remember watching one of Sky Free's videos, and they did their very diligent, copious microcosm measurements where they took the air temperature right at the surface and then centimeters above, and they showed all this stuff. And the very data that they were showing us about what the air and the water was doing in science, what science tells us, they were capturing the exact opposite. So, guys, look, if you still want to quote Andrew Thomas Young, I don't even know if you belong in this conversation.
Yeah, it's definitely clear that terrestrially, like actually over the Earth, over distance, something different is going on with the light than what we've been told. It seems to be different than what can happen experimentally over a short distance. It doesn't seem to be the same thing. That's why, like for me, I've come to the conclusion that the light does seem to be just traveling up all the time, and that explains literally everything. If we have upward refraction light as the norm, that explains exactly why everything is distant or dropping. It explains why someone like Jaron can film a rocket launch and he doesn't see the rocket until 40 seconds, because the light is traveling on that upward trajectory at 170 miles away. It's still traveling up. That rocket needs to get to a certain point for the light to be able to hit it. It has nothing to do with going over a curve. It's just to do with the fact that the light is actually got an upward bend to it. It's refracting upward. And it seems to be the consistent thing. And like I showed, even from the Canigou observation, where the guy's 1,000 feet above sea level, 330 meters above sea level, and he's looking out and he's got an inferior mirage. Well, that proves that even going up to 1,000 feet, we're getting upward refracting light, which everyone keeps telling us, go higher, go higher. Oh, that won't happen when you go higher. Go higher. Well, how high do we have to go before we're not getting this upward refracting light?
So, how does everyone feel about Paul's rephrasing of horizon rises with the observer? You guys feel better about that instead of saying the horizon rises to your eye level?
Seems like everyone's gone to sleep.
Looks like I killed the show, man. Sorry about that.
It's all right. I probably killed it as well. Everyone's
Yeah,
sick and tired of
what up,
AC.
Copernicus?
What is up, Issa, my king?
Yeah, a long time, man. Fucking good shit. Yo, playing reality. You were playing earlier. Yo, I'm gonna put a link in the chat. I was like, kind of enamored with myself, and maybe I could arm you with this. Here, let me see if I still got it as a link. Of course, fucking not,
Yeah, yeah. If you can relink it, that'd be good.
man. Um, super. Hold on one sec. I don't know how I even. Why would that not have the link? Ah, it pisses me off. Hold on one sec, bro. And it's funny. I used to open up. Well, I'll put the link in the chat. Go to 255 on this link, and it's like the exact moment that this boat goes behind what Globers would call obstruction. I just thought maybe it would be useful to what you were talking about earlier.
Okay, yeah, cool. And you can already see in that picture, right? Your thumbnail. You know, you can see the boat that's closer to you is lower. You can see the horizon line cutting through the sail of both boats. It's cutting through less of the sail on the boat that's in front, like further away. You know, showing that that's climbing up closer towards the horizon. The one that's further or the one
Check
that's
the
closer to you.
check the video at 255, man.
Yeah, cool. I'll have a look now.
Hey, Issa, can you send me that video, please?
Oh yeah, it's in the chat, but yeah, I'll send it to you, bro.
I mean, I don't know. What should I think of the baller science, the globe flake science warriors? Like, I had a question. How do you feel about Paul's rephrasing that the horizon rises with the observer?
What do you mean by that?
Well, as you rise up, the
No,
horizon.
Paul. No. Were you here for the presentation, sir?
Yeah.
Okay, so you already know what Paul means by it because he said it over and over again, and I was listening. So are you trolling us right now, or were you not paying attention? Because it's one or the other.
Well, I think there was never disagreement that perspective is going to make things, uh, rise up and go to the center of your vision, right?
Okay, so my question is, how do you feel about Paul's rephrasing what is typically said when, oh, the horizon always rises to eye level? And Paul's saying, I think it's better to say it more nuanced this way. So what I hear is you agree with Paul. That's what I was asking. Thank you.
No, because the contention has always been that if you live on a globe Earth, then the horizon should drop as you go higher up, and it does in fact measurably drop when you actually measure where the horizon is in reference to horizontal. The horizon does drop. The higher up you go, the further that it drops, and that isn't changed by the fact that your perspective makes you look down, and your perspective means that the horizon
Okay.
is going to appear at the center of your vision when you look down towards the horizon.
Okay, so let me ask you this. Maybe let's work on this, Paul, right? All right, sir. Right? So we're in the ditch, right? We're in a ditch in Paul's helicopter. Your eye level is right at the lip. You can't see any surface except for the edge. And even that, to your naked eye, is kind of blurry because that's just the way our eyes work. Now, That's your horizon. Now, if you were to raise your elevation, that horizon is going to Paul was showing in his presentation that when you do long distance observations and you watch something go away from you, it rises in your field of view as it goes farther and farther away.
Yeah, it's just objective reality. So to say that that doesn't happen is just to deny objective reality. And to say that no, I don't think anyone actually says that it physically rises with you. It's an optical effect. It's an optical effect of that we get this rising, just the same as there is no physical ramping up in front of you of perspective. It's all optical. It's how we see. So in a sense, it is a physical thing right in front of us. So that's how we see it, but it's not physically happening. We know that that horizon isn't physically now at 10,000 feet high. It just appears to be there because it's right out there in front of us. And I've been on probably more plane flights than most people in this chat right now. I've probably been on a plane close to 300 times, maybe more. And I literally look out the window every time. So even the last time I was on one, I'm deliberately sat next to the seat, like next to the window, and where the shutter was, I put myself so that my eye line was just above the shutter, and then I dropped myself down, and as I just dropped below the shutter, there was the horizon. I go slightly above, the horizon disappeared. I go just below, there's the horizon. So it was like right at my eye level. Whether it was like half a degree below that or what, that's irrelevant, right? Because
It is
like
relevant
we've
to the shape of the Earth, though, because on a flat Earth, the horizon wouldn't change
no, well,
where it is in relation to your local horizontal. Like in other words, if you put a copper tube, like a half inch tube on a tripod, and you level it with the spirit level and you look through it, if you're at sea level, if you're right on the beach a few feet above the water, you're going to see the horizon in that sight line when you look through the tube. But as you start to go higher up, even just a few hundred feet up, it will no longer be visible in the tube. You'll have to tilt the tube down, and the higher up you go, the further you'll have to tilt the tube down to see the horizon. On a flat earth, that would not be the case.
okay, let me go into something else. I'm just going to not drop off, but I'm going to go quiet for a moment, and I'm going to show you something else.
Hey, Travis.
What's up, Dan? Yeah, he was just here, but I think he might have popped off the panel. So I think Plain Reality said he was grabbing something to show in a second. How you doing, Dan?
I don't know. I'm a little agitated still, but I'm glad some of it got opened up a little bit. I just think that Jeremy's chronology is wrong when he instigates stuff and then accuses me of being drama based when he's clearly not following your rule of keeping interpersonal stuff out of it. So I'm stuck. He's totally accusing me of being drama based when he totally instigates. Even starts it and continues it while you're relying upon him to mod. He got railed this morning. I hope you heard it. His only answer was to turn me down, not listen. So that's how the gatekeeping shit comes up. It's not fair, but that's how it comes up. If you're relying upon him to do his job, you have a communication problem with him.
The crickets are louder than you right now.
Yeah, and making better impact as well. I can't believe that in this whole group nobody's saying anything. Zanuck, are you listening?
I don't know where Zanuck has been. He would have normally chimed in on a presentation like that, but he's been quiet all night.
He put in hours and hours yesterday, I think.
He was probably not there.
Yeah. Okay. Sorry. I don't mean
Oh,
to
I'm
interject.
here. I'm listening in the background, making sure
Yeah,
you guys
so-
don't get too far off the rails. Protecting my families.
Zanuck, I'm going to have to say you're the best. I just, as far as Globers go, I just think you do it the best.
What about Jake? He's right there. He's my favorite Glober. And you're one of my favorite flat earthers for sure. I just have a picture. He dressed up in some spacesuit going into those old discarded space equipment garage sales and having a heyday. Do you have like one of those things that was on the Back to the Future? The thing that drove the Back to the Future Tesla, or
All right, just hold on, Zanuck. Plain, were you going to show that?
Yeah, I just put something in the chat. Who was the guy that was talking about the horizon not rising a moment ago?
He's gone. He's gone.
Travis.
He's
Yeah,
gone.
I'd like to talk to Travis, but that would be hours and hours of interaction. I wasn't willing to sacrifice my evening for that.
Well, he doesn't usually even try anymore, so that I was interested.
Well, he's been very quiet with a lot of his pictures and experiments. I mean, we've gone through all of them, and there's always explanations for some of the things he's caught some of the best stuff. But the problem's always in trying to figure out why we see what we see.
I think Jake was talking about the horizon, weren't you, Jake?
Yeah, I mean, I think that there's sort of misunderstanding about what we're talking about when we're saying that the horizon doesn't rise to eye level.
Okay,
I think
so
we agree that the horizon, when you look at the horizon, it's always at the center of your vision, and things appear to rise up to it when you're looking below. Things below it seem to appear to rise up to it, like the water line.
That's the perspective argument, though. They kind of confuse the two, right?
Which is just simply a matter of perspective versus the position of the actual horizon relative to horizontal, which is usually what we're talking about when we say the horizon rises to eye level.
It's akin to looking at something on your floor kind of 10 feet away, and why in your field of view, why is it a little higher than looking down at your feet, right? I mean, we all know why, but they use that as an argument somehow with the horizon.
Right. So if you look into the chat, the picture that I put in, which is something that you guys tend to use a lot, and we see the horizon where it is. Take the first one that says at sea level. If the horizon isn't appearing to rise with you, does that horizon appear to be below or above that table?
Where are we looking? I'm not sure.
I just put it in the chat. I don't know whereabouts. So
Well,
not too far
describe
out.
what you're calling the horizon, because there's vanishing points, there's perspective. I suppose the table is glass and causing the mirror effect on the red object.
Well, the horizon is that line that we see off in the distance, the water line.
In this case, the end of the table.
No, not the end of the table. At the very distance, the very far horizon in the distance.
I'm confused. What we're looking at? I'm sorry.
I think in real life it's even more confusing because the mirroring that happens obstructs seeing shore to shore quite often. So
the mirroring is an obstruction for sure. That's another thing people get a little mixed up
So
on.
there's no
totally confused.
there's no
Yeah,
mirroring
you're
in the image that I'm showing.
Oh,
I'm just showing a classic.
Go ahead. I'm sorry.
Wait,
Sorry, I'm
are
just
you
showing a
are you
classic
still
image.
presenting? Because I don't show you as presenting.
No, I'm not presenting. I put it in the chat.
Check chat, Jake.
He's
Hey,
got
which
the
one?
picture
Live
of the
stream
white
and live stream one
thing in
tech?
the red box with
Yeah,
on
live
a
stream
table
one.
that's reflective.
That's something that Gleam posted, though. That's not a.
Okay, yeah. Well, no, we're just gonna go over this. So you see, let's go on the one with the sea level. Now you see where the ocean is all the way in the distance, where the horizon is well
No,
beyond.
what are you talking about?
Are you looking at the same picture?
We don't know. You're not describing it very well.
I
What
think
you
maybe
guys
you
just
didn't post it where we're looking. I think is the problem.
in live stream one, isn't it?
I
Should
don't
be.
see anything from you. The last thing I see you posted was the one with the red liquid in the tube.
Yeah, that's what I'm talking about. Yeah,
Oh,
look
okay.
at
I'm
that.
sorry.
So you see the one that says sea level, right? The one in the top right-hand corner.
Yes.
Where are we
Okay, so
looking
we
at?
see the horizon in the distance back there.
Sure.
Okay, so what I'm saying is the horizon appears to visually rise with the observer. Now, as an example, is that table that it's sitting on, does that appear to be below or above the horizon?
It's below because it's below your center of vision.
Okay, so what it is your vision is above the table and the horizon is appearing to be above the table. Now let's go to the one that's at 365 meters on the bottom left.
Oh, you're talking about the
We're just
flat Earth
talking
for
about how
water
it
level
appears.
horizon thing.
We're just talking about how it appears. So on the bottom left one, you can see the horizon, right? The
Yes, I
bottom
see the
left image.
horizon. Are you talking about the tubes of water? Yeah, the red
So
water.
yep. So you see the horizon there, and all those rocks, the cliff or whatever that is below there, is at approximately that 365 meter mark, right? If the horizon hasn't appeared to rise, why does the horizon appear to be above 365 meter high rocks? Because it's
Well, that was going
appearing
back to
to
the more
rise
simple
with the
explanation
observer.
of perspective I gave earlier.
Yeah, but it's appearing to rise with the observer. I don't care about it rising to eye level. That's irrelevant. It's appearing to rise with the observer because it's now appearing to
But
be
the
higher than
observer's at
360
eye
meters.
level. The observer's at eye level. So you can understand our confusion. And there's no reason to pick apart that language. Your
When I look
observation
at my hardwood floor and where the hardwood floor, if I look at my hardwood floor and and the planks of the hardwood floor and where they end at the wall, where where the molding is at the at the bottom of the floor, and I center my vision on that, essentially making that my horizon. Yes, the entire hardwood floor is below my vision, and the hardwood floor appears to rise up to the edge molding, right?
Which could be a
So
45-degree
what?
angle if you're.
That's just perspective. But I don't understand what.
It still doesn't matter though, right? Does that horizon that you're looking at in the distance, does it appear to be above those cliffs?
Yes.
Okay. So the horizon does appear,
Angularly, yes.
maybe, but the horizon does appear to rise with the observer. Because if it
But not
wasn't,
fully.
then the
That's why
horizon
we
would
have
be
the.
below them.
That's why the two pieces. That's why the two tubes of water kind of show that's eye level when they're aligned, and the horizon is below eye level. And yes, there
Well,
is some proportionality of positions in your field of view, such as the rocks and the water in the distance. And even though that water in the distance is uh, supposedly flat, we have the rocks that are above them, 325 feet. But why is the water above the rocks? That's what you're kind of saying, and
okay.
that's a perspective argument. It works either on a round or a flat Earth, but we get into the nuance of the flat round debate is why it doesn't rise to eye level. That's why we get into anything other than that, we start going down a rabbit hole of just terms and understanding of why Jake's hardwood floor goes to the corner and he has to look up by 45 degrees versus his toes. Why is that? Oh, that's a perspective. That's an angle issue. It doesn't mean that it's an optical illusion or anything. It just means that that's how geometry works.
Yeah, for
I
sure.
don't know if
I
that's
agree with that. But the thing
yeah.
is
I know
that
you do.
also
Yeah.
this classic observation here that we get shown, this classic meme. Okay. Now, if you actually look at the one that's at 365 meters, the one that says it's at 1,200 feet, those two red lines don't line up. They're not actually at the same level. So this person who's actually there with the camera is actually below those red lines.
Why do you say that?
Draw a straight line across those two, um, the two red lines there, the two things. They're not level. They're not at the same height. You can clearly see it. The one
To
that's
me, it
at
looks like
sea
they
level,
are.
that's closer. Well, okay, I've got another one where I'll post another one where I've actually like drawn all the lines on
The
it. It's
1,700
not
meter
level.
one,
It's not.
the 1,500, hold on a sec. Your 5,600 foot versus 1,700 meter one, that looks like it's a little lower. I mean, they're trying to get it close. They're trying to get to the point where this is roughly a straight line, which is eye level. And even though they're a little off, the horizon is well below. I think you're getting a little bit too technical on whether the two red fluids are perfectly straight
Yeah,
line
but
with
that
you, the first one and the second one. The whole idea is that if you're looking at something that's at your eye level, they will all be in line. If they're not, then they're not
uh,
directly in line. Even still, it's above the ocean.
but like I've said in my presentation that I just did, if you're 1,700 meters above the surface,
Hmm.
that horizon is actually technically 1,700 meters below you. So when you're looking dead straight out, you shouldn't expect to see it perfectly at eye level. So when people have said eye level, it's
Oh,
because that's the way that it has been referred to over the entire millennia. It has always been referred that the horizon rises to your eye level. It's only since this whole flat earth discussion where people started going, oh, it's not perfectly at your eye level. Well, no, because if you're 1,700 meters above the surface, the horizon is actually 1,700 meters below you. So if you put something there like a satellite, of course it's going to be
You
below
know
that.
why it's mentioned though? It's mentioned because we're expecting to see the drop of the globe, and we don't. So
well, I
fussing about the words doesn't
well,
produce the drop.
if it does rise to eye level, and it will be at eye level angularly, even though it is 1,700 meters or 5,000 foot,
Yeah, and
500
even
foot
if
below.
it's roughly, it's only
Yeah, but
roughly.
I don't know. I really have a hard time understanding where you're coming
He's
from.
not
I'm not
making
going to
a
even
point
get.
at
Wait,
all.
hold on, Dan. Hold on a second, real quick, please. I think if we had unlimited vision, yes, this horizon wouldn't it just be like a blurred area where we can't see anymore, but it would be roughly at eye level. And if we don't want to even deal with that, all we have to do is pick a point that we know how far it is away, like Catalina Island or something. Is that where it should be angularly below level? And that's something we actually can measure and know whether that is geometrically where it should be on a
Okay.
1,200 foot cliff or a 5,600 foot cliff. We can do that math. That's why I like using those kind of hard numbers rather than this possible delineation like the ones I show of the aircraft at 45,000 feet, where it's the horizon between the sky and the surface is 3 degrees below eye level. Now that couldn't happen on a flat Earth. And then we also have the sun and the moon below eye level too. So we know that even if it's flat or round, or if it's flat, we know that the sun and the moon cannot be below eye level.
Okay, but so what you're saying, and because like if we were looking at this image, right, this meme, can you tell me whether or not that the horizon that we're looking at in the distance there is an inferior mirage? Can you actually tell me exactly where the horizon is? Because it's completely blurred out in both of the bottom images. In
Correct,
both
but
of those bottom
we do
images,
know,
it's blurred out.
we see light and sky well above it. So we know that even though the horizon could rise and may be there due to being blurred out or by clouds or whatever, we do know that we can see the horizon or the line of those of the. It's still kind of blurry in that picture to do this. That's why I like my picture better of, a true sky and ground picture, and you know that it's sky and ground. There's nothing blurry behind it because we see a sun and a moon underneath level as well. So then we know the surface cannot be at eye level because the sun and the moon are there, or they should be.
It's the Zdenek makeup
in
shit
this-
hour.
Yeah, yeah. In this, can you
You,
tell
what,
me
you really
whether
think
or
it's
not
makeup
those
shit?
two
Here, let
bottom images?
let
Oh,
me
sorry,
put most.
Zach.
Maybe we can talk about my picture real quick because I'd like to hear your perspective on it. Actually,
Okay, but for those two bottom images of the red tubes, can you tell me whether or not they're inferior mirages out on the horizon? Can you tell me that?
yeah, the bottom two, yes, because I can
You can
see.
tell me whether or not
I
they're
think
inferior
I see
mirages?
Catalina in the background.
If you say Catalina one more time,
Isn't that Catalina?
But my point is that you cannot
no.
tell whether these are inferior mirages in the distance because there's nothing to tell that. If we have an inferior mirage in the distance, that is going to drop the horizon.
You're right, and that is now even though you see Catalina, you're right because there could be this land that goes off into the distance and you can't see where it meets the sky. You're absolutely
No,
correct.
because then the inferior
But that's
mirage will drop
why
the
my
horizon and make
picture
it
will
seem.
kind of fix that problem. Let me put it in the chat for you. So I'd like to
Well,
talk about it.
even
And see what your not objection, but what your thoughts are on it.
did you see
Okay.
the last part of my presentation, Zanik?
Um,
Which went over I completely went over the oil rig observations.
no, I wish I didn't miss that. I wish I'd like to have heard that. Can you give me a summary? But let me just give you this picture here. This might be a good one for you, and you can tie that together with what you presented. The picture I just sent you.
Yeah.
Okay, so that's a picture from 45,000 feet, and we have the level line, which is perpendicular to plumb, and we have a moon below the level line. We also can see the ground, and there's a gray area where it could be this land getting blurrier in the background. But we do know, even if it gets blurry, we do know that the horizon is not ever going to rise to eye level because we have eye level there, and we have the moon clearly in a spot hundreds of thousands of miles away. That is purely visible.
Ask Zdenek to define what perpendicular means.
But also, I want to
Particular
also
is
say, well, you're
an
actually
angle.
you're 40,000 feet above. See?
45,000 feet. Here, another one real quick, just so you can have
Okay.
a
So
good solid
technically, no
picture.
matter what, that horizon is actually 45,000 feet below you.
Yes,
And like it's at least 45,000 feet below you.
correct.
So,
So
and
why is it?
now you guys are also, you fly at a 3-degree angle, right?
That has nothing to do with this picture because that heads-up display, whether you're in a climb or in a dive, will always show the level line. People confuse, and you might be doing the same thing. You might be confusing the artificial horizon, which is always level, and they call it the artificial horizon, but they do that loosely. If you're an aviator, you understand this very well because when you look at this picture I've posted, which is the level line, that same picture would correspond with a horizontal reading of your artificial horizon. That would be dead nut center, the directional dot between the sky and the ground, but it's a representation. The HUD display shows the level line and your direction of travel, whether your nose is going down or in this particular case, the direction of travel is not nose high. So the direction of travel is exactly at the level line in this particular case.
But the other issue that we actually have
Well,
is
actually, no, it's a little higher. Sorry, it's a little higher. There is a W, which is it's about 1 degree up, but that doesn't change any relationship between where the ground is and the level line, which is clearly 3 or 4 degrees below eye level.
Yeah,
That make-
I never doubt that it would be below or can be below eye level. And like I was saying before, I've been in a plane many times where the horizon is right at my eye level.
Never. You'll never see that
Yeah,
ever.
yeah, 100%.
In a
I
million
was
years.
just on one 2 weeks ago, 3 weeks
You
ago,
didn't
day
you
before.
didn't use the right tools, my friend. It doesn't happen.
Well,
You cannot see the
what I
horizon at eye level.
what
It's
I
not
used
possible.
what I used was the shutter right next to the window, and when my eye was right above the shutter, I couldn't see, obviously, the horizon. The moment I dropped my eye just the tiniest bit below the shutter, there was the horizon right at the shutter level,
That's not
right?
that's a flat Earth.
So
That's a stereotypical flat Earth type of test. That's like you almost
that's
akin to using a carpenter's level and say I'm
yeah.
flying level, and that for the Earth is not
But
curved.
either way, that's right at my eye level, right? That's where
No,
my
it's not
eye
at your eye
saw it.
level.
It's right
It's
there.
not. If you had a carpenter's level and you're able to shoot it out, extend it out your window, like what you're kind of doing with the shutter, you would find that it is below eye level by 3 degrees, a
Right.
whopping three, a very large margin. So that's incorrect. But I'm curious as to your presentation. So I'm
But
getting
even
more
if
of a
it
feel of
is,
what you're talking about here. What was your explanation or your presentation? I mean, is there a way I can go back and watch your presentation somewhere? Is it recorded?
It's
it
on the
should be
live
recorded
stream.
on the live stream, yeah. So,
Okay, I'll go back. I'll make sure I go back.
um,
What
just
what
the
did
last
you?
part, if you don't really wanna go over the entire first part, because it was, probably close to 3 hours all up,
Yeah, it's a
but,
little much for me. But I mean, when it comes to the oil rigs, I always show that picture of the two that are in a succession, Habit and Habitat, and the other one.
yeah.
Um,
Uh,
one's
Basically, it's all
9.6 miles, the other one's
yeah,
4.7 miles. And when there's a picture of them, the roof lines in line, how is that possible if they're the same height above the water? Yet from the observer, which is supposed to be 1 or 5 feet off the ground, how could they have the roof lines align unless they've been loomed up by bending of light downward?
okay. So, when it comes to perspective and the way that perspective works is that, like, when you have perspective and the horizon, the way that they work together, when you have an extended horizon and now the horizon is at that, what did you say, 10-mile mark?
I was only talking about the actual objects themselves, not the horizon, because there is some
No, no, no,
fog
no, we need
and,
to
and
talk about
fog
the
banks that
horizon
were
now. So,
mistaken as horizons, by the way. But yeah, I'm talking only the structures themselves.
okay, yeah, but I need to do that. So
Why?
it was 10 miles away, was it?
Yeah, nine
The
point
the
six
back
or
oil
something.
rig?
Yeah.
Okay, so now we know that the horizon is now moved to a position at around 9.6, maybe slightly further, right? So
Actually,
the way that
okay.
the way that the horizon and perspective work together to give us the world that we see is that when anything that is on the horizon is in the visual highest point. That's the furthest point that we can see the surface. Now, in that first one that we actually that you show, that's actually in an inferior mirage as well. So that
Which
inferior
one's this?
mirage
Which one did I show? Which one?
in the one there's the two images, where there's the two oil rigs,
Okay, let me
right?
put that real quick so I can look at it. You can give me some details on how you're interpreting it. Hold on. Uh, more rigs.
I think he's making assumptions so that the water line's visible, and I think what you and I are going to talk about is the convection and scintillation that prevent
Well,
the water line from being visible.
let's talk about that because we have it there, and there's a good picture of it. So, and you are who am I talking to? I didn't have your name.
Plain reality.
Plain reality. Okay, good.
Cool.
I thought so. Okay, there. So plain reality. There. I'll tag in that. So when you look at that picture, describe to me what you think we're seeing there.
Okay, what we're looking at is we're looking at one oil rig on the horizon, right?
Um,
And the top image, the oil rig is on the horizon.
but where's the bottom of it?
What do you mean? The bottom of that first oil
The
rig?
bottom of the oil rig. Yeah, there's a structure about 50 feet of structure that's missing, or 25 feet. Probably 50 feet of
That's
structure that's missing.
that's the back oil rig. Hold on, let's go through the front oil rig first.
Oh, the front one. Okay,
So to
foreground.
the foreground.
The oil,
Okay, so
the horizon is right about there. Yeah, I mean, probably good approximation. I think it's probably right there.
it's
As
it's
I know
close.
there's things
It's
on that structure because I've been out there that there's some cross members that are usually a lot higher above the surface than I can see them proportionally. So I'll give you that. It looks like the horizon is right there. Go ahead.
It's
Which
probably
shouldn't
just
be there, by the way.
it's probably slightly behind the horizon, I would say. Right.
No,
So
there's stuff that's
this
missing on
one,
that.
this
But
one
go
here,
ahead.
I
That's
think
fine.
this is a different image. I don't think this is the one where it's in an inferior mirage. But okay, so this top image isn't an inferior mirage, I wouldn't say. By looking, I'd have to have a really good look at this one. This is a slightly different image than the other one. But the horizon is the furthest visual point you can see the surface of the water or the ground. Would you agree to that? You can't see the surface of the ground beyond the horizon. That's the furthest
No,
visual
yeah, you
point.
cannot see the surface of the ground beyond the horizon. Correct. That'd be a fair explanation.
Right. So when we have perspective, we can only draw our perspective to the horizon. And if we were to have a perspective grid, now that perspective grid can only go to the horizon. It can't go past the horizon. Could you agree with that?
You keep talking about the horizon like it's a thing. The only horizon in this conversation is the apparent horizon.
I want
know
to
that.
hear his thing. So, okay, I'm trying to give you an
I know
answer
that.
to. I said so. When we talk about the grid, is this a fair example of the grid here?
Okay, yeah. So we can just go by that, right? Now, let's just imagine that. Let's say the red one and the blue one. See your little red thing, and then your blue one at the back.
I get the red structure and I got the blue structure way in the distance. That's higher. That looks like it's filling the ceiling.
Yeah. Let's just pretend that these are the oil rigs. Now, this is the oil rigs on the bottom image. Your bottom image, the one that you posted. Imagine that's the
But
bottom image.
we know from this picture though the blue one has to be twice as high as the red, and twice as high as the orange.
Yeah, we're just going by looks at the moment, right?
Okay, so by looks.
Now,
Okay.
yeah.
All right.
Now, what we're looking at here is the oil rig. The horizon is going all the way to the oil rig at the back. Let's say that blue line. The horizon's going all the way to the blue line right now.
The horizon's
That's
going
for
all the way to the blue line.
That's for the bottom image. That's the equivalent of the bottom image, where the horizon is going all the way to the back oil rig. Right?
Okay, but it cuts the horizon goes all the way to the blue, the farther oil rig, but it cuts it in half, right?
Would you like me to share screen and then I can actually show you?
Yeah, probably should do that.
If that's cool. Does anyone else mind if we do that?
Unless you can explain what you're talking about.
Well, he's trying to, and he's got an interpretation of perspective that is a little different than we're used to hearing. So I'm interested in hearing it, and I think I know where he's going, but I'm not sure. I'm trying to find because I know how perspective works. Perspective is really simple in my world. It's just trigonometry, perfect, absolute mathematics, geometry. And somehow I think there might be a gotcha in your presentation, or that somehow we're not able to see things because of perspective. And that's really not possible.
There's no gotcha. Yeah,
that's where I'm thinking. I'm not going to prejudge it until I hear your.
You would really need to watch the entire presentation where I prove that you have perspective going on both sides of the horizon.
All right, well, then how about this?
Watch the entire thing.
Well, I just want to hear an argument from you, if you can just articulate this. Why, if we are the observer at sub-5 feet, which means everything like that box I showed you with all these little bars and arrows and things and colors, shows that everything below eye level will rise to eye level in the distance. Everything above eye level will come down to eye level. Why is the bottom picture of those oil rigs with the red vertical lines? Why is the bottom picture show the roof lines roughly aligned, even though one is twice as far than the other? How is that possible?
Well, I'd say that would be refraction.
Not because the earth is flat?
We're talking refraction over a long distance now, aren't we? Right. So
yeah, but
we're not just talking a perfectly designed thing where we can go, this is how it works in a perfect world where there's absolutely zero refraction and we draw this.
Okay, so you're saying because this is good information. So you're saying that that's actually higher than it should be due to refraction, which is a good concession. I mean, it's logical.
Can you see my share screen?
Hold on a second. Same. So part two of my question, to be very short, I'm not going to go back and forth. I just want. I'm liking your answers. So I would agree. I think that's possible. So what happens on the top picture where the oil rig roof is half as high as the structure? Really, the roof is at the bottom of the structure before the support pillars. So why is it half missing by the horizon? What happens there?
Okay.
Is that also
I'll explain.
refraction, or is that something else? Is that perspective?
That's got to do with perspective and the horizon and how they work together.
But what if it's
Can you see my screen?
um,
Can you see the share screen?
yes.
Okay. So here we have a sort of basic kind of perspective grid. This is the horizon here. You can see where I'm pointing to.
Mhm.
Okay. Now, if we move that horizon closer to us, everything in the distance will disappear, right? Because
Right.
now the horizon is the furthest visual point that we can see. We can't see the
Mhm.
surface beyond the horizon. So if we have a horizon that's further away, we see that horizon in a higher position and we see further. If we then move that horizon into a position that is closer to us, we now do not see the things, or the things that are in the distance appear to
And that
drop
could be a
below.
fog bank that could do that. That could be a fog bank or some type of a
Well,
refractive
it's
element that actually created a inferior mirage that could do that. Would you agree?
well, it won't just necessarily be an inferior mirage. I mean, it's some form of it's a refraction which brings the horizon closer to us and further away from us. Right. So then let's just say we were to get the horizon and it moved into different positions closer to us. We are going to experience a horizon closer and closer. Right now, if we have a horizon that is closer to us, it is going to appear to drop within our vision. Right. So because as we bring the horizon closer, it's going to appear to drop. Let me just do this so you can see better. Now we
Well, I
have
think I
our
have a hard
cursor
time
here.
calling that a horizon if it's not a horizon. It could be something that's been blocking it, some optical effect or a
Well, it
fog
could
bank,
be
for
an
example, is a good
could
example,
be
right?
we're not worried about fog. We're worried about it could be an inferior mirage. It could be all kinds of things.
Fog bank, something
It could
blocking
be
it,
the
right?
position in between an inferior mirage, right? Because when you have an inferior mirage, as the inferior mirage is disappearing and the horizon is extending due to the inferior mirage going away, we will see that horizon appearing to get a little bit higher and higher. And then when the inferior mirage disappears, it's now at a sort of further visual point. And as the conditions change even just a little bit more, we see the horizon continue to extend further and further away. Right? So what we have here is the difference between a far horizon and a close horizon. So your vision can lose. You can lose vision because the horizon is now closer to you. Now I'm going to explain this a little bit more, so just bear with me. Right? So this is, don't worry about that bit there. Here's where I show how even from 300 meters, right, we can get inferior mirages, and inferior mirages drop the horizon. Right. So this is the way that both people see. Both people are looking at perspective, right? So let's just imagine that's a horizon line in the middle of these two people at the bottom of the image. That's a horizon line straight in the middle of them. They are both seeing a horizon ramping up to them. So they're both seeing that top image. That's what they're both looking at. They're both looking at a perspective grid in front of them, right? Because perspective will have the horizon rise with the observer right up to the horizon, and the horizon is the furthest visual point that you can see. You can't see beyond the horizon. I'm just going through this quickly with you.
Go back to that picture. I think there's a bit of a problem with that. So,
Yep.
how far are these people supposedly away from each other?
They could be whatever distance away. They're equal distance, and let's just say that they're 3 miles away, or they're 6 miles away from each other, and there's a 3-mile horizon. So they're both looking up at their own perspective grids.
But you have that line driven at eye level. And you're saying two people can look at themselves at eye level and not see each other due to what's blocking the vision?
The perspective grid, they're
We
being blocked by perspective.
we
No, if
need
you
to
had
start
no fog,
utilizing
no
angle
obstruction,
of incidence. Angle of incidence.
there
Start
is no
using
angle of incidence.
the point in which the light is hitting the eye of the observer.
There is
When
no
we're
angle of
starting
incidence.
to
It'd be
okay,
directly
never
zero.
mind.
At
Let's
zero,
just
there's
keep
no
going
angle of
with that. Go on
incidence.
mute.
There's no angle of incidence at zero. That's what
Okay,
it means.
so you see these two different observations, Zanik. of this same thing, same observer point, same observer height, and we see two completely
Play it
different.
again. Play it again real quick. I want to see it. I want to see what we're looking at here.
It's all right. I'm going to go through it. Don't worry. So
I'm just trying to mentally catch what I'm saying. Can you go slow? Do it again.
that's all right. We'll go over it. So what we have here is this difference here between the height. One horizon is down lower and the other horizon is up higher. So what we're actually looking at there is distance. So this horizon here, which was this image here, that is a 3.6 mile away horizon. This image here is from 25 to 30 miles away. That's the land that I'm looking at in the distance, which is 25 to 30 miles away. So when we're looking at this, our perspective grid now goes to 30 miles. And when we look at this one, my perspective grid can only go to 3.6 miles. So everything else in the distance cannot be seen. It's going to drop off. We're not going to be able to see it.
But here's the problem, Paul. We know that if we set up a camera at the same focal length and we perfectly level the camera, we know that if we take it up higher up, if we take that camera and we take it, we dig the poles of the tripod right into the beach, it's only like a few feet off the water, but it's level. We take a picture and then we take it up to the top of a 10,000 foot mountain and we set it up looking over the water. There's places like that in California that you could do that. And then you take that picture with the camera level, the horizon in the higher picture where the horizon is going to be like, whatever it is, 60 miles away or whatever, is going to be lower. And the picture where you're on the beach where the horizon's only 3 miles away is going to be higher, which is the opposite of what you're showing us here.
Yes, that's true.
Right. Well, I mean, you've got to go out and you've got to take those photos.
Yeah, I've had taken those pictures before. It's not. We've done that research, and you have some good research pictures here too. I'm curious as to why that structure. I'm curious as to why that structure. Sorry,
I'm trying to sort of answer. Sorry, bro.
I'm curious as to why that structure has these. I don't even know what that thing is. Some kind of platform has these windows or these slats or pillars beneath it. And yeah, why is that the windows? Why are they all visible in one picture and not visible in the other?
Tide.
Pardon me?
Tides. It doesn't matter.
I was going to say tide.
Yeah,
now we have coupled in your situation. We've now looked at 2 days, two different times where the tide is 7 to 10 feet higher.
No, it's only about 4 feet higher. Would you like me to get it where the tides are exactly the same, and you'll see the same effect? It doesn't matter.
Well, that'd be probably the best thing to show us. Right?
The tides are irrelevant, right? I can show you 70. I could probably show you about 80 days of this.
I'm not sure, Paul, but if you tilt the camera, depending on where you tilt the camera, you could have the horizon be at the center of frame no matter how close or far the horizon is.
Correct.
Tilting the
That's the problem you ran into when you're on the airplane, Paul. You can't look at a visor and say that I've aligned myself level just by looking with the visor of the window. That's not how you make things level. Yeah. And what you're doing here is similar to what Jake just alluded to. You can't just have something center of vision and say that's level.
Well, the camera has been leveled.
No.
I'm looking at it at the same thing with the exact same camera height every single time.
But how do you know whether the camera is being dipped, half a degree
level.
or a degree? Unless you have that camera on a tripod and you've leveled the head of the tripod with the spirit level to make sure that it's perfectly level between these shots. You have no way of knowing whether that camera is now looking down into the horizon half a degree or a quarter of a degree or 2 degrees.
If the horizon's apparent,
irrelevant.
If the horizon. Yeah, if it's apparent, why is it impossible to be at eye level?
Because there's no optical effect that can loom up.
I didn't say that it's impossible to be at eye level. Because right here,
Zanuck was saying that.
The horizon.
No, I didn't say that.
Zanuck was saying earlier that it's impossible for it to ever be at eye level.
So yes, the horizon can certainly be at eye level, absolutely, positively, and it can be done. That for our hold on, I'm almost done. You can
No, that's
have
it.
that
That's all I
happen.
need to hear.
When you have refraction that looms it up, it can be actually above eye level. And the way
Yeah, I
you
was
test
confused
for
because
that, hold on,
earlier you said it couldn't be.
Paul
Yeah.
and you, what you're talking about, Pure, you can figure out whether it is above or below eye level actually by going up in elevation and taking different measurements. And what you will find is that you will see that that bottom measurement, even if we're flat or round, is incorrect due to looming.
Xan, you
He
answered
also
the
agreed.
question. Like I don't need to talk it
Normally
down
goes
and
that
try to
way.
explain
Normally
I'm
something
not
to
goes
me.
talking down. You just we know that
Yeah,
Problem
things
is,
just
are
Zach,
at eye
let it
level
go
that
forward with you and the other guy. Like I don't need
okay.
any more. Like I'm
All
good.
right, go
Thanks.
ahead.
I appreciate it.
the problem that you have, Zanuck, is that even when you're looking out, for starters, you can't tell me when you're looking at your aeroplane from your aeroplane how far that horizon is.
Yes, I
Like you can't
can.
tell me that. No, you
I
can't.
can. Absolutely
But you
can.
can't. No, you
But I
cannot.
can.
Because you don't
So
know.
there are certain things that are close to the horizon, maybe fractions of an angle. I can see 100 miles when I fly an airplane, and I should be looking down at that particular airport at 1.5 degrees, but yet we're looking down 3.5 degrees. So I mean, or not maybe 3 degrees or 2.7, something greater than we actually see. So why is it we're seeing too far angularly, not distance wise? Because the curvature of the Earth is allowing that surface to drop away from us because it should be at 1 degree. It's dropping to 2 degrees. Probably a better example at maybe 100
So
miles.
can you show an example of where you've actually got images from a certain height and you have things in the distance that are on the horizon? Then you can say, I know that that particular point right there is at 230 miles, and that's exactly where the globe says my horizon should be. Can you show us an image of that?
No, it's impossible.
The image I have to show you, you can extrapolate a lot of
Can you
this.
show us
This
an
question can
image
be
of that?
answered by several pictures, just by, for example,
Okay,
this is
but
a good
no,
picture
what I'm
that you can.
asking you, can you show me an image of knowing something at a particular distance and
Yes,
you're at
I had an airport that
45
we were
feet?
flying to. It was 100 miles away. That was right at the horizon. Maybe it was maybe it was right at it, or for all practical purposes, is right at it. Now you can argue that that's your gotcha, but it's not. It was right at the horizon. It was 100 miles away. Forget the altitude. And I took a picture, and I can't find that picture to save my life. It was at night, and I took a picture, and that tower was blinking. You could see it. I was looking through binoculars. You could see it flashing green and white. It was at the horizon. Now it was at an angle down of 1.5 degrees or something, or 2 degrees, and it
Okay,
should have
and
been at 1.5 degrees.
how are you determining the difference between refraction dropping that image and globe dropping that image?
Good
Because
question.
because it should have. Are you saying that it was it was um it was one? We measured at 2 degrees. So you're saying it was sinking refraction from
No, what
40
I'm saying is,
30,000 feet. We have sinking refraction. We have an angle
what I'm
now that's
saying is,
more positive. We have a now positive angle of incidence, more positive, and as you go higher, that angle of refraction will be less.
you're still
Sinking
looking through.
refraction makes us see further on the globe. So his
No,
question was, yes, sinking refraction makes you see further on the globe. It raises things up and you
no, it
see further.
doesn't.
What do you mean
No, it
no?
doesn't.
What do you mean
Sinking
no?
refraction is light bending upward. The
Which
only way you
makes you
can
see
have some.
further.
You hear my measure? I measured 2
You're
degrees.
still wrong here,
It
dude.
should
It's
it
still
should have been
sinking.
1.5 degrees. So it was sank. We look at the oil rigs. The reason we see farther is because they're now higher than they should be. It's a positive angle above eye
Okay,
level in some cases. That's
okay, so
looming
can
refraction. That
we?
means light is bending down. You guys are confusing light bending down from
No,
light
no.
bending up.
Uh,
Okay,
It's
oh,
a
you,
serious
my
step argument.
apologies. Thinking refraction, you're talking about the effect. What I meant was light bending up, which makes things up here lower than it is. For you,
yeah.
when you're saying
Yes,
sinking refraction, you're meaning upwards refraction. Upward, yes. Okay.
upward refraction.
Okay. Okay.
Yes,
Okay. All right. That's
uh,
it.
Okay,
the light
so
bending
the
upward. So I
but
don't.
the point is,
There's no
though, Zanuck,
conditions where that can happen.
you can't
Especially if you're in an
prove.
airplane, you're so high and the air is very thin, and due to all the things we know about refraction, there's less atmosphere. Of course we're seeing farther, so that's one thing in your corner as far as why we would have refraction but more looming refraction, not sinking refraction.
Well, no, because you don't know that. Like until you actually get out
We
there and
do
you
know
test it, you
that.
don't know it. right?
Okay.
So
How about
what you're doing?
you know
Hold
what?
on, Zanuck. Let someone else speak for just a second,
Oh,
please.
you
Zanuck.
just say the word.
For
I'll
a
let you
moment,
speak. I'm sorry. Go ahead. Go
right?
ahead.
Just for a moment, right? So when you're looking from 30,000 feet and looking down to the ground, you are looking through all the deepest layers of refraction, right? You're not looking straight ahead. You're looking through the thickest layers. You are going to still get refraction, right?
I didn't
So
say you
you
don't
don't
remove it all. I
know.
said you have less of it.
Well, not necessarily, because you're looking through the deepest layers, right? You're looking
Well, it's not a
right
matter of
through the
looking through the
deepest
deepest layer. You look
layers.
at the deepest layers looking straight down, right? They're looking directly through the deepest layers.
Yeah, but
You
you're looking
are,
across.
to your
You're
point,
looking
to your
across the
you asked me a
thicker and
question, I'm gonna
thicker
answer
and
real quick.
thicker and thicker.
To your point, you because you're higher, you're seeing farther, so you're looking through more total atmosphere. I would give you that, yes. But the problem, you got to look at what percentage of the atmosphere has the density gradient that you're looking at. It's all a gradient, but it changes more radically as you go higher. There's more change. It's exponential as you go higher. The
Yeah, but the
atmosphere, the
only evidence that
density.
we've ever seen of light bending all shows light bending up. Yeah, terrestrially, over the Earth, not over a fish
No.
tank.
Yeah, light
Yeah,
bends up. Light bends up?
yeah.
Really?
The
How
only
does
thing
light
that
bend
we've
up?
seen, the only thing that we've ever seen through people who have shown multiple laser tests, when the light bends, it bends up. We've never seen
Where?
a laser
Where have
bending
you seen
down.
that? Where have you seen that?
Seen that dozens of times.
Are you talking about the pictures where they show it over a lake and it's going over their head, looks like it's bending up? Is that what you're talking about?
There are multiple where the
I'm just
laser
trying to get a
is
flavor
showing.
because if you're thinking of those pictures where you're seeing the light bending up, that's an optical illusion. That's not light bending up. It looks like it's bending up, but it's not. It's
King.
kind of like looking at. Hold
No,
on, almost finished. Almost
there
finished.
are some where the
Play,
light
hey,
is
oh, come on, Paul. Paul. It's very akin to um, crepuscular rays. They look like they're converging, but they're not. Same kind of effect on your eyes.
yeah, but the
The
problem
things you
is,
saw as
Zanuck, is
lasers
that
are not the lasers bending up, by the way.
there are ones where the people are looking at downward upon the laser and you see it bending up. They're above the laser, not below the laser. Looking from the same side as the laser and you see the laser bending up.
Yeah, that's called the looming. That's light. That's light bending
No,
upward. I agree that light
that's
can
not
bend upward.
looming. That's the opposite. That's upward refraction.
No, no,
Looming
you're
in
seeing.
your world is downward refraction, not upward refraction. So you need to
No,
prove. So what really needs to happen, right? Just hear me out for a second. What really needs to happen is that someone needs to get 50, 100 feet above the surface, shine a laser dead straight across so we can actually see, get high enough so that when that laser starts to bend down, we'll be able to see that laser bending down.
you see how
Right?
you're confusing the refraction cost. So if you had a laser, if you looked at these oil rigs and you saw the one that's above eye level, it actually looks like the Earth is concave, right? You agree? If we shined a laser,
No.
we would see it look like it bending up. That is actually downward refraction. The reason that the laser would go up and hit from eye level, you hit the top of that roof at that oil rig, it looks like it goes up because it is going up, and that's downward refraction. You're even confused with it.
No,
Can
down
we remain
upward refraction
consistent
sinks things.
to
Upward
help everyone,
refraction sinks.
including ourselves? Can we be consistent and not change downward refraction and then say a sinking refraction next second? You
Well,
see
I
what I'm
guess
saying?
I use that vernacular because I think it's correct. Because when you have sinking refraction or looming refraction, the cause of looming refraction is downward bending light. The cause of sinking refraction would be upward bending light. Now, just because you
No.
see a light source bend upward doesn't mean the light is bending upward. That's not really what's happening.
It's
You
not
Upward
may
that you're
refraction.
wrong. It's just that
intuitively you think it's happening. That's
it,
not happening though.
it's not that you're wrong. It's just that the down the changing the words of direction in one sentence to the next while inferring the same thing. Let's just use the same words.
All right.
Upwards refraction, downwards refraction. Let's not say downwards refraction and then say sinking. It's just confusing.
Uh-oh.
Yeah. So upward refraction causes things to appear lower
Yes.
in the distance. All right. Now, I would say that we are always getting upward refraction. And when we're getting things that are now appearing higher, it's just because the light is traveling further in a straighter direction further. You want to say that what's going on is now the light is traveling around a curve, and that's why we're seeing further.
Well,
I
it
would say that the light is
doesn't
traveling
it tries
straighter
to.
for a
It
further
bends
period.
downward because we know that the differential form of Snell's law is the law that tells us if we have a differential medium and an angle of incidence combined, which is in the differential form of Snell's law, this is what's happening. The light will progressively follow the curve. Not exactly, but it will tend to follow a curved path. And that's why we call it downward refraction. And that looms things up.
Right, but you need to prove that that's what's happening over the Earth because no one has ever
Well, that's why
shown
I got that
downward
picture.
bending
So I
light.
never got an answer. You changed to your presentation, which I like and I've
Well, I'm
enjoyed
trying to
immensely.
answer you through the presentation so I can actually show you what happens when we see further.
Well, I still haven't heard from why the roof line. We got to a point and we changed gears. You got the picture back up again. You said that the picture on the right with the roof line equal is due to looming, a downward refraction, if you will, right? And I would be fine with that. Doesn't mean that the Earth is round or flat. It means that you think they can't be aligned because that precludes the law of perspective, which is the laws of trigonometry and geometry, right?
Well, no, not
Are we in
necessarily.
agreement so far?
When we have a refraction that's getting in the way, then that's going to like mess things up and change things a little bit, right? So normally you would say that if something is at 20 foot, when it goes dead straight across, it's always going to appear to be at 20 foot. But now we have refraction, right? And refraction is going to change that. It's
So you're
not
saying
always going to
just
appear
so
that. It's
so I
going
can
to
know
absorb
we
everything.
have a solid agreement. So you're saying we both agree then. In the picture of the right, which I would say is looming refraction, you would also say it's looming because we both know that those roof lines cannot align themselves from the observer's height and the distance that they both are with each other, with respect to the observer and with respect to each other. Would you agree?
Well, how tall? Like let's just sort of get this. Are
150
both
feet.
those
Both those
oil?
pictures are 150 feet high off the water.
Okay. So they are both approximately the same height, right?
Right.
So the one that's closer is always going to appear slightly larger, correct?
Larger and higher or larger and lower?
Well, it's always going to appear slightly larger and higher, yeah. And it is
Well,
slightly larger and higher. It is still
wouldn't be
slightly
higher.
higher.
What if you were viewing that first oil rig from 160 feet? Would it then be higher too, as it was became larger with something else? That's where
If you were
you're running into problems, I
if you were
think.
viewing it from 150 feet,
If
then
you're looking at the,
technically,
okay,
if there was
look,
no, can
we
I
both
answer you?
know. Okay, hold on a second.
Zanuck, you got to chill, bro. You got
No,
to
I
let
don't. It's getting
you got to let
frustrating
people
because you know
answer.
this. You're a smart guy, and you're not really getting the obvious here. If I'm at
I am
5
trying to
feet
answer
on
you.
the ground, if I'm off 5 feet on the shore, and I look at these two objects, 160 feet high, and the second farther object is twice as far away, it will be lower due to perspective, due to geometry, trigonometry, etc. Yet we see the roof lines align themselves. Yes, the farther one's going to be twice as small as the big one, and we see that. It's half the size, both vertically and horizontally. But
And you
why
can,
are the roof lines aligned? You gave me the right answer initially. You said it's due to refraction. The question is, and I'm not saying I'm one way or the other, is that refraction enough to show that that represents the Earth's shape? Or is it just an artifact of refraction or a result of refraction that we don't know how much is loomed up? Then we go to the second picture where we show the oil rig sunk. Are you saying that's refraction also? Maybe the upward light curving?
yes, it is 100%
So how
upward
does
refraction.
light curve upward when we know the temperature of the water, we know the temperature of the air, the density gradient is still downward, but it's less downward than the day that was due to a temperature inversion?
You know the temperature of the air
How
on that
would
day?
light bend upward if the density gradient is still denser going down?
But you know the temperature of the water and everything on that day?
Yeah, 60, 60. I have the day actually. I have a picture of the snapshot of the day with the temperature. The air was 90 degrees and the water was 64 degrees, 65 degrees.
Okay, well, I can show you where I measured the temperature of the water and the air. So the water, the air just above, and then the air at 20 feet. And all of them aligned perfectly at 15 degrees Celsius. But in the distance, I had a massive inferior mirage. I can then also show you another day where I measured the water, the temperature just above, and the temperature at 20 feet. And the air temperature was a couple of degrees Celsius warmer than the water temperature, and I still had an inferior mirage.
Yeah, the infrared mirage is not going to tell this entire story. That is another optical effect. It's a reflective, an internal reflection, an interaction of the particles of air that actually act like a mirror that actually will block things on the
Can I just stop
surface.
you for 1
And
second?
this is
Can I
so
stop you for 1
we're
second? Wait.
conflating
I want
the
you to
infrared
explain something
mirage
to
with
me.
where things are in your field of view is not really a good way to go about this.
Yeah, but hold on. Explain to me what are the conditions that create an inferior mirage?
Some inferior mirages can be caused by strictly internal reflections. It can be caused by a surface that tends to be more reflective as you get a more acute angle to it, like a street.
What
People always say when you
what are the
start seeing
temperature?
you reflect, not even temperature. It doesn't have to even be temperature related. It can be just the surface qualities itself can give you an inferior mirage.
So, well, no, you could
Yeah,
probably
that's
get a
true.
reflection,
I can
but
show
not
you
an
tons of
inferior
pictures
mirage.
of cars that are reflecting off the roads that are on a frozen day. And it's only surface quality that's giving you that inferior mirage appearance, where you see the tires mirrored on where they contact the surface, and you see the car's reflection on the surface between you and the car.
Okay, but then what would be the difference between the temperature of the surface and the air just above it?
There could be zero. I can do this at night. I've done it at night plenty of times. It's interesting. In fact, I pay a lot more. Thanks to Flat Earth, I've been doing way more experiments and to test it to show this kind of things. So there's a road by my house that is almost near flat that I can see this reflection, and it gets worse on a hot day. But even at night, if a car's coming, I can see details of the headlights reflecting off it, the tires, even other things that are just slightly illuminated
Okay,
on
well
the
then
surface. And even
then
at near dusk, when anyway, the point is, you're like that picture there. Is that an infrared mirage? The
this
ship?
picture here, this
Yeah,
ship, well, we can't tell because it's in a
I can
fog.
tell. That's caused just by fog that's below that is blocking out the what you
But
can see
that's
in
why I
the
say
bottom of the boat.
you
Yeah,
can't
the
tell if
boat.
it's an
See,
inferior
the
mirage
way to
because
determine
it's
where
in a
that
fog.
boat is with respect to the water and whether it's a infrared mirage or not is you look at the angular position in your field of view of where everything on that boat, how high it is and how far it is away from you to figure out where it should be. And in that, I would be willing to bet that's probably almost exactly where it should be in your field of view. Nothing's floating. That's just you're obscured because of the
Doesn't
fog beneath it.
it doesn't have to be floating to be an inferior mirage. You
Well,
can't
that's what
tell
the
if it's
mirage means. It means it looks like it's kind of not touching the surface, but the only reason because you can't see the surface
well,
because it's blocked by the water vapor or the condensed water vapor, I should say.
it's really close to the horizon, so it's hard to tell whether or not it's an inferior mirage anyway.
How do you know where the
Because
horizon is? I'd say the horizon is
because
probably well behind it. I
yeah,
think the
more than
horizon is
likely,
probably at the bow level, actually.
quite possibly. But
Yeah.
that's what
So
I'm saying.
let
You
me
can't
send you
tell
a
because
picture
this
here.
is
Oh, go
fog.
ahead. Why don't you continue with your presentation because I didn't mean to interrupt you.
This is a fog, so we can't really even tell what's going on with the horizon there because the fog is
Correct.
blending the
I
horizon
agree.
into it.
I agree.
So we don't even know. What I'm saying to you though,
Well,
or what I'm
then
asking from you,
you start
hold
using.
on, Janet, give me a second, bro, please. What I want you to do is explain to everyone what the actual science of an inferior mirage is and what they say the temperature gradients are to create an inferior mirage.
I don't know offhand. It's been a while since I've looked at inferior mirages and the cause of it, but I do know they're basically a combination of refraction and
Okay, can I just
internal
tell you that
reflections.
the basic idea that you can read in any of the papers will tell you that an inferior mirage is caused when you have a warmer surface with a cooler air above the surface. That is what causes an inferior mirage.
A warmer surface and a colder. No, that's not true. Actually, I've seen plenty of inferior. In fact, I can show you pictures of inferior mirages on warm days when you have very very cold water and it was a warm day. So it's not that impossible to see a lot of inferior mirages. In fact, I had a series of pictures in the San Francisco Bay, which all sorts of landmarks to be able to see where. Because that's one thing bad about your pictures here, and you
Exactly.
haven't shown
Well,
me that. Like Travis has a
you
lot of
haven't
good
even
ones. Which let
you
me
haven't
finish.
let me get
Let me finish real quick. Yeah, he has a lot of pictures where you see shorelines and buildings and things in the distance, and you have all sorts of different layers of atmosphere along the way, whether it's in the middle of the lake, at the shoreline, at the buildings across the shoreline. You can have inferior mirages where the water is not warm at all.
Okay. But so then what you should do is that you should write a paper now saying that the entire field of science to do with inferior mirages is wrong, because there is nowhere that you're going to find, and I challenge you to do so, go find a paper that says an inferior mirage can happen when the air temperature is hotter than the water temperature or the surface temperature.
Oh,
I challenge you to
absolutely.
go do that now.
Yeah, not a problem. And I've seen it myself many times. I can give you a picture of what I've observed myself, and you know the San Francisco
Okay,
Bay
but
is not going to be.
I understand that, but
Why
what I'm
don't you
saying is I
tell me
want
what causes
to
the
move.
inferior? I'll show you an inferior mirage. Let me show you. Let me just show you a inferior mirage, and you tell me my pictures. These are my own, undoctored, unedited. And these are pictures you can see. The inferior mirage, and that's San Francisco. You can see the Golden Gate Bridge or the Bay Bridge. I have boats between myself and the bridge. Everything. And these are clearly, if you think they're not inferior mirages, that'd be interesting. But I think you'll then here we go. Flat Earth, here we go. I'll just grab one out of randomly, just make sure it's one that looks like a inferior mirage. Here we go. This one here. Where's the bridge? I haven't had the bridge in it. I think this might be. I can't see him. Just going blindly here, but
Can we break in the Xanax presentation or it's a one-on-one? I didn't know Xanax was giving a presentation.
It's just
not
me. I'm trying to share screen to show him something, but he just doesn't really seem to.
I want to know. We can continue to see.
Otherwise, I wouldn't be sharing screen. I just said, "Hey, can I just share this?" And then it's like, "Yeah," but then all of a sudden it goes into all this other shit.
So, Rakia, do you think that we're dealing more like we're both listening to them, right? Do you think we're dealing more with absolutes or optical phenomena? You know, because
said it right. Optical illusion. You call them mirages, refraction, all that, but it comes down to optical illusions that you can't put an index on, right? Like there is no way in hell, because the variables change so quickly, and especially over distance. The water temperature and air temperature be one thing where you're filming from, where the object is, and in between you and the object could be totally different. I mean, just riding a boat down a river and feel all the temperature changes. Getting the water in the Gulf of Mexico in Biloxi, Mississippi, and then go 50 miles to Destin and get in the water and freeze your ass off. I mean, you can't put a standard on this stuff like they try and do. There's no way.
I agree with you, bro.
That's what I was
I agree
thinking.
with you. I agree with you.
It sounds too absolute. Plain reality keeps referring to the horizon as if it's a physical object.
No,
can you see this inferior mirage I have here?
Physical object at all.
So, after you answer me, I want you to continue, and I won't interrupt you anymore. I'm just sorry for adding more color to my questions. But this picture of the airplane across the bay from, I think that's from the 92.
Did you put it in live stream text one?
I think so.
Where are you posting this? I don't see anything.
If you just put it, no, you definitely didn't put anything in live stream text one.
What did I put it in? Oh,
I don't know.
Live stream text one. I got to do them. Okay, here we go. Oh, all the nice pictures I put in there, they don't show up. I'll just put them in. I won't add color to them. Or there's one. And where's the bridge?
Okay.
I think
it's very blurry, but I won't give you shit for that.
Well, this is a picture through a telescope. But would you say that picture of the airplane has an infrared mirage?
Yes.
Okay, so that is on a very cold day, where the water anyway, the air is much warmer than the water. Yet we still see an infrared mirage.
Cool, but what I'm saying is you now need to go write a paper and tell them that they're all full of shit, because
no, I think
there is nowhere that you will find. There is nowhere that you will find. Let me finish. There is nowhere that you will find where within any of the scientific papers where they say that an inferior mirage can be caused or can happen when the air temperature is hotter than the surface temperature. That is meant to be looming conditions. So if you can, I agree with you, right? I'm not saying that I don't agree with you, because I've film this, but that is not what the science says. The science says to create an infrared mirage, you need a warmer water or ground surface with a cooler air surface. That's how an infrared mirage is
Are you
that's how you
familiar with at what point you might get stabilization off the surface and then get your actual conditions again? In other words, I think we're often obstructed by surface noise, for instance. Yet your vision's going to be clearing up beyond it or different through it. I think you're looking through two layers of vision in the distance like that. Do you know what I mean? Because your gradient, your heavy gradient isn't atmospheric at all. It's surface to air. Then it stabilizes, and then you get atmospheric gradient after that. So you'll get a restored standard temperature some 15 feet above surface, what I'm calling surface noise, scintillation, or convection.
Yeah, here I have a picture I want you to take a look at real quick. I gotta make sure I get that plate so I can do it. How do I do that?
I think it causes a lot of confusion in what we're seeing.
Okay, so I got a picture here that is a boat I followed for about a half an hour across the bay. And there's at one point, and then later on, it looks like this.
Yep.
So you see the red mast or the red part that's kind of hiding the sails?
Yep, so it's
horizontally.
moving further into the infrared mirage.
It's pointing because it's going toward us at that point. So where did see it's right on the water, and at first I see the whole boat, and in fact there's a better picture of the boat earlier that I could see, but
it's so the one where you can see more of the boat, that's where it was coming towards you. The first picture, because obviously if it went from where you could see more,
it's going away from us. It's going away from us.
Oh yeah, okay, yeah, you said towards.
Oh, sorry.
Yeah, that's fair enough. What's wrong with that?
So there's that particular shot was not. I didn't see any infrared mirage there. On a different day, when we have it was actually colder water. We saw some of the bridges in the distance having in the day also looking at the airplanes at the airport, seeing the infrared mirages. So you're saying that all the papers say this can't happen, but it does. You also agree that it probably can happen in some cases, and the experts say it doesn't. Is that kind of where we're at?
Yeah.
Disagree?
Yeah,
okay.
100%. So, I mean, you obviously have physics degree, don't you? Apparently.
Partial, a lot of degrees, but yeah, most of it was in physics and engineering. Yeah.
Okay, right. So you could literally write a paper and debunk the entire refraction system, whatever you want to call it, like, because you will not find anywhere where you will see where they say an infrared mirage can happen with warmer air and colder surface. It doesn't exist.
I found a paper once that kind of helped me understand how this combination of internal reflections and refraction caused this effect. And I have a lot of disagreements with many of the experts on a lot of the infrared mirages. My whole reflective surface argument has never been brought up by anybody. I know it to be true because I've done plenty of testing to show that it would be. So my hypothesis could be very easily substantiated by evidence. But you won't find any papers written on it, which I think is it's one of the most curious parts of mirages that I've seen throughout my life.
You want to share that paper and stop filibustering?
Yeah, I gotta find it. I'm buried in papers and things. I don't know if I'll find it. I'm not filibustering, by the way. I'm playing because we're talking about some of the laws and some of the things that have been written, and they're not consistent with what he's seeing.
Actually, there's an already known variable which could account for this, which is humidity. It's actually already measured that humid air under the same conditions like pressure and temperature and so on will have a slightly less refractive index. So if you have evaporating water from the ocean or from the sea, then it's going to create that layer that will be a little bit more humid. So even though there's no temperature gradient, that humidity will make basically the same effect as if there was a layer of less dense air right above the surface.
Yeah, I can agree with that because I've actually filmed inferior mirages in tropical climates where the air temperature was much warmer than the water temperature. But the thing is that the papers actually say that humidity has a absolute minimal effect, and they literally discard humidity as far as refraction is concerned in the way that we see. They totally discard humidity. They say that it has virtually no effect at all.
I don't think that would apply to all conditions, because the conditions, are we talking about stuff like surveying or astronomy, because those people usually don't do observations a couple, like 2 meters above the surface of the water where those conditions are the most variable, and you could definitely get conditions where this wouldn't be negligible. And flat earthers, this is the best environment where most of the flat earthers do their observations, because they are aware of that they can get crazy conditions there. So if you're talking about papers about like professional surveying, no surveyor does observations in conditions like this.
Yeah, well, see, the thing is, the reason why people go out and, go 6 feet, 10 feet, 20 feet above the water is because that's what we're told, right? We're told that, well, people just stood on the beach and they saw a boat go over the horizon. So obviously people are going to go stand on the beach and see what's going on. So there is this whole thing of like, well, you need to get higher. And it's like, well, hold on. Okay, if I need to get higher, nothing different happens when I go higher. I still see that thing eventually disappear, the same as I see it lower, but you want to say that it's totally different at higher than what it is at lower. Like we still get the same effect. Nothing changes. We just see it happen further away.
One thing changes, which is that conditions are much less variable over time. So if you go to the same, let's say, a mountain over multiple days, you're going to see pretty much the same image, or at least much less varied image, compared to if you go to the same place on the beach on multiple days, where you can sometimes get an inferior mirage, sometimes get a superior mirage. I've never actually seen a photo of an inferior mirage from like a mountain or a hill, like never in my life.
Exactly. So my question to you, and just to take a quick sidebar, if you would indulge me, you don't have to if you don't want to. I accept no. But the picture I posted in the chat, I tagged you in it, talks about the land observation. So not over water, we're not at some sea level, we're kind of in thinner air to begin with. We're viewing something from like 1,000 feet, and we're viewing two objects that are 14,000 and roughly 8,000 in height. The side peak of Mount St. Helens is actually 6,500 feet. It has it in meters too. If you wanted to go with meters, I think it's 2,000 meters or something. So how can a mountain twice as high, that is twice as far away, be well below that point? Meaning that you would think they'd be stacked up like the drawing shows. If you're an observer, you're looking, it should be some angle. I can't remember the angles number. I may have put on. 1.5 degrees or something. 1.45 degrees. How is it not in a line to the top of that farther away mountain? That's 14,000 feet. That's Mount Rainier, which is one of the higher mountains in Washington. And then we have Mount St. Helens, also Washington, Oregon. And
how far away is Mount St. Helens?
About 50 something miles, like real close to 50 miles. And Mount Rainier is about 100 miles. It's about double the distance.
Okay. So then why wouldn't?
Because they should be in line based on basic trigonometry and geometry. The observer should see the top of Mount Rainier to be right at that 2,000 meter point of Mount St. Helens. It shouldn't be below it, but you see it clearly below the snow line. I mean, the snow on both the mountains is not that far away, 50 miles apart.
Doesn't exist.
What's
you're
that?
saying is that refraction doesn't exist.
I'm not saying that at all.
Maybe if there was zero refraction, we would see that.
Okay, so you're saying that the reason that
air, and you're talking like 100 miles of air.
Yeah, 100 miles in air. Yes.
Yeah, and if you have upward bending light, and that light is traveling all that
how
distance,
does light bend upward when we know through all the laws of How does
This
light
is why
bend
I say
upward?
that the science is really shit as far as what's actually happening terrestrially.
Okay,
You can
I
say
get
that
your.
maybe this.
I'm not gonna object to your objection. I just want to know what your logic is. How does light bend upward over this height, over cold air, snow-capped mountains? How is the farther snow-capped mountain below the snow line of the foreground mountain?
Well, because the light that's getting to it is coming from that. Like if the light is doing an upward bend, it is going to be lower, right?
Yeah, but why does it bend upward?
Because it's refracting.
It can't be refraction because refraction needs a denser, a differential medium that's going upward. I mean, it has to be denser going up than down. And we know we're already at 6,000 feet, and the atmosphere gets actually progressively, exponentially less dense as you go up.
It's
Yeah, but
in the dense layer,
you're still looking
leaving the
through
dense layer.
100
It gets
miles of
less
atmosphere.
dense. It gets thinner as you go up. Would you
Possibly.
agree
But
that
wouldn't
air
the
gets thinner as you
temperature
go up?
wouldn't the temperature do the same thing? Like if a
No,
hotter
absolutely
ground,
not.
if we're gonna say light, right? If we're gonna say an inferior mirage is created from like the ground is hot, right? The base is hot, but the air is cooler. That creates inferior mirage, right? And that's gonna cause what? The light to go up, right? It's gonna bend upwards. Why can't that happen on a mountain?
It's more of an internal
Why can't
reflection.
the mountain be warmer than the air?
Yeah, and then the air underneath is still going to be warmer than the air on top, right? So
Are you
we're
really
still going to
think
get
you
that
want to
same
really
effect.
go there? You think that the air somehow on the snow-capped mountain? And believe me, aviators have known this for almost 100 years now. We know that if we go higher, we have something called density altitude. We know if we're at Denver and we're at 5,000 feet and it's a hot day, we know if the air is acting like it's at 8,000 feet or 9,000 feet. We know this. We know temperature affects it, the density. We absolutely know that. But we do know that the density gradient still goes lower as you go up because everybody above that 5,000 foot airport knows that their density gradient goes up even more as they go higher because the air is getting progressively thinner. So there's no, okay, I'll finish with this. There is nothing that you could say that I could imagine you could say. You could say whatever you want, and I would be interested in it, by the way. Nothing you could tell me that will indicate that this air has a density gradient that is denser going up, even if it's colder as you go up, which it is, 3 degrees per 1,000 feet, that would be enough for it to bend upward substantially enough to angularly move that 50-mile farther away mountain down almost a half a degree.
Well, that's what upward refraction does, right? It drops things in the distance.
I agree, but how do you have upward refraction when you're at 8,000 feet or 14,000 feet? The air is not progressively getting denser upward. It may be getting slightly colder upward, but that doesn't bend light.
It's less dense, but you've got warmer air. The air is going to be warmer underneath. So
Who
if you
cares?
have warmer
You're
underneath.
saying it's bending because of the temperature?
I don't know. It's
There has
possible.
to be something similar.
Okay, that's the smartest thing you said so far. I don't know. You don't know. That's correct. That's true. You don't know. I guess it's not possible because that's not how refraction works. But I mean, you
Bouncing
can
upwards.
you dig into it if you want. You can figure out a way that if I were you and you believe this, figure out something that follows a model that shows refraction where light bends upward in this scenario, and I'd be absolutely amazed and very proud of you. But I don't think you're going to be able to do it. Just we can move on. I want to take a little sidebar because this is something that doesn't involve mirages and near the surface, that kind of thing.
This is filibustering.
Not a filibuster. We're having a discussion. I want to know where his head's at. I didn't even know if he was a flat earther or a round earther when we started talking. Now I have a feeling I know.
Dude, this is more filibustering.
No, it's just talking. Just a couple guys talking. I got a beer out right now.
This is even more. This is again third time.
Listen, light in a dense layer will bend
There
up
has to be something
because it's going
similar,
to
kind
less
of like
dense.
what concave Earth has, where there's a systemic upwards curvature of light, even in a vacuum, and then there's the atmosphere's influence. FE needs to have this. It needs to have a systemic upwards curvature of light. Due to what, by to what is another argument. But even in a vacuum, this light will have to curve up, and then you introduce the denser gradient atmosphere, and then there's additional influence from that. But that has to happen
Well, I couldn't see light
because
curving up
like
in a
Zanuck
vacuum,
said,
would it?
it's just the atmosphere and the density is not going to be enough. It's not going to be enough.
In fact, it's the opposite. It's completely the opposite. Light just does not bend upward. Even if the temperature is going down as you go upward, it doesn't bend the light upward. Temperature doesn't change the
But do
density all that
mountains
much. You'll
do
never
mountains
find.
refract, Zanuck? Can you get like an inferior mirage with a mountain?
Can you get an inferior mirage on a mountain? Not from a
Yeah,
mountain.
of a mountain. Like, can that create like can a mountain create like you get the illusion of an inferior mirage?
Sure, of course.
All right, so it can go upwards.
Then what can't go upward? The refraction can't go upward?
No, the light can bend upwards then on a mountain.
No, the refraction.
And you're saying it can't,
That's
but
a
you just
non
said
sequitur, and it's a
mountain can
straw
refract.
man combined. No, I'm not saying.
It's not a
I
straw man.
definitely.
I asked you a question. You gave me
If
an
you're looking
answer, and I
through
drew the
layers of, if you're
conclusion
looking
based on
through
your
disparate
answer.
layers, if you're looking through disparate layers of atmosphere, you can have a inferior mirage at your eye level. This is all happening at eye level, by the way. In the distance, way in distance, there could be a mountain, and it could be inferior. It can be internally reflected in that layer, those layers of atmosphere. Not even due to Earth curvature, just due to the fact that you have different layers, and the light is then refracting as it progresses towards you, like kind of like the fish tank in the laser experiment. That doesn't have anything to do with what we're talking about. That's why I got different angles where we don't have the right on the surface, totally acute angles, which are right for any kind of refraction, not only mirages but sinking or looming refraction.
Yeah, but you're still going to have to really show that light isn't bending up because, like I said, the only thing that we've ever seen is light bend up everywhere. That's the only thing we've
That's
ever seen. We've seen people with lasers where they're looking from above the laser and the laser bends up. Now, if
because
the Earth is flat,
downward refraction. It's a kind of it's
no,
non-intuitive.
not
Well,
downward
think about it.
refraction.
Let's go back to the oil
Bend up
rigs again.
because of refraction.
If I shine the laser at night to that oil rig, it's going to bend up to the roof because it's now that oil rig was loomed up due to refraction. If we still see it, and there's some good pictures of those oil rigs at night with their lights coming on. It's
Or
just at dusk. We know that those objects have been loomed up. You even agreed with me earlier. You said, yeah, it has to be because those roof lines cannot align. You
no,
told
no,
me
no,
that.
no, no,
So
no, no. Well,
if we
hold
have
on, let me explain myself for a second. Okay. So what you call loomed up, right? Because loomed up really, like, I would just use the term loomed up because that's the term that gets used. But loomed up technically means coming up over the curve of the earth, right? That's what looming really is. But really, what it actually is the fact that now the light is traveling further. We see that thing that's further away. The horizon now has just moved further away. And now the thing that seemed to be below the horizon because of before that, the light that was bending up now just travels straighter, further, and it now reaches that thing in the distance. What you're saying is that the light goes around and down and hits it. What I'm saying is no, the light is traveling straight. It's not actually looming up. We're now seeing it in a more realistic position of where it actually is because now the light's getting to it. So when I use the term loomed up, I'm not using it in a globe sense. I'm saying that that is now seen in a position that is higher than a point where it is now sinking. Now we see the horizon extending. It now has to come into a higher position because the horizon itself is always going to be the furthest visual point you can see and the highest visual point that you can see. So if you now see something on the horizon, it is now going to appear in the highest visual point, and everything before that is going to have to drop below it. But if that horizon now moves closer to you, now whatever is on the horizon there will be in the highest visual point, and everything beyond it will appear to drop, and everything in front of it will appear to drop. I've literally shown this. Obviously, you need to go watch the whole presentation. I know it's a few hours long, but there's a lot of stuff in there that you have probably never seen before. So you need to go watch it.
two things to get the presentation. I want to make sure I make sure I watch it. What's the easiest way to do it? Through the live stream recording,
I
or do
guess
you have a? So
I guess
it's
probably
on the
through the live.
presentation that was recorded through this Earth Awakenings. Okay. Number
Yeah,
two,
I'll cut it out and post it as its own video after, like by
that'd be
tomorrow
great.
or something. I'll cut it.
Thanks,
Yeah.
Gio. So my point is, though, we both agreed that whatever the cause, whether it be round or flat, doesn't matter. You agreed that the Earth would have to be concave if those two roof lines were aligned in the comparative oil rig position
Oh,
picture.
oh,
And I think we both said, and you said it's due to refraction. So obviously, I'm taking this, to me, it's obvious that you mean the light was bending downward from the observer's point to those roof lines. Forget about the horizons, forget how far you see, whether you see far or not, it doesn't matter. All we're talking about is those objects, because that's really where the crux of the situation is. And you said
So I
that's due to
wouldn't say the
reflection. I
light's
would
bending
agree.
down. I'd say the light
I would
is
agree. Now,
bending. The light is
whether
traveling
that
straight.
is correcting for a little bit of positional, angular position in your field of view, or a lot, like I would say a lot, you would probably say a little. We don't know. We'd be at an impasse at that point until we started taking the next step of the evaluation. And then I asked you, well, how is that possible for it to loom up? And that would be downward refraction. So the light would have to be bending downward. So you're kind of like not double speaking, but if
No,
you
no.
said it's due to it would either be a concave verse or light or refraction, wouldn't you mean the light is bending down to loom that second oil rig up at that roof
No,
line? Because that clearly is
no,
not flat Earth or round Earth,
no. The
right?
light is just traveling to it now. It's going straighter. When
Why is
it's
it? But the roof
when
lines
it's
can't be aligned if it's straighter. That goes
y-
against perspective. Simple geometry
no, it
tells you
doesn't.
can't do that.
No, it doesn't, because when the horizon extends and you have that one
It's
on the
not the
distance
horizon
and the
though.
horizon, yeah, it is. The horizon has extended, right? So
It's
now
not the horizon. We're
the
talking about the
reason that
roof lines. Don't
Zanuck,
talk
can
about
you
yeah,
the.
please stop interrupting, bro?
yeah,
You've clipped him the first 3 times you started speaking. Can you put yourself on mute when you're finished speaking, please, and let
Sure.
someone else speak? Thank you.
Yep.
yeah. So when we get that extension of the horizon, the object that is now on the horizon is in the highest visual point that you can see, right? So everything before that will actually drop lower within your vision. Now that is going to then line up those two roofs, because the one that's in the foreground is going to drop and the one that is in the background is going to raise, right? Now that is due to perspective and the way that perspective works. As you see further, the horizon is the furthest visual point. You can't see beyond the horizon, the surface. So that's where your perspective ends. If that is now closer to you, that's where your perspective ends. Everything beyond that's going to drop. Now, that thing that was on the horizon before that, when you extend the horizon, that thing that is now was on the horizon beforehand, which is now no longer on the horizon because the horizon is now much further away, perspectively, that has to drop. And the thing that was in the distance, perspectively, appears to rise. But it's because the light is traveling further straighter, not because it's going around and down. It's just going further straighter.
I didn't say, Mary,
Okay,
I
good.
didn't concede that it is going to be round and down. I said it's just cannot be lining up. Just like the square, the perspective example, which has the red bars and the height of certain blocks in the distance and everything converging in the center. If you're looking at something at eye level, these pictures of those oil rigs are from someone that's supposed to be 1 foot off the surface. That's the whole thing. It was all framed by that. Even if it's 4 or 5 feet, doesn't really matter. Those roof lines can never match up. You agreed that it was probably refraction, which means it has to be downward refraction. It's following the Earth's curve. It just means you have some kind of phenomena where the light is bending downward from your vision. It's got to be curving downward. Not following a
I
curve, but
disagree.
just curving downward, be due to the differential medium and the angle of incidence, which is given by the fact that you're only at 1 to 5 feet from the surface, and these roof lines are 150 feet, 160 feet above the surface. You said that the farther oil rig could not be in line, which the roof lines are relatively in line. You said it was due to refraction. The only reason refraction could help you see that object, like you could see around a wall, or you could see the propane example where you see this little thing on the backside of a round barrel of whatever it is when you drop liquid propane on it, is because we have refraction that bends light downward and it looms things up. That roof line has been the whole thing, including the horizon. Everything's been loomed up, and we don't know whether the Earth is flat or round, but we do agree that it has been loomed up.
Well, we can agree that it is what they call loomed up, but in the sense of what they call loomed up by saying that it's looming up over the curve of an Earth, I disagree with that. What I'm
Okay,
saying to
so
you is
but you
that
do agree that
the
the light
light
is.
is traveling. No, I'm not saying the light is bending down. I do not think the
It
light's
doesn't.
bending down.
How's it possible for something to be the roof lines be aligned by your explanation earlier, which was totally incorrect if that's what you're going to go lean on. That's not what happens. That's not how it works.
What? So when something perspectively that is on the horizon, and then how the horizon moves forward, that thing that was on the horizon doesn't drop down and the other one raise up? That's
It's going to
incorrect?
drop down. No. Why would it change?
Okay. All right. So now you need to be quiet for a moment while I share screen again. All right. So just let me share screen, be quiet, let me go over this, and I'll show you. All right. And I'm just going to use this one thing here. Let me find it. Okay. Here. All right. So you see this. Let's go here first. You see this picture, right? Can you see it?
Yeah, we see it. Zanuck, you're seeing it too?
Sorry, I
he's in
muted
line.
myself. Yeah, I see it. I was saying I saw it, but I couldn't. I was muted.
Okay. So that buoy that you can see is approximately 3.6 miles away. The tower that you can see in the distance is a jetty or a pier, you guys call it. Now notice how that buoy is appearing. I'll just escape from there and do this so that I can use this. So we see that the buoy is at about this level, right? Because it's pretty much on the horizon. This could just be a little bit of swell where it's just in front, right? But it's basically on the horizon. And see how it's at this level up here? Now, when we all of a sudden do this, so I'll use these two pictures here now. Now when the horizon extends, see how it has now dropped or appeared to drop? It hasn't actually dropped. We now have the horizon all the way down here. It's further away. And now what has to happen is this is where our perspective ends. Our perspective ends here because the horizon is the furthest visual point that you can see the surface. So now that furthest visual point has moved, everything needs to obey perspective and the way perspective works. And this is where the horizon was before at the earlier point. And now the horizon has moved further away. This now becomes the highest visual thing you can see. What was at this height before now must drop down because on a perspective grid, the way perspective works, it now needs to move down. So we have here to here. So this is how perspective and the horizon work together, which has not been described very well before in the past. But when we get the horizon at a certain point and now it moves, the entire scenery now must change. And everything in the distance is going to appear to rise up in relation to those things in front of them. When beforehand, those things that were on the horizon appeared to be higher, when we extend the horizon, they now appear to drop lower. Has nothing to do with curvature of Earth. It's not bending around. So this here, that's 8 miles away. So this is 8 miles away. I'm at 20-foot observer height. This jetty should not be hidden, right? There should only be approximately 2 to 3 feet hidden according to the globe. My horizon should be at 5.5 miles away, which is where this marker is. Now when we move here, the horizon, let me move this out of the way now, you can see is well beyond this at 5.5 miles away and is all the way down the shore here at 9.4 miles away.
There's no horizon in that picture.
There's no horizon in that picture at all.
Okay. Now, there's no horizon in the sense of, would you like me to find the day here and show you how far away the
Did you
horizon
take these
is?
pictures?
Yes, I took these pictures.
Okay. And
These are
where'd you
my
take them
pictures.
from?
This is from Grange Jetty in South Australia, looking towards Brighton Jetty. This is Brighton Jetty.
Okay, now so are you on a pier or a boat, or what are you on right when on that
I'm on a
picture right
pier.
there?
I'm on a pier.
Okay, so you went
On
back
both
to the
pictures.
pier and you took the same picture again.
Different days.
And that's
So
what you
this
saw.
one here is September the 19th. And this one here is, I think, July the 30th. It's got it there, July 30.
And I mean, I'm just throwing it out there. I'm just trying to get an understanding. Was there any tide difference in these two? Is this a lake or is this an ocean?
Yeah, there is a tide difference, but it's irrelevant.
Wow. So your field of view shows that buoy in a position. See, that's you have some great pictures there, and I wish you would have taken the time. And it's a big ask, but if you have something that shows your level, like what is level from you, like this jetty, and then the structure popping off on the dock there. If you're at 6 feet, everything in that
No, I mean,
on
20
that
feet.
structure, that pole, whatever that, what is that, like a tower, some type of tower? That at the base should be right at eye level. Like where you're right now, that should be boom. That should be eye level. If you're measuring that, that's what you needed to do to show that okay, we now have the
What's
position in our
Well,
field
eye
of
So the
view.
level,
line,
eye
what's the
level wouldn't.
height? What's the height difference between these two positions? Between these two
Oh,
pictures?
what do you mean?
Are you at the same? Are you at the same exact spot on the pier? Same height in both
Yeah,
pictures?
yeah, exactly the same spot. I can show you 100 of these,
Okay.
100 different
Same,
days.
same. Okay, and the same exact focal length and everything.
Yep, both 3,000 millimeter vocal lengths.
Can you flip to the other picture again?
Yeah, why does the buoy go down?
I just explained that to you why the buoy
No,
goes
but
down, right? Because the horizon is the physical highest, furthest position you can see. Everything from beyond that needs to obey perspective in the sense of what I showed through the presentation is that when you're on that jetty over there and you're looking back towards me, you will see this perspective. You will see
Flip,
this
flip back to
ramping
the
up.
other
Horizon.
picture real quick.
I, I'm confused. Why? I get what you're saying. That if you have the horizon, then things after the horizon might obey perspective. What basically happens in your drawing, like the one where there's a bend behind the horizon, is basically just a perspective on the globe Earth. But my question is,
Oh,
why do you think there should be a horizon in the first place in your theory? What is the cause of the horizon?
okay, so the horizon is caused by your height above the surface and refraction. So it's your height above the surface in the first place that causes the horizon. That's why you see a horizon. That's why the horizon distance changes as you change levels.
Hmm.
Right. So
hey, don't move that for a
as
second. I want to just take this picture here of this. Okay, there that. Okay, and save
you
that.
got it.
Wait 1 second. Okay, and then go back to the other one.
Oh, shit. Hold on.
I just wanted to make it fair. Divergent Droid was trying to say something, but his microphone is just really low.
Who's mine?
He's gonna turn it up.
This one, or you want to see it?
Yeah,
Like
that one. That one exactly. Yeah, hold on a second. Let me get quick. I'm gonna go take these into my lab and do some work on them. Okay, got it.
Okay, so this is one that I kind of mess with people a little bit, right? Because when we're looking at this is a pretty clear horizon, and I'll show you it from this vantage
No,
point.
you have very little miraging. Those are all very clear. I'll give you that.
Okay, so here we go. See how this is really nice and clear on this side? This is the same day.
Were you looking to the side of it, to the right of it?
Now this is looking, panning right.
Right.
So this is all the way to the left, panning way to the right.
Why is the water not lining up?
These houses, oh, well, because it's from a video and I haven't lined up the water. Right. There's probably, I don't know, 10 miles distance between these.
The
This is
zoom looks
actually
different
17 miles
between
away.
those two as well, right?
No, the zoom would be the same.
Look at how clear you can see the houses in the background. You can't. I mean, it looks like a whole different.
No. This is from I've got the camera at a particular zoom level and I'm just panning across. So whatever that zoom level was.
Okay,
I'm
so
just panning
it's a peninsula way to the right then. Pretty far. It's a lot farther away,
way to
obviously.
the right. This is 8 miles away, this tower,
Mhm.
and these houses are 16.7 miles away.
That makes sense.
And
Okay, got it.
They're at 114 feet,
Okay.
right? So according to the globe math of whatever the curve should be, there should be only, even if we were to include standard refraction, there's 66 feet hidden. With zero refraction at all, I think it's something like 80 feet hidden, right? So we've got closer to about 100 feet gone here right now. Now, as soon as this is what we call the inferior mirage is building, so you can actually just see within this one, you can see along here that this is starting to get a bit funky and an inferior mirage is starting to build. And when the inferior mirage builds, what it does is it starts to bring the horizon closer to you, and it's lifting this horizon as it is. But it's not actually, when I say lifting it, it's not lifting it. What it's doing is it's bringing this and it's dropping everything behind. So as this is coming forward, everything back here is dropping. Now, when we get further away, we can see this is pretty clear, right? This is a reasonably clear horizon, which is what we get told. If you've got a nice clear horizon, then we should see the perfect globe. Well, this is well beyond the perfect globe. Now,
Why is that?
Well,
Which is well beyond. Yeah, I guarantee if you were to look, if you could zoom in and see that peninsula 60 miles away, there is more than 100 feet missing. Or maybe it would be
well,
close to 100 feet, something around. I
can
mean,
show you.
you can't see a shoreline. You can't see anything of it resembles a shore. You're definitely behind something there. Something behind that.
Yeah, but I can just
And
show
you
you
got a
another
choppy day
probably
too. You know, you got this. Why don't you just show pictures of on calm days or relatively calm days where they're not white caps and wind blowing?
Yeah, look, you're only seeing a tiny piece, right?
Hmm.
Okay, so here we have the same thing. Okay, so here, this little section right here is 14.3 miles away. You see how this is raised slightly here? Because this is a rock wall, and that rock wall is 14.3 miles away, and at most is 4 meters high. We're seeing all the way to the shore here now at 14.3 miles away. Before we were seeing up to here. Remember, this is where the water line was, all the way up to here. This point right here, see this little nose section right here? This nose section is 50 feet high. That's 50 feet above the surface.
We
And
go
that is
back
at the
to the
same
picture where
point.
it shows that hidden, and we can see a little bit of nub on the end of that isthmus, or wherever that is.
No, you won't see it. In here with the inferior mirage, that's all gone.
By
Same
the
as
way,
the
in
upper
those
one.
other pictures, what was the name of that pier? I want to look at it at Google Earth. What was the name of the pier?
Well, Brighton Jetty. If you look for Brighton, South Australia, you'll see that jetty. And so here you probably can't tell, but there's little lines right here. These little lines are light poles for an area that's 15.1 miles away called O'Sullivan's Beach Boat Ramp. These light poles right here come to about 48 feet. See how that lines up here? Right, this is 50 feet, but it's about a mile and a half further
How do you think
away.
that's 50? How is that 50 feet?
Well, because I've
That's not you can't. There's
I've checked
nothing
it
in
on
any
Google Earth.
mathematics that can corroborate that estimation
I've
when you're
checked
14 miles away. I can give you
this
this.
point.
How much? Go ahead.
I've checked it on Google Earth, and this point right here on Google Earth, when I drop a thing on it, says 50 feet.
Look at the buildings. Those buildings are 20-foot structures to the left. I mean, they're closer even.
Because
They're closer in the 20 feet structures.
as
Those
you
little
go
white
higher,
buildings on the left hand side. I mean,
we have compression here.
I don't think that you're. This is kind of another case of mistaken. This is almost a Tolan level mistaken identity exercise.
No. I actually used to think that these
Something that's 50 feet, 14 miles away is not that large in your field of view. I'm sorry, that's not how it works.
That's at this is at 3,000 millimeter zoom.
Yeah.
Right. I can show you 100 of these.
It makes sense.
Would you like to see 100 of them? I can show you 100 of them. We can skip through it. Hold on a second. Let me get out of here. Let's move this out of the way. Move this out of the way.
A lot of times it's good to go there and take a picture of those points, and with the when I did Lake Tahoe, I took it across 17 miles. Then I drove there and took pictures of what we were seeing. You can see the gaps in the trees. You can see how much of the trees were hidden how much of the building was hidden, how much of the shore was hidden. That was actually, I thought that was pretty interesting for me. I don't have to prove anything to anybody, but it was interesting for me to do that. And you have you have an inferior mirage there going big time. You right?
All of these are from the same position.
But you have an inferior mirage there. Do you see that, right?
This time, yeah. But now, as we skip through, you can see crazy stuff going on. So you'll see that we'll get to one where we will see. So we see all the way to the shore there again. Okay. So right here, here's that nose point again. I'll blow it up. So when the inferior mirage disappears, we still always see this. Now this is at 50 feet. I've been and checked. I looked. I've done everything. I've driven down there. I go here all the time. Right. So this point right here is 50 feet. So above that has to be 66 feet, right? 66 feet can't be here, which is where standard refraction, which is already making the globe bigger, says that there should be 66 feet missing here. Right? So 66 feet is somewhere up around here. It's above that. So this here, around this level here, is with standard refraction where it should be. But what actually happens is as the inferior mirage is disappearing, all this is becoming visible. And then by the time the inferior mirage is gone, 100% of the time, I always see this. Always, 100% of the time. And then as the conditions keep changing, then we end up seeing the shoreline. Right? So
how big do you think those trees are in those structures on the mountain? Those are 20, 30-foot trees. Those little dots of trees are probably 100-foot trees.
These dots here. These dots here.
No, on the mountain, on the mountain ridge.
No, they're all just
by the buildings. By the buildings. I just
ones
don't
over
buy.
here?
See, you gotta. One
Bushes.
thing that you should add to a lot of these and probably help yourself in your analysis is some type of angular size measurement. Some kind of tool where you can actually look at, like, find a known building over there, like one of those structures. Like you can see the ships, you know how big they are, but those buildings that you're taking, go find them, see how
You can
tall they
calculate
are.
that based on the field of view that you would measure based on the focal length of the lens and the size of the sensor.
Right. So you can go measure
See
that
how
building. I guarantee
already
that
short.
building is not 50 feet high. That's a big building on the mountains there.
It is quite a large building. It's probably at least 40.
Paul, and those pictures from the pier there, what's the name of that tower that or the smokestack or whatever that is that you're taking pictures of?
I don't know if that tower has a name, but you just look for Brighton Jetty, South Australia.
I do, but I'm trying to see what direction. What direction are you taking those pictures?
Go to Grange Jetty. Grange Jetty, South Australia. Go to the end of the Grange Jetty, or you can, so go to Grange Jetty, South Australia, and then turn and go back down towards Brighton Jetty. You'll see that it's 8 miles away. So here we see it again, down. There's the nose area again. Right. See how now we have the inferior mirage. It's starting to break up. It's almost gone, but it is certainly nowhere near gone yet. And we don't see that nose area, but we're about to. That's about right here is about where that nose area is about to come in. And as we keep going, get that out of the way. Right. Again, the inferior mirage has disappeared. And we see the nose again.
Back with the inferior mirage again.
We have an inferior, there's an inferior mirage here. We do not see that nose area again.
Where's the inferior mirage at?
It's right here. You can't see it. It's right there. You can see it here, how this bends back right here.
A little bit toward the surface. Okay.
Yeah, see that little less than sign there, or greater than sign, sorry, right there.
What is that structure, that white and black structure that looks like a motorcycle helmet? It's like
it's a house. It's a house, and I think there's another house back here or something like that, maybe, and then that's why you're seeing the roof from that house, possibly. I don't know. They're big houses, man. They're like, they're like, these are worth a few $1 million. These things, they're not cheap houses, are they, over there? Right. So inferior mirage, no. So Sorry, some of them are a little bit out of focus, but that's just life. Again, we're getting all this missing here. The inferior mirage disappears, totally gone. We're seeing down to the shoreline over here again. It's just very distorted. See how we still have an inferior mirage right here? We can see this little cutback right here. Okay. And the nose is just coming out. This inferior mirage is still there. We can see it right there.
That's really,
We see
really
it bending back
blurry.
right here. We see it
Not
bending
really.
back right here. Right. And we're starting to get that nose now. So the inferior mirage, and we can see that cut, this line cut back right here. We see it cutting back there because the inferior mirage is right here. It's almost gone. It's still there though. We go to a different day. Oops, hold it. Let me go up there. Where was that? There.
Paul, are
Inferior
you
mirage
shooting
green.
from that Brighton jetty? Are you shooting north or south?
No. I'm on Grange Jetty and I'm shooting south.
You're on Grange jetty
I'm on
shooting.
Grange Jetty, shooting south, looking towards Brighton Jetty, and then this is an area called Port Noarlunga.
How do you
So
spell
this
Grange jetty?
Grange. And this area here, these houses are on top of a hill at Port Noarlunga. And where they are, this very bottom level right here of the base of where this house is at 114 feet. And then this point right here is literally right in front of those houses. You could draw a virtual straight line straight across, and they're right there. Maybe it's not perfectly straight from that one. Maybe it's straight from this house, but that's pretty much straight across. So this nose right here is where these houses are at 16.7 miles away. And as we look through, we'll keep seeing when we have an inferior mirage. So this is also an inferior mirage. We can't see that nose. The only time, now we have a lot of compression here. Sorry, it's a bit blurry, but we can still see that nose area there. Inferior mirage is gone again. Now we have an inferior mirage again. We do not see the nose here. Every single time you see this inferior mirage, we know 100% that this horizon is closer because that's what it does.
I wouldn't
Okay,
agree
obviously
with that
there's
at
a lot of
all.
haze in that one. Sorry?
I wouldn't agree with that, but
You wouldn't agree with that?
no. Usually the horizon, since you're looking pretty much eye level, it's somewhere around there, just slightly below the center of the midpoint of the inferior mirage. Generally,
Okay, but I would actually bet my house. Are you willing to bet your
I don't
house
take your
that
house for something this silly.
the inferior mirage brings the horizon closer? Like I'll be willing to bet my house on it. That's how confident I am. I
Well,
know the inferior mirage brings the horizon closer to
I
you.
think you should be. I think you don't bet anybody because you might lose your house.
What we would have to do is you would have to then, because I can show you by looking at the other area down at Brighton, how the inferior mirage always brings the horizon closer to you. It's 100% of the time. So if you
Well,
want to make
we
the
have
bet,
things that are
I'm
fixed.
happy
For
to.
example, the oil rigs again in Santa Barbara, where we have the inferior mirages that are being so these things are known. They're taken from the same spot, relatively close to on the shoreline. And there's a couple of pictures where you can see the inferior mirages quite clearly. What's going on? The mirroring, the inferior miraging, everything, and
And the
it's not
inferior
doing
mirage
anything
will
to
be,
the horizon.
well, and the inferior mirage has to do something to the horizon because that's the inferior mirage will create a new horizon. The
Sorry,
inferior
Paul.
mirage
What
will create the
what
horizon.
camera are you using, Paul?
It's a P1000 or P1100. I got both.
Yeah,
Basically the
but
same.
in the one specifically that we're taking from that we're shooting towards Brighton, was that the P1000 or the P?
They're basically the same, aren't they? I don't think they changed anything in them as far as their lenses.
Are they both the exact same focal length?
Yeah, 3000
Okay, were
millimeter
you
zoom,
using any digital zoom, or were you just going to the maximum of the optical zoom?
maximum optical, perfectly on 3000 millimeter, which is the optical.
Well, let's see. Go to live stream again. Put this picture in here for you. Okay, these are some interesting pictures that are known distances. This is like the gold standards for the flat Earth discussion, I guess. These oil rigs, everyone knows about them. And then something that came from Travis as well. So are you in the live stream? You could bounce out it real quick.
Yep. I'm just looking at the live stream now.
Oh, I didn't get the right one. Shoot.
So there's no inferior mirage for the oil rigs there.
Oh yeah, there is actually. Look beyond the boat. You see a
No,
totally.
not for the oil rigs.
Yeah, I got the wrong one for that. Let me get rid of that one. That's
Well,
the right.
Paul, were those photos cropped at all, or are those the original photos in those shots?
They're the original photos.
Okay, they're not cropped at all.
What do you mean by cropped?
Like you didn't take the photo and then like zoom into a certain section and then crop it so it's not showing the entire field of view, or that's the entire field of view from edge to edge.
That's the entire field of view from edge to edge. Yeah. So it's like all these pictures that I'm showing you. If I just go over here again, you'll see if I go like that. So this is full edge to edge. That's as far as they can go. I can close out of this one and then just go to here and we can have a look at them. Right and buoy. Okay, so there's the picture in question, 30th of July. That's one of the ones that I showed you. Right, so I can just do that. You can see that is the entire field of view. The only thing that I have done is you can see up here, I've moved them so that way I can, as I skip through, all the actual towers are all in line with each other.
There it is. Okay, I found the picture. Paul, we can go look at that. You see it?
Not yet.
There.
It's coming up now. Yep. Okay. So see now how you see the inferior mirage, and it's now in front of that front. It's in front of the front oil rig. It's now been brought closer to you.
What do you mean it's been brought closer to? What's been brought closer to me?
Well, the actual horizon, it's in front of this oil rig here, right? That front oil rig, the one that you see closest to you.
Absolutely, absolutely in front of not the front one, the behind that. Not the front one doesn't have a problem with the horizon.
What are you talking about? The front one's got an inferior mirage.
The front one? No, the rear one, the one that's actually hidden. That's the farther one. Farther one.
Yeah. Okay. There's an inferior mirage there, but there's also an inferior mirage on the front one.
Really?
Yeah.
Where?
I can see it straight away. It's right there. It's so clear, bro. You can't tell that front one's got an inferior mirage.
At its base. There's three. There's.
I'll do this live.
At its base, there's like some gaps, air gaps in the pylons. You can kind of see some.
Wait a second. Let me just get an image of this. We'll do it live.
Well, I agree. The horizon is probably in front of the front one as well.
Okay, but hold on. I'm going to show you. We'll just do this live. We'll drag that over there. Make this larger. This. About the same angle as the thing. And right there is your inferior mirage. See how this is miraging from here? This is that same point right there. See how this cuts down here? That's that same point right there. This is all a mirage, and this horizon is in front of this thing.
I would say it's behind it. The horizon is behind it.
No, it can't be.
No,
it can't be. It's physically impossible.
Oh,
if this is inferior miraging, it can only be inferior miraging because it is behind the horizon. If it was in front of the horizon, the inferior
That's
mirage
not
would
true.
be behind it. It would be
Yeah.
behind it. Zanik. Dude,
That's not true. I can show you
honestly.
pictures of it. I can show you some inferior mirages that were only a mile away, and you see inferior mirage, and the horizon was not behind an inferior mirage. Boats on the water.
No.
I'll show
The
you the
inferior
picture.
mirage is always because
It does not mean that doesn't mean where that horizon is going to be. That's absolutely wrong. I'll
the
show because
horizon.
I can show you a picture of a mile away boat with you inferior mirage at its stern, and it is the horizon
And the
definitely
horizon's in front.
behind it.
No, it can't be. That's physically impossible.
Well,
because
I guess I
the-
get I'll
the
give you another.
horizon-
I'll give you another picture to do your homework with. Oh, I'll get
Hold
back
on.
to you.
Okay, do another one right now, and I'll show you that it's physically impossible, right? Because
It's
the
not physically
inferior
impossible.
mirage. Let me just explain it to you. The inferior mirage creates that horizon. That's why you see that horizon in that position. The inferior mirage is creating that horizon.
That's where you're wrong. That's
Well-
where you're wrong. You can have things up very close. Inferior mirage that's very close, yet the horizon is well behind it. You've done some experiments, and I commend you on all the work you've done,
Okay.
but you've just drawn up the wrong conclusions. And I'll give you some examples of this. Hold on.
Okay, so let me show you here. See how this is inferior miraged?
Hold on.
You can see the little din there and din there. Okay.
I gotta go back to your thing. Hold on. I gotta find you. I was trying to
You
find
can
my picture.
something can only be inferior miraged if it is behind the horizon.
That's not
It's
true.
physically impossible.
It's not
for it
physically
to be-
impossible.
He's just conflating. He's conflating physical horizon and acting as like the horizon can be physical when we know it's apparent.
Okay,
He's just
Just like I can have a horizon that's before. This is a good one for you, and this is one I had solid proof for, and I'll show you in a sec. You can have inferior mirages on the land, for example. Like let's say that tower had the base of it. The base of it had a inferior mirage, but the horizon could be closer. The horizon can be closer, and you can see evidence of that too with boats, for example, that are the hulls are missing.
Now, although this is
Yet
blur,
up in the
right?
mountain, yes, that's an
I
inferior mirage
apologize.
there.
I apologize for the blur, right? But see
I see it. Inferior mirage.
we
I
have
get
the
it.
inferior mirage here, we have the horizon here, and we have the buoy in front of the horizon, now not in an inferior mirage. It is physically impossible that if the horizon is behind something, which is where the inferior mirage is being caused at the horizon, because the inferior mirage is what will give you that horizon. It's
No,
physically
that's not
impossible if
true.
something is in front of it.
You're making baseless statements. I can tell you, I can show you pictures. I'll give you one just like that. Exactly like that, where I see buildings in the San Francisco Bay shoreline where the buildings are inferior miraged, yet I have a boat that's missing the hull well in front of it. The horizon is in front of it, having nothing to do with the inferior mirage.
Cool, show me and I'll show you where you're wrong.
You're not going to show me where I'm wrong because I was there and I saw it. And I watched the boats come toward me. And I watched the boat lose its hull, and all I could see was the mast or the sail.
Cool.
And then behind it, 5-6 miles behind it, inferior mirage in the hills, cutting
Let's
the
have a look.
buildings in half laterally.
So
I mean
now
vertically.
this here is not inferior mirage now. So now the inferior mirage is actually behind this, and it's behind here, very close to here. I think the inferior mirage is starting just beyond that. But see how now the buoy is not in the inferior mirage, because the inferior mirage will create the horizon. That's what the inferior mirage does. That's why when people go out and they look and they just see nothing but a horizon, you can't tell that there's an inferior mirage there until you see something that is behind the horizon, and you will now see the inferior mirage. It's physically impossible to have an inferior miraged object in front of the horizon.
That's not true.
can't
You're,
happen.
you're just making statements because it's what you've seen. There are pictures I have that show quite the opposite in both ways. Inferior mirage that's farther away, higher as well, and a boat that is missing its hull 6 miles closer.
Cool. Show me.
Okay.
Paul, what's the name of that object? I'm trying to find it on Google Earth. That little tower
don't-
thing. What is
don't know
that?
I don't know if it has a name. It's actually a it's a
Is
cell
that in the
tower.
water?
No. Oh, I mean, it might go down into the water, but it's right on the jetty.
It's on the jetty.
Right.
On which jetty? Where can I find it on Google Maps?
Brighton jetty. BRIGHTON Ghton.
Oh, okay. That's in Brighton Jetty.
That's on Brighton Jetty. Yep. It's at the end of Brighton Jetty. Now we see here once again, the buoy is in front of the horizon. Here is the horizon, and here is the. And actually, you didn't see this earlier. I'll show you, right? Because like we can just kind of put this to bed in a way. Okay. Let me go here. Right. Now you can see this. Let's go here. Now you can see this. You can see that there's an inferior mirage being caused right here. The inferior mirage creates the horizon. All this here, you can see it's like, oh, it's pretty close. It's thinking about miraging. It's thinking about it. But now what we're going to do is we're going to watch all of this dissipate and disappear. And you'll see how there's all these little lines. You see a line here, and then we see like another line here. Travis would call them aquabands. So we see line here, we see line here, we see line, 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 line. Now watch in this area, as this mirage breaks up, you'll see it breaking up in lines. See all these lines going and it breaking up and it's moving. It's moving back here.
What
See,
you're
this is
seeing
in
is
the,
the
this is in the inferior.
reflective qualities of that particular the water right there. But go ahead. What else can happen?
No, we're looking at an inferior mirage.
I know,
Now
but
the
that is a
inferior mirage is
reflective.
moving.
It's a product of reflections as well. You're seeing the
It
sky
creates the
reflecting off the
horizon.
water.
So now see
Where's the
how it's
horizon?
moved?
Where's the horizon at?
This is the horizon.
Okay. And where was it before? Did it move?
Here.
No. That's not the horizon. That's as bad as the picture
Yeah,
of the fog. Dude,
that's
you're
the
so
horizon.
confident you think you know what's going on. And it's really kind of frustrating. You're not willing to really look
That
at
is
some of
the
the facts and some of
horizon.
the. All right.
This is your visual horizon.
No,
This
it's
is
not
what
my.
you see.
Yeah, because you have a reflective surface beyond the boat. Look at you can see that. I mean, there's proof of it. Look at the yellow buoy there. What's that
It's
yellow
in
buoy
the
doing?
mirage. Yeah, it's in
It's
the
in it.
mirage.
It's not real in your field of view.
It's
It's
in the
actually
mirage.
higher or lower in your field of view. No, it's
Zanuck, let
well
him
beyond the boat,
respond.
and it's higher. It's farther
Zanuck, let him
away.
respond.
I'm sorry,
I
Zanuck, but
was
you
in
have
the
a
middle of a
very
sentence, Taylor. Thank you.
you do not have a good understanding. So what we're seeing here is this is a very flat section right here, and we have the mirage. This is kind of like still the start of the mirage. This could still be a mile right here.
It's the water reflecting the sky.
No, it's not the water
Zanuck,
reflecting.
That's
let
what the
him
mirage
finish
is.
talking.
It's the mirage
We're
reflecting the
talking
sky.
back and
So
forth. We don't need you to moderate.
it's the mirage reflecting the sky. This is all the mirage, right? What are you going to say? This isn't the mirage, but this is? This is all the mirage. And yes, of course, the mirage is going to reflect whatever it is bouncing off from whatever angle that is. It's going to reflect whatever that angle is that it's coming from. But as you watch the mirage break up and start to move, and like I said at the start, when I first did this presentation for everyone, unfortunately, the temperature didn't get a couple of degrees warmer, or we would have seen this horizon go all the way to the base of this area. Like we've seen where these houses are, and we've seen all the way to the shore. If this mirage fully broke up, we would see down to that nose area. And if it warmed up another couple of degrees, we would see down to the shore. Now watch out over here. You'll see all of a sudden a boat just appear and come up through here. We see one coming up over here, and we're going to see one come up over here soon. And we see this horizon moving. Now that we see this miraging back here, it's now physically impossible for this boat to be in the mirage because the mirage is back here now. And this is what creates the horizon at this moment. Some people will call this a false horizon. I just say, no, it's the horizon because it's what you see. The horizon is wherever you see it. That is the horizon.
Right.
Right?
I got the picture I wanted to in the
Okay,
chat.
we'll
If you
look
could
at
look
it
at
in
it
a
real quick.
second. Now see, there's, no, it wasn't that one. So we still see the horizon moving a little bit more. The horizon's going to come right to this buoy on this day. We're going to see right there. See this popping out now all of a sudden? Oh, where did it come from? Did it come from below a curve? No, it
I've
did not
seen
come from
that too happen. Like I saw a whole building pop up as the day went on, and you should have been
Yeah.
able to see it. This was over Lake Pontchartrain. It was
Yeah,
crazy. It
nice.
was like in proportion to
Why
the other
wasn't the boat
buildings, you should
missing?
have been able to see it. But then as the day went on, a whole building popped out of nowhere, and I posted it on my Twitter, and I can post it again on here. It's
Yeah,
crazy.
yeah, it's
The
great.
optical effects, man.
Now see this line right here? And this line right here where the refractive layer is starting to move as this
Mhm.
is receding. All these refractive layers are happening in the trough. They're not happening on a peak. This is a peak that's breaking out. The refractive layer happens in the trough of the waves, in the
That is
pits,
a
in the
reflective
little pool
surface.
section.
And I
What do you
think
think
you have your interpretation. I have mine. Why don't you look at my picture? Because I wanted to show you the picture that would dispute
a
what you said.
reflection and refraction are two different things.
But
Reflection.
in a mirage incorporates the reason that you have a mirage is because you have refraction and reflection both working to make a reflective and internal. It's called an internal reflection is what it's called. That's the effect of a mirage. Can you go to my picture in the live stream for a second so I can just show you something you
You
said is
can't
impossible?
dominate though, Zanuck.
I'm
I think
not
he was still
dominating.
trying to.
I was listening to him
I
talk
think
the
he
whole
was
time. I
still trying
watched
to.
his
Were you
pictures.
finished playing
He's been,
reality?
dude.
Yeah,
We
let's
don't need
go.
to talk. I need to talk about this with you.
Where's your picture? I don't see your
It's
picture.
in the live stream. Do you see it?
Nope.
No, she's right, Zanuck. I mean, you're clipping and just you have like
The last
little
picture that I see from
etiquette.
you, Zanuck. Oh, sorry, Gia.
Playing
Last picture
reality. Were you finished with what you were trying to
Yeah.
show?
No, that's cool. Yeah, but we can go back. I'll just look at what I don't see your picture here, though, Zanuck. Everyone can see my screen. I can't see it. Did you put it in live stream text one?
Can I ask you a question? Playing reality.
Yeah, of course.
Have you ever seen that happen where something popped out of nowhere in the middle of the day? Like, I had a picture of 3 buildings across Lake Pontchartrain, and based on the proportion of the other 2 buildings that I could see in the morning, like, I should have been able to see the other one. But as the day went on, just like an entire building, like, poof. Yeah, I can,
Yeah,
post that one again. It was crazy.
yeah,
Can't explain
100%.
it.
I've seen it multiple times. Now, unfortunately, I'm having to use my laptop because for some reason my PC doesn't allow me to share screen on Discord. I don't know why, but it just won't allow it. All the settings are the same, and I just don't know what's going on. But I can take out the sorry, brain fart.
There we go. So the
Oh
picture's
my
in
god!
live stream now.
Hold on, Zanuck. He was talking. I was gonna ask him one more question.
No, that's so cool. Oh my god, Zanuck, really,
Um,
dude? Yeah, go on, Taylor.
I was gonna ask, what is like after looking at all these pictures? By the way, thank you for doing this and thank you for sharing. It's really nice of you to put all this together for us. But what would you say some of your biggest takeaways were in getting all these doing all these observations?
The horizon clearly is not a physical thing. The horizon is when I start saying things like, "Oh, this is where we see the horizon and perspective. We can draw a perspective grid, and it goes to the horizon." I'm not saying the horizon's a physical place. I'm saying that that's the physical thing that we're seeing at that moment. The horizon, as you saw when I played you this, it moves. It's dynamic. It's constantly. It's never in the same spot. Like it just isn't. And Zanuck, you just showed me
Wow.
literally. You showed me a picture, and I'm going to do this again.
You're gonna make the same mistake a lot of people have made in analyzing this. But I was there, and you have to believe what I say because I watched this boat go away from me, going toward Brisbane, and you're gonna say that the Mirage cuts the sail in half. But no, that's a sail that has a. I was trying to find the boat in the harbor because I went down there afterward to try to find this guy, and it was too far away because I got there too late. But I saw him go all the way to the harbor, so I thought I'd be able to
Right,
see this boat. This boat had
right.
a sail
Mirage.
that angled.
Here
Hold
is the
on.
horizon.
Hold on. It angles down and then it hits a big bridge like hull on top, and then it has like 2 layers, like a yacht beneath it. So the Mirage is clearly mid sail, yet there's a hull underneath that. That is the non-refracted, non-miraging horizon. It's not part of the
How would you
miraging
know that?
because I was watching it, Taylor.
Who cares? You're not
I
gonna know if it's
I,
non-refracted or
I
it's
watched it.
just it's
I watched the
radiant.
entire boat while I saw this miraging in the background. That's why I took the pictures, and I didn't take
Let me
enough of them because I
respond.
wasn't really in. Let me finish. I wasn't taking enough of them because I wasn't really into this sport back in the day.
Okay.
Had I known what I was going to come up as far as objections, I would have taken pictures. I would have taken video of the whole thing. So that miraging in back, the inferior miraging, that is Brisbane. Those are buildings at Brisbane behind SFO, San Francisco International Airport. And this boat I watched come from
Hey, raise your plane so
the
someone else can
isthmus,
jump
and
in.
I'm trying to tell you what I was watching. So this boat was where I was, maybe 3 or 4 miles away. I watched it travel 6 to 8 miles for the entire hull to be hidden, yet I still could see the entire way saw the inferior mirage. So
Okay,
that
so it's
I'm
ironic that you
talking
just
to
told me
Paul
to
about
let
this.
you
Why do you
finish.
want to jump in?
Because you made your full
This is an
statement and she
open
wants to reply now.
conversation. This is an open conversation, Zanuck, first of all. Second of all, it's very ironic to say, oh, let me finish, but you did not let him finish. Almost every single time I heard him talking, you cut him off, like within like 3 seconds. So that's just kind of ridiculous. And you would, but based on the Journal of Surveying and Engineering, you would not know if there's refraction or not unless you get the vertical temperature gradient. So just to say this is no refraction, you would never know that. That is your speculation.
What are you talking about? You're not. It's a total complete non sequitur and a straw man. I'm not talking about any refraction or anything. All I
You
said
just
was
said
that
there
there
was
was a
no
mirage.
refraction, no miraging. You just said that.
There is miraging. It's in the city. You can see it. But there's no miraging where the boat is because I watched it disappear.
Okay, can I jump in for a second?
Okay. A boat disappearing does not mean no refraction. It's ironic the boat's disappearing bottom up, that's curvature, but then boats floating in the air is refraction. That's in
Okay, you're
that's
just
not being
making stuff up and
consistent.
you're being non
No,
sequitur
I'm
and straw
not.
manning to
A
death.
boat
Yes, you are.
disappearing bottom up is
I watched the boat without
curvature,
any kind of
but boats
distortion.
floating in midair is
Slowly,
refraction. That's
the hull
inconsistent.
disappeared into the water. Yet I
Can I
could
jump
still
in for a
see
second?
the reflective causes of internal reflections of a mirage, which was developed and it was a very nice day. It wasn't very windy. And the entire time I was watching this boat go away, I could see the hull of the boat go beneath the surface. So go ahead.
Yeah, go ahead, plain reality. But I did just tag you in that thing I posted in the chat. That building popping up in midday. It
Awesome,
was
thank you.
crazy.
Okay, so you know how we
Which has nothing to do
know
with
that
my
this
point.
boat here is behind the horizon, Zanuck?
Yes.
You know how we know that it's behind the horizon? Because if it was in front of the horizon, we would see the whole fucking boat.
And it
You're not
was.
going
Not
to
only
get.
did it get lower, but
No, no, no.
it
Where's the
disappeared
hole? Where is the hole, Zanuck?
underneath the
Where's the boat?
water.
Okay, it
When I-
can't be because this is
It
behind
is.
the horizon. This is behind the horizon. This is not in
The
front
horizon
of the
is the
horizon.
water.
Yeah, the horizon is here, which is in front of this.
No.
This
Wait,
is a mirage.
no, that's not. It's not because I watched it. That whole thing, the sail, everything went down. The entire sail. No, that's not the horizon.
This
It's
is the
close.
horizon
That's
right
what
here.
the angle of that sail is such that I can see
This
this. Other people have
is the
pointed it out
horizon.
before. That is not the horizon. I watched that. That did not happen. If it went closer, you would see the
This is
hull.
the
That's why
horizon.
I'm really mad at myself for not having the entire sequence of pictures at my disposal to show you. That's not. I can see what you say. It's close. It's not quite there, but it is close. You're a
If
little
the
off. Your
boat
line's a little higher. It should be a little higher. So you're just off the angle. But that was an angled sail. It was very clear as I watched you go away. Now you're telling me I'm a liar or I didn't see it properly.
I'm
That's your
not
that's your
telling you
choice.
you're a
But
liar.
all I can say is if you're going to bet your house on it or your life, you would lose. Yes, that
We
angle of the
see
sail,
right
that
here.
angle is the shape of the sail. Stop it. Let me just
See
finish.
right here.
That angle, stop saying I'm wrong. That angle is the shape. That, yeah, and it goes down and attaches to the hull very clearly. And I wish I had the picture of the hull and the sail and just before they disappear because it would remove that doubt that you've just instilled in the audience because you think you know something you don't.
But Zanuck, if the boat was in front of the horizon, you would see the entire boat.
No, because the curve of the earth precludes you
It's
from doing so.
not if it's in front of the horizon.
Yes.
Oh, we've lost Zanuck,
What,
ladies and gentlemen.
what
Oh
the
my God!
fuck are
Yes,
you? Sorry, but
you're
what
just
the fuck
wrong.
are
I
you
mean, I was
saying?
there. You weren't.
Zanuck,
It went as it went away. That miraging area was fixed. It didn't change. I was noticing that. And as it went away, the top of the boat slowly sunk into the water, and there's not a line there where this angled sail looks like that's a point where it matches roughly where the delineation is on the inferior mirage. It looks like it's close, but it's
So we
not
see
quite
what I just
accurate.
typed in here. boats in front of the horizon. Now let's go to images. Okay, now when we look at boats in front of the horizon, what I would like you to do is show me one of these boats where we don't see look, this is a classic one, right? You guys love this one. Boat behind the horizon, boat in front of the horizon. We see the whole boat. Boat in
Yeah,
front
because
of the
what would be
horizon.
obstructing it
We see the
if it's
whole boat. Boats in front of the horizon. We see the whole fucking
I've already
boat.
shown you the evidence.
You're
You're
insane.
denying it. That's your
Boats in
choice.
front of
You're
the
wrong.
horizon.
You
We
can
You're
bet your
see
life
denying
on
it,
it, but you would
Zanuck.
lose your life. Trust me.
That's a good point.
boats
Because
in
what would be
front of the
obstructing it if it's
We
in
see
front of
No,
the
it's wrong.
horizon?
He's absolutely wrong. And I'm not going to argue anymore because you're just going to
boats
deny
in
it.
front of the
Okay,
horizon.
that's what you're doing. You're not going to argue it anymore, and you're denying it.
No, he's
What
denying
is
it.
what's
Boats
obstructing
in
it if
front of
it's
the
in front of the
horizon.
horizon?
Exactly.
The
That's the
horizon.
point.
The
It can't be
water is
That's
getting
a good point.
obstructing it, not the mirage in the hills
How does
behind it.
that work?
Taylor, let me finish the sentence. It's a classic, very rare picture that most people don't have of a boat that's being hidden by the curve of the earth, yet there is still miraging going on into the shore behind it, farther away. Not very many people have
Excuse
that
me,
kind of
did you just say
information.
curve of the earth?
All right, well, I'm
Are
just
you a
saying,
flat
I
earther or are
watched
you
it
not a
and that
flat
didn't
earther?
happen. He tried to say I got it figured out and drew a line. That was incorrect because I watched it disappear, and that's the shape of the sail was a trapezoidal shape.
I'm not calling you a liar, Zanuck. I'm saying you are wrong. It is
I'm not
physically
wrong. I was there. I saw
impossible.
it.
It is physically impossible
It
for
is
something to
not.
be in front of the horizon, but also blocked by the horizon. Unless, of course, what we're talking about is a really large swell and the entire
No, it's a
boat is
bay.
deep
It's San Francisco
inside
Bay.
swell.
It's a
So
bay.
it's
There is
physically
calm day.
impossible. This is the
Calm
Hey,
point.
day.
Wait, I wanted to hear what Plain Reality was saying. You said it's impossible unless what?
Like it's just physically impossible for
It's
anything to be
not.
in front of the horizon, but then be hidden by the horizon because being
It's
hidden
not in
by the
front. It's
horizon,
behind the
Oh, man.
horizon.
then if it's behind the
God.
horizon,
I'm sorry.
it's
Can
not
you
in
try
front of the
one more
horizon.
time? Try one
Like,
more time. Like,
okay, so you just debunked yourself, right? Because you said that this boat is in front of the horizon, but you can't see the hull of the boat. We can, like, people can literally go back, and you said you had a picture of a boat that's in front of the horizon, but you can't see the whole boat. I'm saying this is behind the horizon, and that's why you can't see it. And this is in an inferior mirage. You can clearly see right here the way this breaks up. Right here, you can clearly see this is an inferior mirage. I'm not
yeah,
fucking
what else could be
retarded.
blocking it?
I've filmed this thousands of times. I
That's
haven't
a good
gone out and
point.
done this once or twice. I've filmed this thousands of times. I'm telling you, this is an inferior mirage right here. You can see it right there, right there, right there, right there. And we know it's an inferior mirage because we can see it back here on everything way further away. I'm
Okay, can I
sorry,
ask
dude.
you? Okay, you said that it's physically impossible for it to be blocked except by what? Like,
No,
what
I'm
else
just
could
saying
block it?
if it's in front of the horizon, it's physically impossible to be blocked by the horizon. That's just an oxymoron. That's
Yeah.
like what's that in logic? That is a contradiction in terms. It's like what's the term for that in logic?
Paradox.
Well, it's a paradox and it's a contradiction. You can't have something that's in front of the horizon be blocked by the horizon because it's in front of the horizon. It
Was somebody
doesn't
else trying
work.
to get in real quick for me, Zanuck?
I was saying that
I just wanted to see
this
Paul.
swell,
Can
like
you
if it was long enough, could block some boat.
can you show me the pictures again that you have of that Brighton
Or
of that tower at Brighton Pier
Pardon
between
me
the
one
different
second, Jake.
conditions?
I never said that, by the way. I was muted. You kept on saying I said it was in front of the horizon. It's not. It's being blocked by the horizon. You are asserting that there is a line of delineation that incorporates the boat as well, which it doesn't. I was there. I watched it. And I'm so mad at myself for not getting the string of pictures to show you. I didn't think it mattered because it was so obvious to me because I was there. You're saying it's impossible. I saw it. Let's just end it there because you're wrong. And I never said the horizon. It was in front of the horizon. It's behind the horizon. The water is the horizon. And the other part of the picture that shows the inferior mirage is separate above the horizon. It's a very rare picture, and it is true. I was there. I saw the whole sequence. I watched that boat for a half an hour. So don't tell me what I said and didn't see. It's impossible according to you. You're wrong. Thank you. We can move on to something else.
You said the boat was in front of the horizon. Someone can just
Never
clip
said
it.
that. Go back to the
Oh,
tape.
can
I
you
never said that.
can you
I
pull
said
up
it's
the
in front of the
folder that has
mirage. It's in front of the
that has the
mirage. You
image?
equated mirage with
You
horizon.
said you watched it go behind, remember?
Yes, watch it go behind the horizon.
From in
Oh,
front.
can you pull up
I
the
watched it was
folder
in front of the
that
horizon to
still
go
has?
back behind the horizon.
Okay, so that's
Yeah, I've
when
got
you
that
said
up
in
there.
front.
It was in front of the horizon, and I could see the entire boat, like he said, and then it went over the horizon where the boat disappeared. The mirage was constant the entire time.
why you always like got the tone of freaking out?
And the horizon was behind.
Because they're
The boat was
misrepresenting what
behind
I'm
the
saying, and
horizon.
I get pissed when people do that.
Just chill out, bro.
Because
I'm
you're
freaking out the
wrong.
whole
It
time.
cannot go over the horizon. It absolutely cannot go over the
Okay, that's
horizon
your
in any
opinion.
way, shape, or
Fine.
form.
Move on.
No, it goes into the horizon. But anyway, you can't see my screen right now?
Yeah, can you pull up the folder that has the original pictures in there that has the metadata in the pictures?
Oh, dude. I'm gonna have
What?
to. I can't do that. I mean, they're all completely separate. I'm gonna have to get out of this.
You calling him a liar now?
I just wanted to see something in the metadata in
Well,
the
tell Xanax to
original
do the same with his.
pictures.
Have to wait.
Taylor, quiet.
Show me
Don't poke the bear.
show me the picture where you can't see of Brighton Tower where you see it obstructed by the horizon and the one where it's not obstructed.
Yeah, hold on. What do you want me to do? You want me to? Because I'm gonna have to take
Well,
this.
just those two. Can you find those two pictures, the original pictures, not from your slide, but the original pictures that still has the metadata, where we can look at the metadata of those two pictures?
I'm gonna have to connect different.
I've never heard anybody
You,
ask for a
you don't
metadata from a picture.
you don't have those pictures just in a folder. You didn't just download them off the camera.
No, I told you, right? So I'm on my laptop right now, and everything is basically organized to be plugged into my PC, but I can't share screen from my PC for some reason, so I've had to go onto my laptop. So everything is kind of like hooked into cables that go perfectly to where they will fit into where my PC is. I can try to, and I've literally got 7, 10 terabyte hard drives connected into different things. So I'm going to have to I'll be able to find it. That's not an issue, but I'm going to have to basically go through that and then connect different hard drives and then see if that's the right one.
Well, let me tell you why I'm asking this, Paul, because I'm trying to figure out. Can you pull up those pictures in your slides that you have handy there of the two shots? One where that that tower that's on the end of the Brighton jetty.
I'll get it in the actual.
There's all kind of pictures like this online. This is nothing like. I mean, it is really cool, but I'm just saying it's a common thing. They'll say something's the horizon, but then there's the horizon. But yeah, that's a good point. Like, what could be blocking it if the horizon's like behind it?
It's
Yeah,
not
'cause
behind it.
Okay, we're going to clip it. I'm sorry, Zanik, but we're going to clip it, and people are going to see that you actually did say. Maybe you misspoke, but I literally said, and I showed an entire thing going. If it's in front of the horizon, it can't be blocked by a mirage. I did a whole thing where I showed that, and you said that you had something that was in front of the horizon but being blocked by a mirage.
No, front of the mirage. I said that you.
Doesn't even matter.
And Taylor, please. The boat's being blocked in front of the mirage, not the horizon.
Okay, right. Okay, flip between those two. Here's my problem with these two pictures here that I need an explanation for.
Sure.
Why do we have about a third of the resolving resolution in those buildings between those two shots? If you look at those buildings, you can look at the resolution and how resolved those buildings are. That goes way beyond just the fact that there might be just a little bit more haze. You can clearly see that there's way more there's way less resolvability in the picture. It's way less resolved between the two shots. If these are both set at the same distance and the same focal length, there is no reason to see this. Look at just the detail of the trees between the two, or look at the windows of the buildings. Why does it look like one shot was from 3 times further away than the other?
Because it's a clear day. The difference in the conditions of the day.
Yeah, but a clear day is not going to change the resolving. It's not going to change things that we clearly already have established shadow detail. It's not going to change the difference in the resolving of the shadow detail, regardless of how hazy. Like the hazy is going to reduce the color. It's going to look like the contrast is lower, but it's not going to change the resolution of the shadow detail. And all the
Can,
shadow detail is lost between the two.
can you show
Okay.
my
And
picture?
I'm going to be honest with you,
No
Paul.
offense to
After looking at the
you.
pictures, I know the two piers that you took those two pictures on. I know they weren't taken from the same place.
Okay.
Hey, can you
Well, I
show
can
my
I can
picture?
literally prove it. You want me to prove it? Okay. If you're gonna go down this road, I'm gonna escape from here. But we can.
Well,
Sorry.
I think
Sorry.
I don't. Can you explain why all the shadow detail is gone between the two
You
shots?
see how all these pictures? Are you saying that I went to different places to take all these pictures and then I'm just fucking lying and I decided to post them and tell you that they were all taken from the same spot? Even though we see the towers and the position of the buoy and all the markers all were in the same spot, but somehow what I did was I got onto a boat one day and I took a picture and then I went into a boat the other
Wow.
day and then I went back to the jetty and then I like somehow got
No,
high.
no,
Like,
no.
what are you saying, dude?
A good chunk of those pictures were taken from the same place.
Dude,
Okay.
this is cool.
Yeah. You want like I have no problem. Once again, you want to put
That is
a
very
house on
cool.
it?
I mean,
What do you
unfortunately,
what do you
I
want to
was
put down
looking.
on this?
Unfortunately, the P1000 doesn't have GPS tags in it because it doesn't have a GPS receiver in there. That would be
What
like the ultimate way to tell. So unfortunately,
All
that
right,
doesn't exist.
let's okay, let's do
What
this.
I would like to
Jake,
see.
let's do this, Jake. Let's
kind of money would you like
say
to put
that
down on
both
this?
of those pictures were taken from the same place. Now what?
Well, then I'll happily admit that I was wrong. That's why I want to see the original RAW with the metadata intact for both of those pictures.
Admit that you were wrong, and then what? What's the implication?
Yeah.
Well, then I owe Paul an apology.
And what's the implication?
I don't think that those two pictures were taken from the same spot.
Oh man, that wasn't even
I
15
think
seconds
What do you
into
want
the
to do?
hypothetical good faith. Let's try again. So let's just say that they were taken from the same spot. What would be the implications?
Well,
well, I was wrong.
No, no,
Jake,
but what would
I
be the
think.
implication?
If the horizon's not a real thing, it's not
Well,
geometric.
Jake, I think they're in the same spot. I mean, I think these days can really cause drastic observational differences. But I'll tell you, Paul, I hate you for putting that up there. Now you're going to make me go back there. I did this already. It's very difficult to find a boat that's right in that area where I saw the between myself and the Bay Bridge 92 and in Brisbane, and have a boat come toward me or go away from me. And I've been here 3 times already just for you guys to do this, and I haven't been able to do it since because I just didn't do the right thing when I was there because of my rudimentary equipment. It was difficult to take pictures, but I did that.
Yeah.
So
What would
anyway,
be the
I will now make
implication?
it my life mission, Paul, to go do this, and I'll come back someday, hopefully the
Mm.
next few month or two, and I'll give you the picture that you're looking for with a
So
video.
what would be the implication? Hmm.
Yeah, hold on. Hold on.
Jake, Zanuck.
What do you mean? What would be
Implication?
the implication?
If he took all these images from the same place, what's the implication?
Because that what a streak of luck. What did I say it was? It was September. No, it wasn't. Shit.
This guy really owes us an implication.
We seem to be really fighting the idea that they were taken from the same place, seeming to imply that he doesn't think that it's possible because if it was taken from the same place, it would mean something that he isn't thinking is possible. So if I then ask him hypothetically if they were taken from the same place, what would it mean? The only intellectually honest thing to say is that the thing he's acting like isn't possible actually not only was possible but happened. And instead of being intellectually honest and just saying that thing, he reverted back to the I don't think they were from the same place.
Okay, so this is the
Seems a
30th.
little squirmy.
Yeah, a little bit. Okay, so this is the 30th. This is the exact day of one of those images.
Is this
And
taken from a video?
this is a video now, yeah. But what I'm going to show you with the video is at some stage where I zoom back, see where I am? I'm on a jetty. Now, hold on. I'll have to find another one because I don't. I'll find another one where I pan. So you can see I'm on the jetty here, right? Oh, that was that one there again. Okay, hold on.
Hey,
let me
do you
go
have one that
here.
where you're on the jetty where you took those pictures?
Yeah, this is that's
Okay.
what I'm saying.
Oh
This
yeah,
is the
yeah, yeah.
jetty
This
where
one
I'm
here.
on.
Do you have one where you pan around?
So as I zoom back here, right? So I'm on the jetty here. See how there's water here? And I just
Yeah.
showed
Can you
you what.
pan to the left of there? Can I? I want to look down the bridge, down the pier.
Okay, hold on. Let me.
No, that one that you were just at. That video that you were just at.
Okay, there you go. You'll see here. Wait a minute. Let me do this. I'll close out of this. See, this one was taken at 3:21, 3:24, 3:31, 3:34. These are all done at the same time. I'm not exactly about to run down the other end of the jetty or run anywhere else. And then we go here, right? I'll get rid of the sound. Let's play this so you can see
Yeah,
me
let it
pan
play.
across.
And then wait till you zoom in.
Okay. And now, and then there it all is.
How far
There's
is it
my
to
buoy.
that structure, that tall structure, like the park structure? It's like an antenna or whatever that is, that smokestack. What is
This
that
tower thing.
tower?
That's
Yeah, what
8
is that?
miles. 8 miles.
8 miles to that. Okay.
Yep. It's 3.6 to 3.7 miles to this. I went out one day and I looked for about 4 hours trying to find this. And I eventually found it and then looked
Uh-huh.
exactly straight across from me. I had it dead straight across from me. I saw where I was, and I was Google Earth basically said I was 3.6 miles away from Grange Jetty, where I'm normally filming from. So this buoy is, we can say, from 3.5 to 3.7 miles away.
Well, Jake, I think that concludes our exhibition here. I think the Earth is flat.
Well, it at least tells you that I'm not full of shit and I'm
Yeah,
not
I
lying.
don't.
So,
Yeah, I didn't realize that this was taken from video. So all those shots are from video.
no, I'll show you. Hold on. See how we
No,
got here
man.
photos?
Wait, dude, you're
Because that
so
would explain if
obviously
one shot
doing
was
like
taken from
this
a video
desperate
screenshot and the
attempt
other
to
was
just
from
come
a.
up with any way to avoid addressing it. It's like so obviously what you're doing.
Okay, so I don't know where that picture is going to be in here. So I'm just going to open up all these files.
First, it was that they're not from the same place. Now we're gonna move the goalpost over to it's just a still from a video.
Well, that's why I asked him. The first thing I asked him for was for the metadata for this original shots.
So if they are just pictures from the same place, then what would that mean?
Okay, so here's the pictures that I took that day.
I mean, the pictures are going to have way more detail than the video. That's why I was asking Paul if maybe it's because you took one was from a screenshot of the video and the other was from a still, and that would explain why there's way more resolution in one picture
Look
than
at
the other.
look, I'll tag you in
This-
them, Jake. You can see how today the resolution will completely change. This is mine was definitely from the same exact conditions and photo thing.
Yeah, I
Yep.
mean the
So this
same thing
picture right here.
happened to me all the time. And it changes every day.
So
It'll change throughout the day.
How high off the water were
A
you,
whole
Paul?
building popped up.
20 feet.
Oh, okay.
Because
There we go. That makes sense because when I did that with my picture, for example, I went back up, Paul, and that's why I didn't add to my commentary before. I went up about 20 feet and then saw that boat again, and that mirage area was still there. That's the picture I really want to get. That's what I will get eventually if I get down there. So when I went up, I could see everything out to my area, but the miraging was still there, by the way. And I think 20 feet gives you enough to where you would see over 8 miles. You should see everything. I don't know. You have a curve calculator handy? Nothing will be hidden over 8 miles, 20 feet up.
yeah, about 4 feet.
Right.
That's with standard refraction. So
Yeah.
this area here is 9.6 miles away, and I've had a mirror test from the sand. My mate had the mirror on the sand.
This is a July day. You said July day.
This is July. Yeah. Hold
So
on.
probably a warm. Oh, it's wintertime. Cold day.
Yeah, it would be winter time. Water
Cold
might
day.
be warmer than the air this time. I don't know how warm is that water out there.
It's still cool. Like, I don't know. Well, during July, it would have been around probably 14 degrees. more than likely somewhere
Oh
around
yeah,
there.
that's colder than that's colder than the air for sure.
So that would give you a
Okay,
situation to give you downward refraction, which would loom things up and make it
here we
flatter than
go.
it's.
This is the image that we're talking about. It's either this one, or maybe I took another one. No, yep, there you go. I only got one image of it that day. So this is the image that I showed you. We
Yeah,
can
and
do
that's a
that.
still. That's not a camera shot, right?
Yeah, this is a
That's
camera
not a
shot.
video. That's not a
No,
screen
no, no,
grab from a video.
no. This is a still now.
Okay, okay. So then that other one that we were looking at, is that one from is that one a screenshot from a video?
It's this picture.
No, no, no. The one that you were contrasting in your presentation,
Yeah,
where there
it's
was
this
a
picture.
lot of obstruction. Was that from a still, or was
Oh,
that from a video?
No, that was the 19th of June. Oh, we only go up to July here. No, no, no. Sorry, that's the 19th of September. I can find that. So we can look at that one as well. So that one there was the 19th of September. We can go into September, go to the 19th. I only had the one camera out that day because it was windy as a mofo and it was really terrible. And I can show you just here quickly. Here I am on the jetty again. This is where I stayed, probably at this zoom length, and went through.
Yeah.
And then this one here would be zoomed in more, but still from the jetty. And
seems
so
like
now
more
that,
things are hidden. Seems like more things are hidden on that particular day, though. Would you not agree?
Yeah,
oh yeah,
yeah.
100%.
That's the whole point.
100%.
Yeah, and so
100%.
you're saying I don't see a lot of infrared miraging close to the base of that tower. Do you?
Yeah, well, no, it has to be, right? Because this is the infrared mirage is just building, right? So you can very, very faintly just see it coming in here. It's just starting to happen. And in fact, when I first looked at this, I was like, this
Oh,
is really bizarre
look at those
because there's no
buildings.
infrared mirage. There's no
Look
infrared
at the
mirage, but there was an infrared mirage, right? So this is actually just ever so slightly miraged.
Okay, well, my apologies, Paul. Yeah, I think you must have taken that other one from like a screenshot or something, because
No,
even
go
in
back
this
to the
video
clump of
here, I'm
buildings.
just noticing that when you're pausing, sometimes there's way more detail than others, which makes probably from the compression. So
I'll show
Well,
you.
there was a lot of could have been some fog or
no, I think it's more than that. He must have grabbed it from a video, is all that I can think of.
Well, go
No,
back
I
to
didn't.
that last. Don't I like what you were doing there in the last video, or I think it was video. I want to see the pictures of the houses in the clumps, where you said
Okay.
something was starting to form, but still, we still see more of a. And we see a lot of pictures like this where we see a curvature, and it's apparent, apparent curvature on days like this, because now we have air obviously moving all over the place, moving the air. There's a lot of air movement, so you don't get this stagnation of air. You don't get this transient element of the temperature disparity near the water because the air is moving around so much. So we tend to see a little less refraction going on days like that. Still there, but it's not as dramatic as those calm days, like the oil rigs, same kind of thing. So if you zoom in, or at least go pan to one of those multiple unit structures where you can see the windows, you can see whether they're actually, even by that tower.
Okay. You can
Yeah.
see I didn't used to have when I was trying to get pictures, I didn't realize if I had my camera in autofocus, it autofocused better. I used to do
Yep.
everything in my manual focus, and then I didn't realize that my eyes are getting shit because I'm getting older. So let me
Mm-hmm.
just find let
I
me
get
just
no. I did. I
find
did the same thing. No problem.
so on this day, because it was so windy, I took so many photos, it was ridiculous. So sorry for having to flick through all of this.
I remember even with the ones I did with the boat under the bridge. I had probably several hundred, and had to go through and take out all the ones that were just crap that didn't really show very much. It's a lot of work. I get it.
I think I had to take 900 photos this day. It was ridiculous because it just kept being out of focus. But I'm just trying to show you that, or trying to show Jake that was from a photo.
Yeah, I think
From
yeah, I think Jake was just concerned about why there was inconsistency of clarity of the two photos on different days with the same camera, the same distance. It didn't make sense to him, and I think you've kind of cleared that up.
Here we go.
Well, I don't know why that wouldn't make sense to him.
Well, he just wants to know. He's got an inquisitive mind.
Okay, we'll just find a clearer one of these so I can show you that. Okay, there you go. That's a little bit
That's
clearer.
a pretty good one.
So if I zoom into there, you can see that this is the same photo. If you like, we can then, so 7998. So we can close that now. 799. That's what it said, wasn't it? What was it? Yeah, 7998.
Yes, 7998.
It was just here. 7998. And then, so if I go like that and go get info, there we go. I don't know if you can, do you want me to take a screenshot and then blow the metadata up? And then you can see whatever you want to see from
Yeah,
that.
can you
Good.
maximize that?
Just a
Focal length 539. Interesting. I guess you're not zoomed all the way in there, huh?
It is. Yeah, that's zoomed all the way in.
Oh, interesting. Does it always show? Is that always 539 when it's zoomed all the way in? Wouldn't it be?
I don't know. I have no idea, but yeah, you would think that it wouldn't say 39 millimeters. Let's just let's have a look at another one here. But this is all done at full.
Right.
Optical zoom. These are all full optical zoom. 1000. It says 539, but we can go in and just have a look at it another day. Okay, so you wanted to see this? So like I'll just do this.
Oh yeah. See now that looks way more zoomed in. I guess you're not using the full focal range in those other shots.
No, this wouldn't be more zoomed in. This would be less zoomed in. This is probably at like around 2000. Because see how
Go back to
hold
the
on.
big buildings to the right of that tower.
Cool. Okay, let me just quickly explain this too. Now, if I just skip through here a little bit.
In your presentation, you could see way more of the background, right? So that's not as zoomed in.
No, because you can probably see less of the water.
No, I mean even on the hillside, you could see way more houses from the screen.
Okay. Here's the problem with the P1000, and I'm not sure if other cameras do this as well. In a photograph, the actual field of view is bigger than what you have in the actual video. When you video it, it shrinks in the amount that you can see. So you actually see less.
I got it. I got it.
I don't know why it does
It's
that.
using less
But
of the sensor.
yeah. When you click it onto video, you see less. So Zanik, you want to see this?
Yes. Yeah, right there. Okay, I don't see much miraging toward the water there. That the shore is gone, and these houses, there's no real line of any kind of infrared mirage, and right near the surface.
It's super
So
hard
what-
to see. Super hard to see, but I'll show you here. Right. So, so that it gets to
And
be
it can't,
clearer.
but believe me, it can change via different directions because the air qualities change in different directions and over that area.
Yeah. Now this is where, like, I actually didn't even think that there was miraging here to start with, Zanik, right? Because I was looking at this footage going like, there's no miraging here. This is crazy. We got 20 feet missing at just 8 miles with no miraging. That's insane. Right. But it's really hard to see. And you can just kind of see over here how there's just starting to be a little bit right there. It's really difficult to see.
Yeah, but not 20 feet. The water line, everything, the buoys, everything's different than the calm day. You would agree, right?
Yeah, 100%, right? Because like I'm explaining to you, the horizon is the furthest visible point that we can see. You can't see the surface of the water or the ground or whatever it is beyond the horizon.
Beyond it. I agree.
So
We all agree.
our perspective, the way that our perspective works is our perspective can only go to the horizon. So when I showed the one on the other day, and we now see further, now our perspective goes further and everything. So these things that are at 3 miles, when all of a sudden now our perspective and we see further down to 9 miles, this has to drop and change because now whatever's at 9 miles away is on the horizon, and the horizon is the highest visual point you can see. So see how, just as an example, this little bit of a wave is below the horizon. It's not actually below the horizon, right? We know that. We're not dumb. But perspectively, the way that a perspective grid works is that everything down low is closer to you. And as you go further away, everything climbs up the perspective grid.
But the where it is angularly, it makes all the difference in the world. How much it raise, we all know it's going to raise. That's due to geometry, trigonometry. That's all known. But the rate at which it does change is what we're talking about.
Yep.
We know it will
So as
change.
an
How
example,
much it changes is the question.
Yep. So what I showed in my presentation and through the actual video, I showed you what happens when I'm looking from one jetty to the other and my friend is looking from that jetty towards me. And we filmed a boat like this going in between us. And I watched the boat go up prospectively. It went into the mirage, and before it gets to the end of his, or actually, sorry, it starts to come out of the mirage for him and go down, and then it fully disappears for me as it starts
Yeah,
to go down.
that's fine. That's expected. And that's due to
Now,
perspective.
see how this boat here, all of this is visually below the horizon.
As it should be.
But we know that it's not actually below the horizon, right?
Angularly, it is.
Yeah, but it's not actually, though. Physically,
Yes,
it's
actually,
not.
yes. Trigonometry and geometry is actual.
Well,
It's
yeah,
like
but in
it's
the
like we started out the conversation, Paul, talking about we started out the conversation, Paul, talking about my guitar on the floor in the corner of my room. I have to look down to it. Now it's the same level as my toe. Why do I look straight down to my toe and look at a 45-degree angle to my guitar? Because I'm 6 feet tall and the guitar is 6 feet away. It's going to be a 45-degree angle.
Okay, but what we
Trigonometry
know,
is math, bro.
That's right.
but what we know is that the base of this boat
That was useful, by the way.
is at the same level as this, right?
What's at the same level
This,
as that?
the base of this boat isn't actually below this point right here, where the water
Correct.
is here, right? Okay, it's all visual. Now I'm trying to show you. Let me see if we can. No, see, it's still really hard to spot the mirage right there. I'm going to have to go into one of these ones. Not that one. Okay, here. So see, now we see this boat here. So I showed this in my presentation as well, looking to be below the horizon. But then I show you on another day where you can see all the way down to the shore here. And you see a boat that's miles further than this, all the way to the hull with the horizon still behind it. It's in the presentation. Now, when we get over here, now, if you look in this area right here, this spot right here, you'll see lights appearing. Go back. Now, I don't think I can zoom here. No, I can't zoom that. But you can just see a little dot forming here and a little dot forming here. And there are these two dots here. It's really hard to see. I may even have where I've stabilized this footage. But then
Wait,
I'm
go
going to
back
have
to
to
the
go
boat that's hidden. You're saying that because that boat is beyond the horizon, we can't see it.
Okay,
Is that what
so
you're saying?
this boat right now, and I can go into, I can't right now because I've just changed.
You can walk me through it. I'm not going to
Changed hard
fight you.
drive. Okay, so this boat here, a lot of people sit there and go like, oh, what are you trying to say? That the hull is actually down here? And then they put a
Yeah.
boat and they go, you see this hole? You trying to say that's there like that? Yeah, that's
That's what,
exactly what I'm saying. Because prospectively, if you're on the opposite side of that horizon, you will see that hole right here. And if I put a boat right here, we're going to see the same thing. the perspective of these two things are exactly the same. They're just on the opposite side of the horizon because the horizon is your dividing line of
I
perspective.
totally agree. I think Jake, do you agree as well? Jake's not paying attention anymore.
Okay,
Yeah,
so
I
the
couldn't
horizon.
sperm out. Yeah, it was different.
I stepped away. Sorry.
Do you agree? I think he's putting this in interesting terms. This boat, we would say that the water is curving, and that you're on the other side of this curve. And if the boat was closer to me, like it is to your friend on the other shore, it would be below the horizon. So we would see the whole hull, and it would be the tops of the masts would not really line up, but they would be following the laws of perspective or geometry.
And what we would see is that, let's just say if I was to put this same boat in the same position here, we would have the boat sitting here and the sail would come up, and this section of the sail, although this is an inferior mirage, so it's slightly different, but let's just,
Why
for
do you
shits and
say?
giggles,
Look at how it's angled. It doesn't look like it's cutting back at all. It has a distinct angle coming
yeah, I know
outward
that.
from the tip. It's not coming back in. So
Yeah,
that
but
boat
there's
is
an inferior mirage there.
where? Show me the for mirage.
I did, but it's super tiny,
I
right?
know it.
But
I
what you
don't
don't
think
under,
it's
but what
not
you don't
tiny. It's not
understand about,
large enough to hide the entire
yeah,
hull, which is.
yeah,
So you're saying the hull is actually where that bottom of the sail
no,
is? There's a hole there. We're just can't see
no,
it.
no, no, no,
Well,
no.
that's
It's
what it has to
being
be because
swallowed up
things in your
below the
things
inferior
cannot.
mirage. All right, it's being swallowed up below the inferior mirage.
The water is not
And the
inferior
inferior
mirage.
mirage, the inferior mirage. No, the water here is not inferior mirage. No,
Even to the sail,
but
right there. That's everything to the sail is not inferior mirage on the
no,
water.
yeah, the inferior mirage is teeny tiny,
Starts there.
very tiny. Yeah,
Okay, but where's the
when you have
hull?
waves and stuff as well, it's much harder to spot the inferior mirage when you have waves.
I agree. I don't care how big the
Problem.
inferior mirage is. You should be able to tell me where it is, where the hull is hiding in the inferior mirage. Because
The
I
hull
did
is
some
hiding.
I did some analysis to
Okay.
I think one of Travis's pictures, and we started comparing sails and the masts that had actually lookouts and things on them, and we started looking at the angular size of them for where they were with each frame of the picture that he produced, and it didn't add up for what you're saying. See, you're just
Okay.
saying it. You got to look at if there is an inferior mirage, and you got to say what the angular size of the inferior mirage is. Where
Well,
is
remember
this?
this.
Where's the hull? Yes,
Remember this, and
yes.
how this hull appears to be below the horizon.
That's due to perspective. That's an angular
Exactly.
identity.
It's due to perspective. And on the opposite side of this horizon, it's also due to perspective. Now, if you want me to go into it, let me close this out and I'll show you. I really should go eat. I haven't eaten, but I'll keep going. Oh, no, wrong one. No, no, no.
It's like when I show you the picture of so back to the windmills. When there's 200 feet of this thing missing, and always seeing this thing down to the annulus on the water with one blade sticking.
Good thing we're now establishing that that occurs and has nothing to do with
Thanks for the
curvature
interruption.
of
I
Earth.
appreciate that. We're not saying that at
No
all.
problem.
He in his own way is actually talking about the curvature, although he's saying
Okay.
it's really something that's being absorbed into our line of sight via the mirage, and that's where his error starts and ends, in
Okay.
my
So let's
opinion.
describe this. How would you describe this? That as this boat moves further away from the horizon, we see it disappearing from the bottom up.
Yes,
So it's moving away from the horizon, right?
it's moving.
As
What do you mean it's
as
moving?
it moves further away from the
Yes,
horizon, we start
it's
to
going
see
away
it
from
disappear.
the horizon. Correct.
Okay, cool. And now, as this one moves closer to the horizon, we see it rise up. Correct? You agree
Yes,
with that wordage?
yes.
Okay, right. So, I mean, you can have a quick look at this as well. Where did I go there? All right. Okay, so what we're going to watch here is this is what happens when, because it happens, both of these boats aren't moving. Okay, so as I drop myself from a high point to a low point, what we see is a teeter-totter, right? We see this teeter-totter. And as I go lower, that's bringing the horizon closer to the boat on the left. And it's moving the horizon closer to me as well, like for both of them. And as we move the horizon closer, what's going on is that boat behind there on the left-hand side is now going to appear to drop below. And as we move the horizon closer, the one in front is going to appear to rise. But if we get rid of that, what we're seeing is this. We're seeing this perfect mimicking, teeter-tottering of each thing. Now, what did we describe before? We
Well,
described that
hold on.
as the boat
Before
gets
you go any
closer.
farther, Paul, I agree with all you're saying, but the
Dan,
rate
can
at
you let him
which
finish? You always
okay,
come in at the absolute worst times. Like you
well, I
just
mean,
clip and interrupt every time. Can you just figure out how to not do that?
well, sure. I thought it was an appropriate time to put a key point in, but go ahead. I'll wait till the end. Go ahead.
Oh, good. All right. So now what did we establish before? That as a boat moves closer to the horizon, and I'll escape out of here so you can see what I've done here. We have this sticking up just over the top of the horizon, and we have a boat here on the opposite side of the horizon sticking up over the horizon. As they both move closer to the horizon, what we are going to see is both of them appear to rise up above the horizon or onto the horizon. And now, what else did we also establish? As a boat moves further away from the horizon, it will now appear to drop below the horizon. So, as a boat moves further away from the horizon, it will now appear to drop below the horizon. Now, what we know is that on our side of the horizon, it's perspective, right? We know that. We can see it. We know that it's not actually physically going below the horizon. It's all perspective. It's perspective on both sides. There's no difference between these two things. This is perspective on both sides, right? Now,
No, that's not right. But
I can show you this, right? Now, let's just skip through all of this. Okay, here's a picture that Travis took where this is the same boat. This is Travis the Plain Truth, Omni Copernicus. This is the same boat. Let me just I'll do this instead so I can point. So these two are the same boat. He had a friend on one side of the horizon and he's on the opposite shore. So he's on one shore and he's on the opposite shore. Now here we have an inferior mirage because why? This is in front of the inferior mirage is always going to happen behind the horizon because the inferior mirage will cause a new horizon. That's what the inferior mirage will do. It will create a horizon that is closer to you. Now this is how Travis saw it, and due to it being an inferior mirage, he's seeing it cut up here in the sails. Sorry. Now on this side, we are seeing the same thing, but because it's not in an inferior mirage, there's no inferior mirage here, so we're not seeing it cut up here in the sails. We're only seeing it cut here on the boat. So we see the horizon cutting right here, right? So that's what we're seeing. This is where the horizon is cutting across here. Now let's go to this. Now this is mine. Just happen. This is not any cutout. These are two boats that just happen to be in the same position, literally within probably very similar position from the horizon, distance away. And what we see is this boat here cutting across here in the horizon and the sail coming up here. And we see this one with the horizon cutting across here in the sail. If I just do this and I add a boat here, we're going to see this boat all of a sudden be right here on the horizon.
And that's
just
not where they
below
should
it.
be.
And
You
this
wanna know
one's
why
going to
that's
be
not
here like this.
that
Or
can't
maybe
be
this one would
possible.
be a little bit lower. Maybe it would be a little bit higher, but it's not going to, it's going to be in this kind of vicinity. And that's what it's going to look like from the opposite side. Right?
I agree that
Now,
you see. Can I make a comment, or do you want to keep on going? Because I
no,
think I'd
no,
like to
make
click.
a comment by all means.
Pardon me? You want to keep on going? Okay.
No, make a comment. I'll do
Okay.
this in a second.
So going back to that picture, I mean, it seems logical, but you throw out perspective when you do that. They could be the same if they're the same height. Those sails, the peaks of the sails, then that would be fairly appropriate. It'd be very close. But when you bring that boat closer to it and you line those sails up as where they should be, That's not correct due to perspective because the farther away, if you're observing these two boats below the height of the top of the sails, then the farther away sail will be lower in your field of view than the foreground. It's easy to say that, oh, no, they're going to be in line, but they're only in line if you are going to be observing these two sailboats at the same height as the top of the sail, which
Oh,
you
you're
are not.
saying when I did this?
That would be
You're saying
impossible.
when I-
That wouldn't be possible.
Okay, yeah, but that's just a bit of semantics.
That's an
on what's
important
going on.
point. So I think it's
This could
interesting
be
because
slightly higher, but either way, what we're doing is
slightly
we're showing
higher.
that these,
If it's twice
these
as
two
far
images.
away, if it's twice as far
Oh, yeah,
away,
it's going to
it'll
be
be
lower.
twice as low in your field of view.
Yeah, well, it could actually be even slightly lower. That's cool. I don't have a problem with that. But what I'm saying is that what we are actually seeing is that this boat here is in a similar position, right? So it's a similar
Yeah, I think
position to this one. It could be
it
slightly
feels so.
lower, but I don't think it's too much lower because if it was,
It'd have to be.
we would see way less of the sail unless this is friggin' huge, and I don't think
Well, I
it
think they're
is
two different boats and
because
must be a larger sail
this is
too,
miraging from here.
and it's a
Now,
larger sail.
now let's go to this, and what do we see? This is we're watching these boats move away from the horizon, and they're physically dropping below the horizon. See what's going on? They are moving away from the horizon, and they are both dropping below the horizon. Okay. Now, does that remind you of anything? If you were looking from the opposite side, how the sail drops below the horizon? Now, when we look here, and we just on the right hand side there, I've just covered it. We're imagining what we're doing is looking at it from the opposite side of the horizon, and we see the boat rise up. And as it comes back closer towards us, we're going to see it disappear from the bottom up. Has nothing to do with Earth curvature. It has everything to do with perspective. All right.
I don't know how you can
Now,
say that, but
is,
okay.
But
is
you
this just
acknowledge that it would be the same. It'd be the same for a person walking up and over a hill as well, and the person's videoing from the other side of the hill and seeming to be obstructed by the hill. It'd be
The
the
whole
same
point
thing, right?
The
cool?
whole
I don't
point,
care.
Paul,
That's fine.
is that
You
it's
go
the
first.
rate of change. It's a rate at which these things fall and rise. That's what we're disputing. It's not saying that it won't fall and rise. It's saying that actually it won't fall if it's flat. It would continue to rise up to eye level if it was at the same height of the observer.
Right. So without fail, 100% of the time, when something moves closer to the horizon, it rises. It appears
Yes.
to rise. And when something moves away from the horizon, as we're going to watch this move away from the horizon, it's going to get to a point right here where now it appears to be below the horizon because it's now further away from the horizon. And as it
Because
goes towards
it's
the
closer to
horizon,
you by basic geometry. That's
right,
closer to you. Why does it go down after the horizon? I mean, we're saying the same things. We're making different conclusions, and I think it's admirable. You've done all this. These videos they're
why does it go
fantastic.
down?
But
It goes down
you've
because of
drawn the wrong. Hold on. You've drawn the wrong conclusions, and I can say that
No, he hasn't.
confidently, because perspective doesn't work that way. As it gets farther away and it hits that horizon and starts going down, why would it go down? If you're an observer on this piece of water that's supposed to be flat, anything that is below eye level will rise to eye level. Anything above eye level will go down to eye level and not go
It's called
a micro
refraction.
angle below eye level as it gets farther away. There's no reason for it to do that.
Okay.
You haven't really thought of that, I think, maybe.
Called
It just seems kind of crazy to me. I mean, I love the
Okay.
videos. You're taking fantastic stuff, but you're just drawing the wrong conclusions.
Okay. So here we go. This is where I got a friend of mine in this boat to go from my jetty to the opposite jetty. So I'm now currently standing on Brighton jetty, and I had a friend over on Grange jetty. And so what I have said to you and have put forward is that we have this visual ramp right here, and this is perspective. Over
Granted.
here is Grange jetty. Now, unfortunately, I wanted him to just go straight, but I forgot about the fact that I have this privilege of knowing that that's exactly where Grange jetty was. His GPS told him to go all the way out here and then cut back down again. So it was a little bit difficult for my friend to find him straight away. Now, what happens is we watch him go up a perspective grid until he hits the horizon. And I deliberately wanted a miraged horizon because that way I knew that there would be a horizon between us. So this horizon on this day was at approximately 3 miles away for both of us. So there's 2 miles of inferior miraging. There's 2 miles of mirage area. So now this has reached my horizon. He should have been able to see it over here right now, but he didn't know where the boat was. He's looking around. He was actually getting quite frustrated because he couldn't find it. So he was kind of getting a bit annoyed. And I'm like, dude, you got to pan to your right. And he's like, my right, you're right. And I'm like, no, you're right, bro. Pan to your right. So he's like panning to his right. He's looking. And then you see all this area down here, which we were looking at before. Okay, he couldn't see it. I think actually it was just there a second ago. He couldn't see it. We see I'm over here on Brighton Jetty. See this visual ramp that he has right here now? And my visual ramp right here? Okay. So he pans across and boom, there it is. He sees the boat now and I'm like, yeah, you got it. Right? So it's in the mirage here now. Now what we're going to do is we're going to watch it come down this ramp for him and disappear for me. So it's going further into the mirage and it's still in the mirage there for him. And now as it keeps going further and it's about to break out of his mirage, about there somewhere, right? So we see the horizon there. So it's about just broken out of the mirage now and it's about to come down for him. Okay? And I'm still having it miraged here. I can still see it. And now as it starts to drop on his side, I'm starting to lose it. This is perspective. He's dropping here in perspective. Nothing to do with the curvature of the earth.
No, the rate at which it drops is what we're talking about, Paul.
Right.
You have to acknowledge that, right?
Then-
They both would drop in
then
both
what's
scenarios.
down here?
It drops more on the curved earth, right? We have to agree to that at least.
No, I wouldn't probably agree to that.
Well,
I
then we
mean,
have
no, I don't know.
then we're done. I guess we're done at that. That's really obvious to everybody, but
And
maybe
so right here, right, well, let's go. Right there is pretty much where I start to lose it, where his roof is still just slightly visible, but it's gone for me now. So then he keeps going. Oh, let's get to about here. And this is where the water line is here now. And the boat's all the way down here below it. I can't see it. And now from this point of view here, we see the jetty right there. We see Brighton Jetty right there. Then he just turns around. Oop, and we do it from the opposite way. Now, either this week or whenever the conditions are right again, we're going to go do this from the 12.6 mile observation. And I want to try and do it when there is no mirage in the way. So that way we can still have a horizon being at 12.6 miles, but we've got to do it on a day when it gets warm enough so there is no mirage. And now here we see it's in vision for me. And as it starts to come back down again, which is here, starting to come back down again now, he starts to lose it. Sorry that he had it blurry. I told him how to get rid of the blur, but he couldn't work it out. And then now the boat starts to come back down towards me.
who's paying for the gas for this little excursion?
I did.
Hey, get your boat and take it out 12 miles and then come back. You're 24 miles in their boat just so I could
It's
go.
not cheap. You know, I mean, I had to give my mate a few $100s for this.
I know.
You know,
It's a lot
I've
of
done
work.
all of this.
Great
Oh,
video, by the way. Good job.
I've spent a lot of money doing this over time.
I think
Never received $1 for it. So,
I hope,
and I'm not
yeah,
asking for $1 for it.
I know these are what our inquiring minds
Right.
wanted. They want to know. They
And
want to know the truth. And you're doing a lot of good
the
experience. But why do you think it goes over over the horizon? Why do you think there is a horizon? Why doesn't it continue to go straight out into the distance? Why does it have to drop? Your perspective argument doesn't quite work because the only disagreement we are having is a conclusion that we're making by what we're seeing. The perspective works. The only difference between perspective where things are ramping up and then ramping away is the fact that the rate at which it ramps is the only difference. And why it goes down though is a big difference too. Why does it go down after it's past the horizon? Why is there a horizon?
The horizon is the dividing line of perspective. So here we have
that's not true.
This here is this, right? So
what is a dividing line of perspective? I know you're explaining.
So this boat here is this boat here, which is what she's seeing. She can just see the top of this boat here. He can just see the top of the boat here. They're both going to watch it go up, just as you saw in the video I just showed you. And as that happens, they're going to watch these boats also come up. So that's
but
what
that's not
seeing.
that's not reality for perspective. Perspective doesn't.
I just showed
clearly
you reality.
States. No, I know you showed it, but that was because the Earth is.
Yeah,
but
see,
that's not
this
how
is the thing, though, Zanik. Is what I'm showing you is
if I was
something
going
that
to
has
fire a
never
laser.
been. Wait up, Zanik. Let me speak for a second. What I'm showing you is something that has never been described before, ever. No one's
you're
ever
right.
described this before. So you're going to need time to soak this in, and many people are going to need time to soak this in. I started showing this a year ago, but now I've actually gathered so much more evidence for it that I'm showing this evidence now.
Well, I think sometimes
I'm not.
Xanax, chill, dude.
Yeah.
Well, he made a pause. I was going to make a comment.
So we watch it go up, it hits the horizon, and we watch it come back down. Now, this is what they're actually watching from their perspective sides. So they are both looking at this image on the right. For both of them, so we can see that that's the back of the boat. As that boat moves away from them, they are both watching the same thing. They are both going to watch the back of the boat climb up, and the boat in the distance on the horizon also climb up. We know that they're both watching perspective, right? So they're both seeing the exact same thing from either side of the horizon. It's no different. Once it hits the horizon, it gets there. Remember, we established that when something moves towards the horizon, it rises up. And then when it moves away from the horizon, it drops. We established this. We established that that's what happens. We went over that.
There's no reason.
Right here. I just showed you the reason. You just don't
No, there's
understand
no reason because we know due to perspective, due to simple geometry, if I have something that is at eye level, it will go farther away and will never change my center. It'll try to move a different up or down, but it will always stay at my center field of view for indefinite distances. It will not go over a hump. It will not go up, and then it will ramp out angularly because that's how perspective works, but it will always stay at eye level. Something at eye level 100 feet away versus something at eye level at 5 feet away is the same angular position. If it's at my feet when it starts out, this is what you're talking about. This is also perspective. So both can be true. Something at eye level, out to infinity, stays at eye level. You can't accept that. That's okay. We're going to get to the bottom of it. Because, hold on.
Can I ask you a question, Xanax?
Wait. Let me finish the last part of my statement. I was quiet. So something at your feet that is below eye level will, as it goes farther away, will rise to eye level, and the rate at which it rises will depend on what the surface shape is, round or flat. Now, if it's round, it will go to a distance, a apex, and then start going down like you're clearly showing. You're showing more round earth truth than you know. But if it isn't, hold on. If it isn't round, then it will continue to go off in the distance until it is up at eye level. It'll never get there, but it will try because it's always below eye level because we saw it at our feet when it left. But it never will get there due to perspective, but it'll always go up. It will never go down like you have misassumed here. And I hate to say you spent a lot of time on this, but I think you
land your plane, dude.
Well, I want to give him credit for doing all this, and I think
You've done it 12 times. Just like
I think
make
he
the
will come
points
to
go
a
back
different
and forth.
conclusion once you understand that.
Okay, we don't need you to say
We
that in a
talked
different way
for
every
an
time.
hour. I can't say 30 seconds?
Because all you're
Yeah,
Yeah, I
saying is
know.
like, well,
I'd
I
like
think,
people to be fair and each person speaking in a length of time. Don't be
Okay,
unfair.
Zanuck, I was wondering, this seems like kind of the crux of the issue to me. Can something be obstructed by the Earth before it reaches the horizon?
No, the horizon is that is the Earth, and is what's going to obstruct it.
Okay, so what if we're seeing bottom up obstruction like way before it even reaches the horizon? What's going on?
That can be caused by miraging as well. You can
Okay.
still have things obstruction by mirages.
Well, I think we made a lot of progress. What do you think? Plain reality,
well, I
if he
don't know. I
acknowledges
think
that.
plain reality is making a different point, which is like what Xana keeps responding to is like, no, based on my understanding of perspective and the geometry that I use for it, then we know this will always happen. That can't take place, even when he's showing him videos of something other than what he's describing taking place in reality.
Exactly. And what I'm introducing, again, it's so new. Like this has never really been shown before. And humbly, let me be saying this as humbly as I possibly can, is that this has never been shown before. This is the
Can you
first time
summarize what you're
anyone.
showing? Like
Okay.
summarizing?
Yeah, well, summarizing, basically what I'm saying is that the horizon is the dividing line of perspective. All right, the horizon divides perspective. So
I don't agree with that. I think if you had a
Let him
Xanax.
finish. I think he was still talking. Were you done
yeah,
playing?
no. So the horizon is the dividing line of perspective. So this is what I say the horizon is. The horizon is the furthest visual point where you can see the surface. Not controversial. It is the
Right.
furthest visual boundary where the sky appears to meet the ground or water. Also not controversial. It's all visual, and all visual paths converge to a vanishing point. But the difference is that what it is that it's where perspective convergence ends and perspective divergence begins. So once we hit the horizon, we also have perspective going on the opposite side, but it's just divergence. It's the exact same thing. There's no difference between the two, except for the fact that when we're watching something go further beyond the horizon, it's going to get smaller. And when something's in front of the horizon, it's larger. That's the only difference. But when it passes the horizon, perspectively, we are going to watch them drop. Is that a
So
good
he's
enough summary?
saying that like if you take like if you look at railroad tracks, right, they're going to converge into the distance. Now imagine those railroad tracks just representing our perspective. It's converging, and then it gets to the horizon. Once you get past the horizon, they would begin to diverge out, and that
Yeah, don't look at any
horizon would be
symbols.
dividing. That horizon would be the dividing line of perspective between the convergence to the divergence.
Well,
Exactly.
here's the
Yeah, and
real
hold on. Let me
Just
jump in to say I
isn't
have
it?
this image real quick. Have you seen this plane? Have you seen this image? It just shows a
Hold on one
perspective
second.
matrix. You've probably seen something like this. It's not necessarily incredibly fancy or anything, but if you want to just check it real quick, I put it in the live stream text. It just shows the convergence and divergent like you're referring to.
Oh, right. Sorry. I was already right there. Yeah, exactly like that.
Yeah.
So we have convergence going up and then just divergence going back down again. That physically happens. That's how we physically see the world.
I have one. These are old ones that I have. I've had them in the folder forever because we used to. But anyways, this one's kind of an animated version. But yeah, it just reminded me of what you were
Yeah.
talking about. But yeah, dude, this is awesome to think about it this way in terms of seeing it. It's like a mirror, seeing it from both sides.
Mm-hmm.
It's really interesting. It opens up a lot of new considerations in my mind of like ways this could be tested, because of course people are going to want to know, how is this exclusive between being over a planar surface with a planar grid of perspective versus what the globe would the globe would claim is a curve, and everything that would be involved with that, because there is some overlap. Like if you had a hump of water, some of these things would overlap, but there certainly are differences, and that's what would be interesting to think more about. Tests that can be done and ways that can be done to isolate and show which one's exclusive.
Okay. Now, I think it's exclusive because perspective, personally, is always drawn over a flat surface. It's always predicted over a flat surface. We have Sky Free, who has done all their observations over a floor, flat surface, over just a few hundred feet um, of a lake, a flat surface. I said earlier how I'm actually building a 10-meter long perspective grid that's 40 centimeters by 40 centimeters square, and that's separated by 20 centimeters for each section. And I'm building that 10 meters long, and I'm going to put like a little perspex pool all the way along it to create a water environment. And then I'm just going to run a camera and put things at different sections of that, just run a camera for hours of the day, put temperature gauges there, put boiling water in there to warm up the water, put ice in there to cool it down, and then just watch the refractive effects happen and watch what happens over the day. You know, and that little experiment that I'm going to do there, that's going to cost me about $2,500 to do that. The shit ain't cheap. But I think I'm going to get some really cool things, and we're going to watch stuff disappear at less than 10 meters away. And if anyone wants to tell me that the water from that point 10 meters away to the point 10 meters closer is curving at some kind of drastic rate to make those things disappear, well, I've got some land on the moon to sell you. It's ridiculous.
That's what they will say, probably. But so,
Well,
you know, what's so fascinating about hearing them back and forth here is like he's showing you the video of it happening, and then when he goes and describes what's happening, you say that can't be happening because we know how it works. Here's the geometry. And
almost.
basically,
Go ahead.
what you're saying is just that it's like one way, and it just goes infinitely, right?
Yeah. So math works, you know, in mysterious ways. This is obvious to me. It's not obvious to Paul, and I respect Paul for all the work. He's not a dummy. He's a smart guy. But the problem here is this idea has a critical flaw, and the critical flaw is due to one of the fundamental laws of perspective. And that fundamental law I already pointed out
You said
that
it 12
things
times, bro. You said it.
I know that things but he's saying that that's not true. At the horizon, all bets are off. We have a convergent perspective, and then we have a divergent. And this is his own conjuring. He's come up with it himself. No one else has done this, and he's right. He's the only one. And I commend him for thinking hard about this. But let me ask you this, Paul: wouldn't it also be true, this divergent perspective? Wouldn't that also occur if the Earth was round? Would we see some of the same things? We could be misinterpreting it as round, and you could be right because it's how perspective works. Or if the Earth is round, wouldn't we see the same thing?
Are we going to see things disappear beyond the horizon? Yeah, of course.
Okay, so we're both
But
saying
so
we both love these videos, and we both know that this is going to happen. Your cause and effect relationship description is going to be different than mine, and you think it's due to this perspective law that's been overlooked for centuries. That this is actually what's happening, and I think the video you have. I mean, I can't say enough. It's fabulous, unbelievable stuff. I love the video, and I love all the different slide up and back animation. That's fantastic too. But I just think there's a flaw in it because I think there's no reason in my mind to think that the geometry has an exception because you've replaced it with something different. That shows that there's a divergent perspective after a convergent perspective.
Cool.
At the
So let's
horizon.
just say for a moment that what I've done is now offered a full working description of how this works on a flat Earth. Okay. Now, you can still say that, oh, well, it would be the same on a globe Earth, but I'm now describing and showing to you and to everyone how it works on a flat Earth. So for people to then turn around and go, show us how it will work on a flat Earth, I just showed you. Right?
It's go
Because
ahead.
when I go to these other images again, right? And like there's a whole bunch of stuff that you didn't see within the presentation. And again, what I would say is, take the time to go
I
back
will.
and have a
I
look,
will.
watch it,
I'll watch it.
Now, I am
Yeah.
by far nowhere near the smartest person on the earth and nowhere near the smartest person in this room, but I'm not retarded. And what I've gone and done is shown a whole bunch of things that have never been seen before. Now, when we look again between this image And this image, what I'm showing you with this image is that when we have a day that is a virtual, for all intents and purposes, a perfectly flat looking ocean, that's when I see all the way to the shore and can do a mirror test from the actual ground, from the sand. So it's interesting how every single time we have this perfectly, well, not perfectly, I can't use those words. Every time we have this visually flat surface of water, then we see the furthest we can possibly see. And what happens is every time I go out there just for something fun to do, and I never, in general, I don't talk to people when I'm doing my filming and stuff. I don't talk to them about flat Earth. There's a few that I have, but whenever it's flat like this, I always comment to people, wow, it's really flat out there today, isn't it? And they're like, yeah, it's like dead flat out there. So on the days where it's flat, we get this, unless it's an inferior mirage, and then the inferior mirage will still be hiding stuff.
And
But
you're
this is
saying
what we
that
see.
because this happens, the obviously the horizon is now out by the base of that shore or the what do you call that structure?
I just think you should keep listening.
I am. We're listening. We're going back and forth. There's nothing wrong with what we're talking about with it. He has described something that is flat, and we would tend to agree with him. That
Wait,
over this,
but what happens is so much of what he says gets lost, right? Like, for example, he just pointed out, like, he finds it interesting that when we have these favorable conditions and we look out and the water's super flat, that's when we see the furthest. You just skipped
yes.
right over that. You just
No, I
skipped right
didn't.
over that.
I actually
Okay.
said the horizon has now moved all the way to the shore
The,
to the structure.
the,
So I actually
the,
acknowledged that.
the,
So I was going to say, I was going to say. So if you didn't cut me off, I was going to finish my one sentence. It wasn't going to be very long. In that we now are in agreement that when that water is flat, it is flat. The horizon has risen up, it's farther away. You see farther, and this effect that he's talking about, this divergent perspective, happens after it, which we can't see. But what I'm saying is that is caused, and he might even say it's caused also, and we both could be agreeing that this is caused by refraction, not due
okay,
to the
see,
curvature of
wait,
the Earth.
can you, right, just a sec, bro. So this is where your paradigm will then say that when it's clearer outside and the water appears flatter outside, and we thus see further outside, that's when there's the most refraction occurring, creating that illusion that it's super flat and that we
No,
can see further. That
no,
is the required position
no,
from
because
your side.
not at all. And so I'll retort with this one quick sentence. No, there are some days where we have it flat and then it looks flat as a, like I'm a big water skier, so when I see flat, get pretty excited when it's flat and there's no waves. And some oceans get like that too. In some parts of the world, crazy exciting when I see flat. I just love that calm look. And you can see farther sometimes, but sometimes it can be flat and you can't. So they both can be true.
Deflection.
There's not a
Deflection.
deflection.
I'll just repeat it.
Sometimes it's flat, but we
Deflection.
can't.
Deflection.
Sometimes
I'll
it's flat.
just
We
repeat.
cannot see farther. I'll give you a picture of one of
Deflection.
those
Red
situations.
red
It's
herring,
not
bro.
deflection, not a red herring. There's
Dude,
sometimes
calm
complete
down. Calm
contrast.
down.
Complete contrast. What you said, Witsit. There are some days where it's totally flat, and
You're just
ships
gonna
and
keep
buildings
repeating it.
are. You're gonna talk through me. I'm just gonna
No,
finish my
you
sentence
stopped talking, and as soon as I went to respond, you didn't like I was pointing out it was a deflection. So you want to talk some more and say it again.
because it's
It's
not
a
a
red
deflection.
herring. Well, I'm about to explain why. As a red herring, for you to say, sure, sometimes it happens, but sometimes it doesn't address what I'm saying, though. We're talking about the times that we
Directly.
do. We're talking about the times that we do see further. Okay, so in the
Farther.
situation that it's very calm, clear, flat, and we see further, in your
Farther.
paradigm, you're going to have to now claim that there is more refractive effects causing it to appear that way.
Correct. It's not a
Okay,
red herring
thank you.
because, in direct contrast of that statement, there are plenty of days where it seems just as clear and calm, where you can't see farther. You see less far. So, which is actually more representative of the reality of the geometry of the Earth? Well, you have to test for that. That's all I have
Well,
to
what we
say.
would do
But
is we would look at the days that we don't see further, and we're going to start to see effects of inferior miraging. We're going to actually see the obvious refractive effects on the days that we aren't seeing further. That's a problem for your claim, though, because you're claiming that's when there's the least amount of refraction
no,
and the most refract. Yes,
that's
and this is
must,
what I can. This
must
is
be
the
not
same
true.
experience that I had. This guy's observations below anything I did out of the water. I had the same
What?
basic observation and experience though. When I would pull the camera out anytime we were near water, sometimes it'd be clear, sometimes it wouldn't, et cetera, et cetera. It's very simple. When it's clear outside and everything is calmer, you can see much further.
It's not
And for me to
true.
believe the Earth's a globe, no, generally speaking, it is true.
It's
And
not
for me
true.
to believe the Earth's a globe, I have to look at these observations when I'm seeing way further, and it's way calmer, way flatter, way clearer, and then believe that's when there's the most refraction.
Yeah, I have an example too that
Well,
I posted where I can see it's much clearer and you can see a whole nother building that earlier in the day and that was foggy was completely gone.
look,
Yeah,
Do you
I
want
check
me to
just
this
tag
out.
you
posted.
on that? I wish somebody would
Taylor,
put it on the big screen.
I just posted a
Taylor,
calm day
you have a
down
look
in
at this
Santa
one, Taylor?
Barbara during the oil
You're like,
rigs. It was a very calm day, and
Plain rig
that
was
was
trying to say something.
very clear.
Yeah,
Okay. Anyway,
I
very
think you already
clear.
told us
Very,
about that one.
this is no. This is
did
one
you
I have
see
not
this one,
shown. This
Taylor?
one I haven't shown
Did you
this
see
one.
this, Taylor? So when you were saying how a building just appeared all of a sudden, look at the difference between here. So we got about 70 feet missing, and then we blink test it, and then boom, there it all is.
That's
Exact same
cool.
position.
Did you see the thing I tagged you in?
Can you
No,
describe this?
can you maybe just send it to me?
Okay.
So
Anyway, go ahead.
same camera height, same location, same distance,
Yep, same focal length.
same day.
No, different day.
Oh,
Sorry.
okay. The date's on the left. I see the date. Okay, okay.
Yeah, yeah. So one was the 11th of October, which would be this one, I would say, and then this one here would be the 24th of September.
Right now,
And
can't
it
we
actually,
all just intuitively tell that that one right there is just the clearest, more accurate depiction of what is there? Right? Like, am I tripping?
Dead calm in the ocean. I just posted it. Dead calm. And you can see that both are dead calm. Unbelievable. You get a few of these days in Santa Barbara. One was on a very hot day. You see, it's kind of smoggy because it was fires going on that day where it was loomed up tremendously. And the other day, it was calm with blue skies. Both are very calm. Which one is more representative of the geometry of the Earth?
I don't
the
know.
one on the left,
We just
one on the
had
left's an inferior mirage.
No, they're
The one on
both.
the left has, yeah,
Which
the one on
one?
the left
They
has
look the
inferior.
The one
same
on the right.
elevation, just the water
The
looks
one on the right
higher.
has more miraging, actually.
No, the one on
Well,
the
that
left
one's
has an
I post that one a lot because it's useful for various things. I don't know that I agree that atmospheric magnification is like the entire kind of answer of what it is, which is what somebody put that on there, but
Well,
nonetheless, like that actually shows what he's been showing all night. How when you have the horizon point that in this case is like closer, the object that looks like it's because of the convergence and divergence that is dropping due to that effect because it's beyond the horizon, as it
okay.
were.
Well, actually, mathematically, it should be higher in the distance than it actually is, so it has some looming, but it is lower. It is calm, and we are not seeing farther. So, contrary to what Whitsitt said, sometimes, and a lot of times, depending on the conditions atmospherically, we will not see farther when it's very
yeah.
calm.
This perfectly proves what we said, which is where you're gonna have inferior miraging.
See this right here,
At
Zanny?
the
See
end of team.
this little line straight across here?
Yeah, I've actually
All
been out
that
there on
stuff
a boat, and
underneath
that's
there, all that stuff underneath there is an inferior mirage in this observation. And what I showed about this observation earlier, right? Because this is the one that I went over because you posted this to me a long time ago, and I have been over it a few times, but I need to, reiterate this, that when we see something like this is a representation of what we're just watching or what we're looking at. Let me do this. Like this, right? So this is the same thing. The buoy's on the horizon. That should start skipping now. So we have the buoy on the horizon, and when the horizon is close to us, So the buoy is representing the oil rig at the front, and the tower at the back is representing the oil rig at the back. And perspectively, what we are seeing is only to the horizon. Our perspective can only go to the horizon to the buoy on that day, and now it's further away. Things don't just magically raise up and down. This is all an optical effect. On the day when we all of a sudden see further, like I showed to you before, which was this picture here, right? Where was that? Was that just here? Okay. So here again, let me just move this back to here. What we are seeing is perspective. And I explained to you before how that little yellow buoy, how it seems to be high up on the horizon there. And then when we drop and we see further, that little yellow buoy now appears to drop. It's not actually dropping. That's just how perspective works. People haven't understood how perspective and the horizon works together to give us the world we see.
Well, I think the picture addresses your points as well, and it shows your points in there. There's several things happening in this picture. Can you see it at 29 after the hour?
Okay, hold on. Just have to.
So we have some. This is a good picture because it has inferior miraging.
Is that this one? The one that you showed earlier?
No, I don't think I've shown this one. And maybe it was part of a duo, but this is just by itself now. Calm day. I got it.
The one that with the inferior miraging?
Yeah, there's some inferior miraging. You can see the C shape, backward C shape, or the actually C shape on the right platform, and then of course the entire platform for habitat is gone. Half of it's gone, and there's a bird actually flying along the water as well. This if you're saying that there is an inferior mirage that's hiding everything below the cranes and the platform underneath Hill House, I would agree that is not. It's a reflection, an internal reflection and mirage, as they call it. But the water itself is what we're seeing, and it could be even hiding some of the water, but only a very small angle because everything above that inferior mirage is not fake or generated or illusion. It actually is reality. So the water beneath it and there's a band in between. This you can call it the ether band, as Travis calls it. But the point here is not so much what you see. It's not how much is hidden, although it kind of is. It's really about its angular position in your field of view. Does that match the flat Earth or a round Earth? And you're saying it has to be dropping because you've already given this new law of perspective, this divergence that happens after the horizon.
Yes. And that happens wherever horizon is created. So it's the horizon itself that does that. That's why I say it's the dividing line of perspective. I don't go, well, it only happens when there's refraction here or refraction there. It doesn't matter. No, it's the horizon itself. The horizon is the dividing line of perspective. So even within your image of what you've just shown here, right? And I'll blow it up, and I don't know if people are looking at my screen or whatever. But so we have this inferior mirage. We know that this causes upward refraction of light, 100%. We know that. And that's why this image now seems so low. But we still see a visual ramp coming up to the point which is the highest visual point, which is where the horizon is. And the inferior mirage is now creating the horizon here at a much closer point to us. And now everything starts to drop below there. It's exactly what I've been saying. All you're doing is showing what I've.
Yeah, I know you're saying that, but like I said, all your videos are great, and what you are describing happens. It's just the reason for which it happens, I completely reject, and I reject it for the reasons I stated. I don't need to go into them anymore. I think if you think about it and start talking about perspective and where things are mathematically in your field of view, you'll find that there's a key flaw in your analysis. But that's just my opinion.
I have a question. How did y'all come up with the geometric horizon?
Is that a hiccup?
Xanic? Yeah, that was a hiccup.
I had one right then too.
How did y'all come up with the geometric horizon?
It's backwards engineered, knowing the known measurements of the Earth. So that's not
Xanic?
a way.
The tautology.
Xanic?
No, we we look at where things are in distance for known heights and see where they are based on distances away from them, just by taking the distance above the surface divided by the distance away from it, taking the inverse tangent and getting an angle. When that angle doesn't comport with geometry, that reality, then we say it's due to something else. We call it Earth curve. Yeah.
How did y'all figure out the distance to the geometric horizon?
By doing these kind of measurements. One of the first ones was the one down in Cyrene and in the Middle East, but that was done a long time ago by Eratosthenes. But we've done it. There's many other ways that we've actually come up with that
By doing observations?
by doing
Or
observations.
To the apparent
by
horizon,
mathematically
correct.
deriving? Yeah, I think they just mathematically derived it.
Well, math is a useful tool. We use it sometimes to actually determine things
Oh,
like
but
this.
which one is it though?
It's both.
Is it both?
Yep, they reverse
Xanax.
engineered, and they do the apparent horizon.
What do
Wait,
you
how
think,
did they
Xanax?
actually get the
And
The way
geometric horizon?
the funny
and
thing you could do. Sorry.
sorry, you go ahead. They're talking to you. Go ahead.
Well, no, it's okay. I mean, I've been dominating we've been part of the main conversation. Everyone should jump in if they want to. But I want to make a quick comment. The way you can test for this, and I've said it a billion times, differential measurements. Anything you see, start, if you know the distance to it, and you can change the height at which you observe it, take 10 or 15 measurements at different heights above the surface without getting closer to it. And then see if that object comports with a curved surface or a flat surface. That's an easy way to do it, but no one really has done that yet. It's you've done one of the few things I haven't seen people do. That what I've talked about for years now, no one's done. So that's
What?
one way you can actually check. Take differential measurements. Take a measurement to oil rigs, go up to a floor, take another measurement to the angle to the object, go up a floor, repeat that 10 or 15 times up to a 15-story building. You could do it like in Santa Monica. There's lots of 15-story buildings down there. And then see if the object actually where it is in your field of view comports with a flat or a round Earth. You'll see that the refraction value could be predicted at any height based on those measurements. But no one's going to do that because it takes a lot of work to do it.
No, man, you've never done that.
I told you I haven't done it. I've done things that resemble it in single measurements, like I've taken up at Mount Baldy and down to the Huntington Pier, measured the angle. It's half a degree off where it should be.
You know, the side that needs to do that is the one that's claiming to know that that's what's going on. And whenever people are claiming to know that when we make observations that don't comport with the globe whatsoever, and they claim that it's atmospheric refraction, they should be able
Whatsoever.
to give a repeatable, testable claim for that. They
I
should be able to go
fly.
out and provide specific predictions for
Yes.
that. This
Those
doesn't
mountains.
occur though.
The mountains are a great example of it also. Since you fly and you're going toward Yosemite, you can see Half Dome in the distance. You can see it's a 10,000 feet or a 9,000 foot peak. If you are at 9,000 feet and it looks like it's above you, you think you're, or below you, you think you're going to be able to clear it. And as you approach it, it suddenly magically rises, even though you're flying theoretically at the same level it is, same elevation it is. It's burned many pilots in the past that fly and think they've got this mountain range cleared, and as you get closer, due to the Earth curve, they don't. So that's one example that people that in reality can experience to know that they've mistaken the shape of the Earth.
So how did they come up with the geometric horizon again?
By knowing the actual diameter or the circumference of the Earth.
So not from observations.
From observation, yes.
So from observation to the horizon, or from the mathematical construct?
No, they've made observations to determine the diameter and the circumference of the Earth, therefore the diameter, but the circumference of the Earth. Therefore, you know what the curvature rate would be because it's just simple mathematical laws for dimensions of a circle. And then by knowing those angles, you can then predict where object will be in the distance in your field of view. Pretty simple. That was just these are things that were done, thousands of years ago.
Okay, but which
So the
horizon?
geometric horizon wasn't actually done by like looking to see where it was. It was just mathematically derived.
No, it was looking to see,
Got
and
it.
yeah, just
No,
like
they
you.
looked to see the circumference,
They
and
looked
then
and they saw the rate of change.
mathematically figured out how far
Yeah, they
away
looked.
that thing
Well,
would be.
the shadows. In Siren, they had shadow where a stick near the equator did not have a shadow at noon. And then they walked 500 miles, stepped it off, and figured out that the Earth had this angular representation to distance.
Can we get that
mass-
original paperwork, that original study?
It
That
doesn't
is,
matter because it
that
can be
is one of the
replicated.
almost
You can
absolute
replicate it.
original studies.
A fifth grade
No.
class can replicate it. It's just something that
The
anybody can
geometric
do.
horizon was mathematically derived. That's all.
By the
Well, it's derived
observation,
from the
we see
circumference
the
of the Earth.
observation.
And Al Biruni did it a different
Not for
way, where
the
he
not for
measured
the not for the
Al
geometric
Biruni.
horizon.
Al
That's
Yes,
Biruni
the
that's
measured the
geometric horizon.
horizon. Al Biruni measured the horizon dip from the top of a
what?
mountain and came to almost the same number. He
Tell
was
me again, bro.
within 1/3% of what was
Alberoni,
correct.
Alberoni
Rooney.
used the R value.
He measured the dip of the horizon, was able to calculate the radius. Yes.
Right.
Oh, he came up with the R value.
He came up with he validated the R value is what he did.
So he didn't have to worry about atmospheric refraction.
It's such a small percentage of the actual measurement. When you're measuring up a hill or down a hill, your angle of incidence or that acute angle, because you're seeing most of refraction when you're on the surface of something looking across it. The more acute that angle becomes, the more refraction there is. We all will agree that looking straight down through the atmosphere, there will be no refraction. Anything in between will just make it greater
What?
as you get to the. If you look straight
Tell the
down,
black swan that.
pardon?
Tell the people that observe the black swan that.
No, Xant just said.
I'll tell
Zanuck
them.
just said, if you're looking straight down, you don't have to worry about refraction.
I think it means like looking.
That's not true.
Looking like a
Wait,
drone looking down at the ground, straight
Alberoni
down.
looked straight down.
No, I'm saying if you wanted to really
Oh,
test.
so just a totally irrelevant comment.
So now it's just objection from incredulity. Okay, I got it.
No, it's called
Nobody's
a
actually doing that.
deflection. So I asked about Alberoni and atmospheric refraction, and your response was, no one would deny that when you're looking straight down, there's no refraction.
Well, you're not.
How does it have anything to do with
I'll tell you if
incredulity?
you listen.
No, it's
So
that your comment
no.
wasn't relevant
It is
to what was
relevant.
being discussed.
I'll tell you. Just let me finish and I'll tell you. So we all know that looking straight down, there's no refraction. Looking along the surface is the greatest refraction. So it's logical that as we go higher and follow a optimal curve path to be above the object would be the best scenario. It would be difficult to do without a helicopter or something. But you can do things just like go up in elevation. As you go up in elevation, the refractive value will be less. Less refraction effect will be less because that angle is less acute. Angle of incidence is the most critical element of refraction. So by doing that, you'll have. So if you look up a mountain and down a mountain, you can do things like reciprocal zenith angles and figure out what the actual excess is. And they find that every time they do it. You can do it yourself. Go to Squaw Valley or go to whatever ski mountain near you. Look up a mountain. Have someone up there. Look down. Measure the angle to each other and see if the angles add up to 180. They won't.
No, listen, bro. If you both have sinking refraction, atmospheric conditions to cause that, that could be one cause of it not matching up to 180.
But when you're
Thing is,
high
both
altitude, less.
globe
This is
and
so irrelevant
plane.
that it's off topic.
So
Sorry,
plain
guys, 2
reality
seconds.
claims that perspective is just looking like a globe because bottom-up obstruction looks like a hump in the middle. So he just claims that is just like how perspective works, which means light has to curve upwards, where's no physical explanation for an everyday situation. The globe says light sometimes bends downwards, aka we see too far, where there's a clear physical explanation for it. And
No,
he
you guys
just
claim it
claims,
bends
no,
downwards
this is,
always.
he
Yeah,
just,
they do.
no,
That's
no.
wrong.
He
That's
just
correct.
You claim it
claims,
bends down always.
okay, you have to
Yeah, they
interrupt
say it
because
always does.
you're scared, right? Okay, come on,
No,
go
you're
ahead.
just
No,
lying.
that's what they say. You disagree?
Yeah, of course, you cannot stand it with it once that someone explains something. Only hear yourself. Go ahead.
Well, no, you're just
I'm sorry
misrepresenting
that I
your
was
own
talking.
side. It's all good. I made one simple interjection. It took 3 seconds.
You're
It's just that you
always
don't want to
doing
be
simple
intellectually honest
interjections,
in
and
it.
then
You are.
Taylor is doing a simple interjection, and then you are whining around that
Well,
you're
I can't
interrupting.
control what other people do.
Hey, Snooze, sorry, can I
That
just
was incorrect.
jump in 2 seconds to say I'm going to drop down to listener because I've been here since 9. Well, for me 9:30 in the morning. It's nearly 5:30 in the afternoon now. I haven't eaten the entire time. Barely drank anything. So
Go take care of yourself, brother.
I'm just going to drop down to listener and go get something to eat. So thanks for having me anyway, guys. I hope people start to really look at what I've introduced, and I hope people start to use the
I
arguments.
appreciate all the effort. And
I,
thanks
I,
for
I have a question before you leave. Do you
I
have
can-
any you've been very respectful this whole time, and I applaud that. But do you have any sources or links or something we can look at?
to my work?
Yeah.
Yeah, well, I've literally just started posting on YouTube more now, so I'm going to start doing a lot of posts on YouTube. I'll drop my YouTube link in the chat, and then I also have another channel, and that other channel is going to be just purely observations, edited to music, nothing to do with anything, just pure observation and music, just so people can see the observations that have been done as well.
Well, that
Nothing
was
to-
great today. Yeah, thank you so much for everything you brought, and it stimulated a lot of thought and great discussions. And then yeah, I'll cut out the presentation, into its own video, and then this was a long after show, so I can. Well, I can include some of the after show too. I guess I could include it all, but at that point, it's going to be 6 or more hours because it's been quite some time. But yeah, I can cut it out to make it its own video. That way, other people can watch the presentation from the beginning. But yeah, I just wanted to say thank you, and that was awesome. So yeah, cheers.
Yeah, no worries, man. Thanks for having me. Sorry we were here for so long to everyone. Some people were probably bored as shit, but
They wouldn't be here if they weren't interested. I think everybody's interested in this kind of stuff. It's fascinating.
Yeah, it was great.
I do have more that I can present. I've actually designed and basically worked out how this can work over a flat plane and how the observation would work, why things disappear at greater distances. I actually do have stuff where I've done that as well, but we were too busy talking about everything else. But I can present that another time or whatever. And then I can also, I'd like to do maybe some presentations on how people get mixed up between inferior mirages and globes, because we have a lot of misconceptions on inferior mirages.
Since you've already kind of gone down the path and you've kind of reached to the top of the mountain at this point, I think the only thing you could do is to kind of back up with evidence. Like you have a hypothesis now, which is great. This is a very clear hypothesis. See if you can figure out ways to experiment and test it by different types of observations. I would say the differential measurement would be one way. I don't know how you could set it up. There's many ways. We could talk about it some other time, but just have in the back of your mind, maybe figure out ways you can test for it.
Yeah, well, like I said, I'm going to go do the same observation with the boat when there is no miraging. So that's one thing I'm going to do. But what do you mean by differential measurement?
Changing, like for example, I gave the simple example of seeing something in a distance and then changing your elevation, taking a measurement of an angle to the object in the distance, maybe say very close to the horizon, and go up this building. Maybe take it every floor, maybe a 15-floor building. Every 10 feet, you're doing a different measurement, and then you should be able to get an angle based on the known height above the surface, above the water, and then see if the position of this object in the distance is actually representative by the angle of a flat or a round surface. That's just an example. I mean, there's many ways you can test your ideas by what your hypothesis is and your guesses are of what's going on in the hypothesis has something to do with this convergent perspective, and at the horizon there's a divergent perspective, following exactly what we all see in reality of boats going over something's horizon. We all agree that happens. The question is what's really causing it, and you can test for that. I don't know. That's one test you could do, but you might think of others. I would think that'd be maybe in the back of your mind to come up with some different tests that could provide evidence for your and support your hypothesis.
I'll go outside now and I'll take a photo of, because I've built 5 meters of that little perspective grid thing. I'll go outside, I'll take a photo of it, and then I'll post that as well so people can see get an idea of what that actually is as well. So that's just another little test that I'll be doing. So if I can mimic what we see over a 30 feet distance over water, then that's just more evidence to say that we're doing the same thing. But yeah, I'm just going to drop down to Lissa and go grab something to eat, man. Thanks a lot, guys. Thanks
Take
for having
care.
me.
Much love, bro. Okay, so what this guy said that he just conveniently made up some perspective that just says it looks like it's a globe and requires light to bend up with no known physical way that that can happen, and that the globe just claims that sometimes light bends down. The globe model claims
Is
that
all the
there's light.
explanation.
The globe model claims that there's light bending down and refraction always, every single day, always.
Light can bend upward sometimes in very, very unique situations. It does happen though.
Yes, but in, let's say, 99%, and that's not an accurate amount, it does bend down. That's correct. So you basically always see a little too far with it. And we know that because we can do the actual geometrical measure. And then we know how much it.
Oh, well, you said sometimes, but the globe claims pretty much always. And that's because the observations in the real world don't match the globe. And then they cherry pick all kinds of observations and throw a lot of them out because if you actually accounted for them, it would make your radius value way too big. And what the Glovers don't seem to get about what he's presenting is that the Glovers say they make a claim of exclusivity. They claim that the fact that objects disappear in the distance, bottom up, and that they disappear over the horizon or behind the horizon can only happen if the Earth is a globe and the surface is curving. It's a claim, it's a positive claim of exclusivity. And he is showing that that isn't true, that due to perspective, the observations would be expected on a flat Earth. And he's showing direct empirical observational evidence of the phenomena that he's invoking and showing inferior miraging, etc. So that you can
No,
no
he's not
longer
showing that.
claim
He's not showing
you
that. He's
can
just
no
claiming that.
longer claim you can no longer he's not just claiming it. You can no longer claim exclusivity. And the funniest part of the whole situation is this is how simple it is. When we go out onto the earth, look at the earth,
Could you
when it's
maybe
really
stop with
when it's
one
really
claim so
clear,
that we can
when it's really
respond
clear,
instead of doing
when it's
multiple?
really clear, when it's really clear outside, we can see further. And you guys want us to believe that's when there's the most refraction.
So he did not show that or demonstrate it or anything. He just claimed that perspective makes it look curved. He just claimed that perspective is working, that bottom-up obstruction would appear. But there
Suze,
is
were you
no
here? Did you
single.
hold on? Did you just get here? Were you here for the whole presentation or anything? And are you talking about plain reality or who are you referring to?
I heard multiple hours before I went to sleep, and now I'm up again.
Oh, so you didn't
I
even
was
know. Can you
I
still
was
man,
not there the
you
whole
said he didn't
discussion.
show anything though. That's not true. You said he didn't show
No,
anything, he just
I
claimed it.
said he claims that it was due to refraction, but there is no physical explanation why perspective should work so that you have a looked bottom up obstruction. It's
Okay.
just this
So
cone of
you don't
vision.
even know.
It's the cone of vision and so on, which has no physical explanation behind it.
So you don't even know what his position is. So you're just jumping in to claim it's wrong. So
Now I know.
no. And he addressed it specifically, and he said, "What we do for all perspective is we use a flat Earth. We use a flat surface that we can then replicate these observations over known flat surfaces, even local flat surfaces like lakes, right? And to get the same like very small areas that are known to be flat, and get the same effects." So
But
the onus is
lakes are
actually
not
on
flat.
you.
That's exactly the point. He just claims them to be flat without being flat. Even lakes are not flat. Even over
you don't
3 miles, you have curvature. Even
we're
over
not doing
1
anything
mile,
like
you have
3
curvature.
miles. It's nowhere close to a mile. You don't we're talking about little bitty
Even
boats on
over a
little bitty
mile,
bodies of
you have it.
No, not over a mile.
Yes, definitely. You will have curvature over 50 meter. It's just very small.
Okay, so the amount of alleged curvature in your globe model is not enough to account for the effects observed on these very small scale observations.
He just showed mirages. That has nothing to do with whole buildings disappearing behind the horizon.
So you just deflected once proven wrong. So you don't know what you're talking about when he's discussing the
No.
small local observations over flat surfaces, such as using little miniature boats on little lakes that are known to be flat. You cannot claim that they're curving and that's the explanation because they're in your paradigm over that small area.
No.
There's not even anywhere close to enough curvature to explain the observations. If you're not familiar with those demonstrations, I encourage you to go look at them. Maybe
I have seen them. And
then why are you talking about
these
miles then?
surface effects are based on different effects. You have different situations on surfaces. However, the thing is, the explanation of this is how perspective works, again, there is no physical explanation why light should bend up, which would be a requirement on a flat surface to have bottom-up extraction. You would have to have always light bending up, except of the very rare situations like the black swan, where you see it not bottom up obstructed. And there is
Not
no explanation at all
not
why that
true.
would happen.
Not true. Like just because you say something, it doesn't make it true. So no, that's not the only way. He
Okay,
just now
give me
showed
the
that.
physical explanation that he gave why light should bend up.
Oh, you just repeated again the whole light bend up thing? You just repeated it. No, that's not
Yeah,
true. It doesn't become true just
straight.
because you
If
say
light
it, no matter how many times
if
you
light
interrupt me to
travels
say it
straight,
again.
you have to
Notice how
see
you
it.
complained about being interrupted and you are incessantly doing it 2 words into my response back to back to back times. So
Because
just
you're
because
not
you said,
responding.
how would you know what I'm doing if you interrupted 2 words in? Oh, you wouldn't, would you? The answer is that you wouldn't. So just because you say it can only happen if light bends up, that doesn't make it true, right? He was pointing out perspective, converging the horizon being the dividing line of perspective. It then diverges on the other side. So once it gets to that vanishing point of the horizon and converges into that point, it's then going to diverge out to do the exact same thing, just on the other side of the dividing line of perspective, thus causing it to go down optically to your perspective. That's not invoking anything to do with light bending.
Just that these paths are not correct because the line from the bottom, like the floor, is not continuing to the top and being upside down on the other side of the vanishing point. It's somehow making a curve at the vanishing point and then goes down. So everything seems to be in his explanation to curve around the vanishing point and then go in the opposite direction. However, that doesn't work with the sky. The sky also goes down and the floor goes down behind the horizon. So it's absolute bullshit, this explanation that at the vanishing point, it just turns in a different direction. Everything, literally everything, sky, floor, everything goes down behind the horizon.
Everything you
There's
said made
no
no sense
upgoing, no
whatsoever.
opposite thing. And still, if the light travels straight, there must be bending of light to see bottom-up abstraction. You cannot
Yes,
explain it differently.
Okay, so notice how you didn't address the direct refutation of your point,
I
right? Which
did.
was that you were struck. No, you didn't. You strawmanned it, claiming that he's just claiming light's bending up and needs to show it. That was a straw man. He didn't claim that. Once you were corrected, you just skipped over it. That's very convenient. Secondly, the fact that stuff in the sky also converges doesn't rebut his position at all. It converges to the horizon. The point is that if there's something that is below the horizon, moving off into the distance, appearing to rise, and then reaching that horizon, which is the dividing line of perspective, it's then going to get into that vanishing point, and then it starts to diverge, causing it to lose information from the bottom up due to
Okay.
perspective,
So if that's
and
the
it
case
and
with
and there's no curvature involved anywhere. It's literally all flat, and you keep
But that's
saying
exactly the
curvature
so if that's the
when
case with
even
what's
I'm
happening
almost
when the
done. I'm
sun
almost
sets?
done. I'm almost done. When even in your own paradigm, you have to say, yeah, sure, it looks super flat. So stop saying the word curvature, please.
no, we just say it's big.
So
So
as
go
soon as the
on.
And
sun
flat.
goes over
And
the
flat.
horizon, within minutes the sky starts getting darker, and especially in the wintertime when the sun travels a more direct straight line path over the horizon, it could be like pitch black dark in like 30 minutes. What's happening there? If this is all just this, if it's all just this atmospheric refraction or whatever, what is happening there where the sun, the moment it goes under the horizon, the sky starts getting darker and darker within minutes?
Jay, can I
So
ask
this
you,
comes.
is that a non sequitur? Can I ask you that? I'm
It's not a
not.
non sequitur because what we're claiming is that we're claiming the horizon is an obstruction in the same way that a hill is an obstruction to a person that's like looks like they're being cut off from the bottom up, right? Someone that's walking down a hill, right?
We're
And
talking.
and if we imagine them having a flashlight or a lantern or whatever, we can imagine the same effect, right? But if we're just talking here about some kind of atmospheric effects and the horizon is just, you know,
Not what we're talking about. You don't even know. You like this is like it was just explained that isn't what we were talking about, and then you said it again anyway, and then deflected to the sunset. It's
because
just
we
so weird.
because the
Is it
sun is
because you were
setting by this.
I know, but did you do that because of just? I mean, if you're willing to admit this, did you do that because you were uncomfortable with like the discussion and what was being said? So you had to. Did you purposefully just feel like, well, let me just jump into something else real quick?
Well, no, because they're making claims about the horizon and characteristics about the horizon. And if we're going to make claims about the horizon, we have to explain this behavior that we see when the sun goes behind this horizon, right?
I mean, you did. This is, I think, the fifth time you did it. You did it 3 times in the after show specifically, and then Travis, I'm your Copernicus, had to like literally like multiple times, like he practically yelled at you, like
I
telling
mean,
you
you
to like
guys hate talking
erase some
about it
stuff.
because it's an
No,
obvious
because we're
debunk.
not talking about celestial bodies, though. It's a different topic. We could shift to that topic at some point. But Witsit just laid out a whole thing. It was a sort of back and forth with Snooze. There was things laid out, and then you just jump to these celestial bodies. I hear you. It's a different topic. It could be interesting to
It's
discuss,
not
but
a different topic, though, because it's going behind the same horizon that we've been talking about all night. This
It is a
behavior
different
happens
topic, and
when it becomes obstructed by this horizon. And this whole
it,
argument all night is about what is obstructing these objects behind the horizon. And the claim is no, they're not being obstructed. Okay, they're not being obstructed, but why is it that when the sun goes down the same horizon, it very much behaves like an obstruction?
okay. So it is objectively a deflection, right? And then
It's
you
not a
used a straw.
deflection, it's a debunk.
It's literally not. And you used a straw man just like the guy before you, right? To try to claim it wasn't a deflection. Atmospheric effects or whatever. It's like he said, light bending up because it has to be. No, incorrect. So we know us not taking the bait of your deflection to the sunset doesn't mean that it can't be addressed, right? You're like, oh, so when the sun goes off into the distance and eventually can't be seen anymore, it starts to get dark. Sometimes as soon as 30 minutes after. Okay. Yeah, the sun got further away. Okay. So back to the point. The actual point is you guys are claiming exclusivity of an object appearing to disappear bottom up behind the horizon. He's saying, no, not true. Perspective causes the object to converge into the horizon. That's the vanishing point. It acts as the dividing line of perspective. Once you get to that line, It then begins to diverge out like a mirror. It does the opposite, does the exact same thing, just the opposite way, because you've now reached that vanishing line. So it serves as a dividing line of perspective. It then begins to diverge out from that dividing line the opposite way. And now it's going to cause information to be lost bottom up. That's strictly due to perspective. And he's pointing out everything that we do with perspective is done over an assumed flat surface. All of the math that you're invoking, flat surface, that the same effect being shown over very small, locally, provably flat surfaces. This claim of exclusivity is just that. It's just a claim.
Could I ask a question? This vanishing point, or tied into the horizon, is that where you can't discern details on the surface, let's say, of the sea? Is that what's meant by the horizon due to a vanishing point?
You begin to not be able to discern information, yes. The
But
really big point
yeah,
that
but
I'm very
how does how does that create a horizon?
So again, just the response is another avoidance of the actual argument. That's 3 consecutive people doing it 5
It was
consecutive times. Yeah, yeah, that's what's going on.
why didn't you instead try to explain it
I addressed it specifically.
instead of just
I addressed your
no, you haven't.
deflection specifically. I
So
did.
how does that work with it? How does it
How
work on a
does it
flat
work?
surface? On a flat surface, if you have an object up on a flat surface and you move it away such a distance that you can actually discern the details on the flat surface, you would still see the object on top. So where is that vanishing point? It can't
The
be. It can't.
horizon.
No, it can't be a horizon due to the fact that you can't discern the surface details anymore.
What? That's where the sky and ground appear to meet, and information begins to be lost and not resolvable. It serves as a dividing line between perspective, is the argument that was presented that none of you can rebut. But even the funniest part for sure is like, it's like the same point I've been making to you guys for like 5 years. You guys just all avoid it. I mean, there's a couple people that like just straight up stick their chest out and say, yeah, but it sounds so absurd. Most of you don't. Just like he showed, when it's clearer outside and it's better conditions, it's clearer. So more visibility. It looks flatter. We see way further. So when it's clearer and there's way more visibility, we see way further. It looks way more flat. And in your paradigm, for your model to be true, those scenarios are when there's actually the most refraction, and that's an illusion. It's more clear, there's better visibility, it looks way more flat, we see farther. That's an illusion. That's when there's the most refraction. That is ridiculous, dude.
So, from my understanding, then, is that the further away, when you get to such a distance that you start losing information from the flat surface, this somehow affects a vertical or an object sticking up on this flat surface. How does that happen? Why does the less information of the flat surface affect an object on top of this surface?
It's beyond the dividing line of perspective that we just discussed on repeat 5 or 6 times.
No, that doesn't answer the question. That's just a claim.
It does. No, it's not just a claim. He showed videos of it happening. Were you here?
Yeah, for quite a while, been listening in and watching.
Were you watching the stuff he was presenting? Because like when Zanuck was going back and forth,
most of it.
he showed Zanuck a video. He showed Zanuck a video
Still
and then
does not
described the video.
explain how you lose. It's still not explain.
All right,
The
dude. Look,
combination,
I'm not
the
interested in the
combination,
really gay,
the
like, just you guys
combination
have
of
no impulse
the
control conversation.
losing information from a flat surface combined with perspective and an object on top of this flat surface by
If you just want
distance.
to hear yourself talk, why are you pretending to ask me questions?
I am asking you questions which you are not answering.
No, you're interrupting me.
Oh, then I'm sorry, I couldn't hear you.
You heard me, actually. So, just like when he was going back and forth with Zanuck, he showed him a video. He then described what happened in the video, and Zanuck said, that can't be true because we know how perspective works with geometry.
No,
This
it's
is the
not.
same thing
Wait,
that
wait. Now
you're doing.
you're misrepresenting what I
You're,
said. What's it? Can I jump in real
no,
quick?
that's like verbatim what you said.
No, no. But you took again. This is your classic calling card out of context. That does what it is. What we see happen. What causes it is what I was in disagreement with. You know, I meant that. You know, that's what I was getting at. It does. It just because we see something go over the curve and go down the other side and lose a position in our field of view vertically doesn't mean it's caused by perspective going into a divergent mode. That's what I disagreed with. Clearly,
That wasn't
you
the
should know
point.
that.
That wasn't the point though.
It was
He
the
showed you the
point.
video of the ship, and then you were like, he described what happened. You're like, that can't happen though because we know what happens. And it's
Yes,
just like
not
right
due to
there.
that cause.
Even when you clarified right there, you just called it a curve. You just begged the question, and
Yes, in this case, I
this is
did.
the whole point. When you
Because
guys
you
claim
can't
there's
just
no
make up
other way,
something and say it's
you
true.
dude, like all of you can't help it.
It's reaffirming
Bro,
the
you
consequent.
can't help it.
It
None of you
happens.
can
Why does it
control
happen?
your
Because
your
it happens because
you all have an inability to
oh,
just
you
not
you
interrupt.
ramble on, you drone on for minutes at a time. You just don't let anyone come in there. Look, I'm
That's
telling
not
you
even
right now what I
true,
meant.
bro. I was talking for
You
less
were
than
there.
3 seconds when
You
you
watched him.
interrupted.
Let me respond. Let me respond. Hold on. Just be quiet for a second.
Oh my God,
He
bro.
did describe what describe what caused this phenomena that we all agree on of something going up to the horizon and going down on the other side. He said it was due to this converge or this divergence at this horizon point. I said that can't happen based on perspective and natural known laws of mathematics. These do not that does not is not valid. And you can't if you want to prove it is
Natural
valid,
known laws of
hold on. Yeah,
mathematics.
start showing some balls and start providing some evidence to support your hypothesis, which he did not do. I do
He
appreciate
did
everything he
do
did, but he
that.
didn't. You know, he can't just ascribe what he thinks happening and say that's
Oh,
what's
but you can
happening.
do that. You can do that
No,
though.
I can back it up through
No, you
differential
can't.
measurements, for example, and through laws of perspective,
No,
which
you
are
just admitted you don't actually have
indisputable.
those.
No, laws of perspective are indisputable. You know what the laws of
You
perspective
notice how
are?
now you're
They're
trying to dominate the
trigonometry. What's it?
conversation,
What's
dude.
it?
Like
Did you not pass trigonometry?
you see what you're doing? Like this is all you guys can do. It's
Oh
because you
God.
actually
Yeah,
can't
laws of
debate.
trigonometry are broken because some guy in his backyard with a couple cameras decided he wants to view
Yep.
the
Just
cause
now you're
and
in
effect
full
relationship
blown
completely
spiral
different, and
mode.
you're still doing it. You're still talking over people.
You,
You
no,
can't
no,
let me finish.
because the only way I
Because
can
that's your
speak now.
excuse.
No, because when you start talking, either the other person just never talks and lets you completely run all over them, or they then have to start to do it back to even
Nice
talk.
excuse. What's it? I want you to
It's all
stop for a
recorded.
second.
It's
And
all
yeah, it is
recorded.
recorded.
Yes,
You're
but
right.
why most people don't even engage with you.
Shut up.
It's like, dude, Zenik, it's factually what you just did, dude. So like,
No, you
again,
started misrepresenting what I said, and then you said, "Yeah,
oh my, you're
Don't cry.
I'm not crying." I came back and responded back to it saying, "No, I didn't say that because I didn't." He gave the made up that he had. I call it a made up
see now
cause.
you're
For
rambling
which,
again.
let me finish the sentence. You keep on doing this. I start talking for a sentence and you start interrupting. He said that this is the cause for the phenomenon we both agree to, and we both agreed to it. And he made it up. He provided no evidence to support it. Evidence is not a description. You know that, but you've called people out on that forever since I've known you. He did just that. He gave you a description as evidence. That's not how it works, Whitsit. You just can't make up something that seems to equal. Oh my God! You know you got the
Zanuck,
point.
I didn't
It's
just
all baloney.
provide a
This
description.
doesn't work.
Can you hear me, Zanuck? I didn't just provide a description, Zanuck. I showed an actual video showing you exactly what happens. I didn't just say what happens. I showed you exactly what happens. It wasn't just a description. I got a boat, showed you what happens to a boat from both sides of the horizon that did exactly what I said it was going to do.
Then you
And
weren't
I actually
listening to me.
described this a year ago, and then I told everyone this is basically what's going on a year ago. I didn't have the same evidence, even I knew that was happening, so I've got to gather that evidence now. So for you to say that I didn't show any evidence, that's a little bit
That's not
disingenuous, bro.
evident. Okay.
It's a lot disingenuous,
Paul,
not even a little. It's just
Exactly.
it's snaky
Paul,
at this point. Just
Paul and
snaky.
Gio and company, I totally appreciate your videos. You gave great videos and show, and we all agree that that's what we see in reality. Your description of why that happens, what I disagree with, and I think I was very clear about that.
That
Your
isn't the
evidence is
point,
not the
though.
video. That just because we see what we saw, and I would see the exact same thing if I did that test, I'd show the exact same result as you did, just like you did. The difference between you and me in this particular regard is that you think it's due to something other than what I think it's due to. It's that simple. We have a disagreement,
Okay,
and I
that
think
was
I
what
forced
I
you to
said, though.
produce some evidence. And evidence isn't a video of what you see. Evidence would be do a test, an experiment that shows that what your convergence divergence relationship exists. I don't know how you could do that, but
I
you're
just did
a
it.
smart guy.
So,
You'll figure it out. And I didn't mean. I'm
so let
sorry.
me
I didn't
just.
mean to be disrespectful. Winston brings out the worst in
That's
me in
all
that situation.
Someone else's
Let
fault.
me just put it in another way. Right.
We
So
get
what I
contentious and we
did,
start talking, and I'm sorry I insulted you during my
Oh,
defense of
all
my
four of you
position.
little globers started spiraling because you can't handle me
Not
laying out the
spiraling. I didn't agree with
dismantlement
what
of
you
your
said.
belief system.
can I just throw one extra little point in there? So what
Sure.
I also did with my boat observation was we had a horizon that was at 3 miles away, right? Maybe
Right.
even slightly less than 3 miles. We were at over an 8-mile distance. So at the height that we were at, technically our horizon should have been 5.48 miles away. Now we had an inferior mirage, and I deliberately did that so that we would create a
I know
horizon
that.
that was earlier, right? So
I appreciate that.
so what I've just demonstrated to you wasn't just that it's something that I'm saying happens. There's virtually no curvature over that distance, even on your globe, right? So we had a horizon at 3 miles away. I showed you that a boat would go up perspectively at by the 3 mile mark and then come back down. And as it was going back down, we see it from my side going down, and he saw it from his side coming up and going down. So
Totally agree with you,
that's some
Paul. Paul,
that's
there's
some
no
pretty
disagreement.
solid evidence. It's some
And I
pretty solid
appreciate the
evidence for what I'm saying is going on. And we
and I
both
I'm
appreciate
not
agreed.
understanding. Stop interrupting him.
I
Shut
thought he was
up.
done.
Yeah. And sorry, just one last point. We both agreed on the optics of what happens, which is as a boat moves away from the horizon, we see it appear to drop below the horizon. And as a boat moves towards the horizon, we see it appear to rise up onto the horizon. Now, I've worded it specifically that way because that way then it has nothing to do with whether it's beyond the horizon or in front of the horizon because it describes the same effect from both sides. Okay, I yield the floor.
No, like I said, there's no disagreement on what you described and what you videotaped. My disagreement is that this is due to Earth curve. You're saying it's due to some new variation of the law of perspective, which says that things converge up to the horizon and then diverge when it passes the horizon. I'm vehemently in opposition to. Sorry,
Did you miss
I
the
think
part
what you
where he
should do.
said that even
I
within
and,
your
and having
paradigm, we
having a
don't
little
need to
more.
hear you repeat the same thing
Hold on,
over and over and
Winston,
over,
I'm
dude?
not repeating. I'm adding. Hold on. I'm not.
What I want
Dude,
you to
I
do
let
is
you
go get
speak.
my measurements with
You
different
speak incessantly
variables so
for
you can tell
hours. Let me
me.
just have my sentence. So the
That's not
fact you've
true.
had,
I've been quiet in here for
you're not
hours.
right. Right now, you're still talking. Just put a zip on it. Come on. So he also mentioned he did an idea where there is actually a refractive or a mirage layer, which I thought was great too, because I've done that before and I've seen my observations through a mirage layer. It's as Travis has done to great lengths to show as well. That showed that the horizon was actually a little closer. But the reason that it goes down after the horizon is not due to the divergent in my mind. With our mathematics that we all understand, because you can actually see the tops of these ships and things going down, and that goes against the laws of perspective. So what he's telling us is that the laws of perspective can be thrown out because he's found an exception, and I
Oh my
again
There's
god.
no,
vehemently deny that that's possible. That's it. That's
No,
everything else I agree
I
with.
haven't said that they can be thrown out. What I've done is
That's how laws
introduced
work, though.
that there are particular things about perspective that we did not understand. They were not described before, and I would say that they weren't described before because what we were doing was just assuming that we were on a ball. So therefore, then when we saw this thing go down and beyond the horizon, we're not even thinking about the fact that it's doing the same thing that's happening in front of the horizon. We're just going, why is it disappearing? Oh, must be a curved surface, like most people do.
Would you?
Not
You
that
already agree
like
with?
there's
Okay,
something
sorry. I
else
heard that.
going on.
You
No,
agree
what he's
with me?
saying is that the perspective is happening on the other side of it, and you just skipped right over the whole.
I
According to
didn't.
your own model, there's barely any curvature at all from that height and over that short of a distance. You just skipped right over that part
That
conveniently.
appeal to proportions. Come on, there is a
Appeal
lot
to
there.
proportions. That's the dumbest thing I've ever heard, bro.
It's not dumb. It's actually very smart. Hey, so the point
No, it's
is that
not.
there is a little bit of curvature, very small, but that's also, I mean, what divides small? Small is relative, right? So because the Earth is so large, it compared to us as people being 6 foot tall, the Earth is very large.
But is it big enough to get to make the boat
Can be
disappear?
horizon can be around 3 miles, and it can hide ships and boats over 25, 30 miles for sure. We know this because we measure it. Now he's saying it's due to this divergent area of perspective that happens after the horizon that has not been understood by most, not been proclaimed to be known by any but him, maybe someone else he's worked with. I disagree, and I would love to see him provide evidence for it. Not what he's done is not evidence. Do a test. Do a set of
You do that.
experiments that if this is true, then we should see that and do that and make sure that they're independent from if this curved surface could also show that same
You do
phenomena.
that.
Then what's it? You gotta help. You can't help yourself, can you?
Because you just are in repeat. I
I'm
sat here
not.
quietly
I'm
and
giving
listened
him
to you
some
say the
sound
same
advice.
thing
Just let
for
me finish
2
it because
hours,
I have
dude.
not said the same
Now,
thing.
the one time
I'm
I
giving you
choose to
sound
say
advice.
something about it,
Just
you
stop. I
want to
get it.
jump
You
back
tell
in
me to
and
stop,
say
but
it
I
all
want to finish the
again.
sentence. So if you want to do some experiments, which are not going to be able to be possible if the surface is round, only if it's flat, that would be great. I could think of some, but maybe you can think of some too. And then do those tests. Have that test ready to go, complete the experiment, and show that it is independent of the curve of the Earth, and it stands on its own with its by its own merit, and it can be shown with substantial evidence. That's all I'm saying.
Okay, and how about if I show it in my little test that's going to be 30 feet? How about if I show the same effects in that and we see
Well,
something disappear within 30 feet?
well, it has
I'll
to
be able to have
be
items at
independent.
certain heights and distances, and I'll be able to see how much actually disappears at certain distance.
Okay, do
So
that.
if I get the
Make sure.
same effects happening over a 30-foot surface, that's
Well,
just more evidence, right?
well, yeah, it would definitely scaled tests are definitely evidence. Some things scale well, some things do not scale at all.
He's
Aerodynamics is
already
a great.
preemptively looking for excuses, dude. Like,
I'm not.
this is the thing.
I'm being
This is the
logical too.
thing, man. You're not engaging with the
I come
actual
from an
point.
engineering background, and when I talk about things like this, I'll take it from an engineering perspective, which is not a bad thing. So if I'm going to do a test, an experiment, I'm going to make sure that it can stand on its own. The evidence can. It's not going to be the same for the same kind of test I do for a curved surface. That wouldn't make any sense. You have to something that differentiates it. It might be difficult to do, especially over a short distance,
Okay.
because well, you know the refraction thing we've done that dropping
Okay, can you chill for a second? Can I say something?
dude, might as
Because
well because you're gonna do
supposedly
it
I'm about
anyway.
to get to say something like the last 7 times. But what actually happens is you don't ever let the other person say something. That's what happens.
That's rich,
So,
which is coming from you for
okay,
sure.
you're all avoiding the actual point, which is that you guys are making the claim of exclusivity that it can only occur, it can only appear to disappear bottom up behind the horizon if it's due to physical obstruction due to Earth curvature. And explain how it could happen on a flat Earth. This is impossible on a flat Earth. That's a claim that isn't true. It's now been rebutted. The alternative has now been presented. For you then to say, well, yeah, but it could be either one. Okay, cool. That's our point. Okay, so you can no longer claim that can only happen on a globe. You can no longer invoke it as strictly, exclusively globe evidence. And when you go on to now say, conveniently, you understand the concept of supporting the positive claim, when for the last 7 years you were perfectly content running around just throwing that claim out as if definitively unquestionable. Now you want to present a test that shows that it can only happen one way or the other and provide evidence of exclusivity for curved or flat. Well, that's convenient now, which is cool. Obviously, I'm always in support of that. It's just funny that you're now saying that. So engage with that point. Engage with the point that you can no longer claim that it's like, and you never could, by the way. You
But
can't
you
claim that
can.
it can only occur due to your reified position that you haven't proven when another alternative is being shown and demonstrated, certainly when it's being shown to occur on smaller scales of known flat surfaces.
I have not seen any evidence to support such a claim. Number two, we can do things to actually provide that evidence that supports the round Earth. And that's, like I said, through differential measurements, you can actually verify that these objects that are due to perspective, that are going away from you, regardless of the surface qualities, there's no point, any vanishing point, any point of convergence, whatever you want to make up as your new scientific or physics term, will create some scenario, some conditions where an object will not rise to eye level if it starts out below eye level, or comes down to eye level and no farther if it starts out above eye level. That right there is my claim. Now, if you can find an exception to that, some logical exception, right now the exception is divergence after the horizon, as Paul said. If that's true, there should be an easy way, maybe not so easy, but there should be a way to be able to provide some evidence to support that claim. I don't think he'll have the ability to do so. That's my challenge. I would welcome it, but I don't think he can do it.
Okay, so if you look in the text chat, live stream text one, I just posted the first 5 meters of the structure that I'm building, so you
Yeah,
can
you
sort of
are.
see what I'm actually doing. If you look straight through it, it's like having a perspective grid. That's only 5 meters of it. I'm building another 5 meters. I'll join that to it. And then I'm putting perspex sides all the way around it, perspex bottom, like perspex acrylic, clear acrylic. And then I'll basically just put things at different positions all the way along it, little boats, little cliffs, whatever. Put maybe a picture at the end of it, and then fill it with water. Sometimes put cold water in there. Maybe I'll put some ice in there. I'll put some hot water in there. It's going to be probably getting up to like 30, 40 degrees Celsius over the next couple of months. So the water's going to get nice and warm. I'm going to do that. And then I'll have little temperature gauges all over it.
You
And
are out of control. God bless you, man. You are a man after my own heart. I love these projects. You okay? I don't know what you're going to get out of that at such a short distance, but you may be able to find some kind of conditions or experiment that actually
He's
provides
just
some
gonna
evidence.
do it to scale, bro. What do you mean?
Well, some things don't scale like you think they
Oh,
do.
conveniently now the
Well, no, that's
perspective
just due
won't
to in
scale.
physics and in physics.
Oh,
In physics, that is kind of
that's funny
a
because
known
just I remember
idea.
30 minutes ago you were claiming that perspective does scale.
Perspective absolutely does scale.
What are we testing?
okay,
What are we going to be testing?
That's up to Paul. But things like aerodynamics scale very well. Things like
No
strength of
perspective and
materials.
conditions.
Hold on. Strength of materials things doesn't scale well at all. There's certain things that does scale, some things that don't. On this particular test, we oh God, there's so many things that are going through my head about what you need to do here.
Yeah,
But
well, just take your time to come up with excuses while I
no,
build
no,
it.
don't be a jerk. I'm not. I'm saying this is great that he's doing this, and I don't know what he's going to test for. I'm really curious to see what the results of the myriad of tests he's going to come up with and what they actually show.
okay, so just as an example, let's say that I get a little boat and I get it from one end and I make it go to the other end, and it does exactly what I just showed in my video, going from one jetty or one pier to the other pier. Would that back up some extra evidence?
Yes.
And you're going to
Because
now publicly admit the earth is flat.
No. because some of the things what you have to because what's going to happen is anything at eye level that travels down a straight path will be still at eye level. It's not going to go anywhere. So if you have water will have some curvature to it because it's following the curve of the earth. So my fellow
Oh my
religious
god, bro! I
zealots
can't
say.
handle
I'm
this
being
guy,
funny.
bro.
Did you say water curves?
Yeah, water curves.
Dude,
How
over
much
the 10
curvature
Holy
is in
meters,
shit.
30 points?
Ever so slightly, but
over
over this
10
distance, it's not
meters,
going to over the ever so slightly. Over this distance, it's not going to curve. I
dude.
was trying to make.
Did this
I was
guy
trying to
just
put it.
invoke the
It was
Earth
a joke.
curvature of
Yeah.
10
Great
meters,
sense of humor,
bro?
I guess.
I'm so
You
done,
don't get the
bro.
joke, it's fine, no big deal. Okay,
No, it's a
so
joke now that I've said out loud.
well, that's why it makes it a joke because you say it out loud. So when he does this test, I'm telling you, anything that is straight, he has markers on this thing because it's a structure that he's built out of some type of metal. It should be at eye level entire distance as long as you make sure you're setting your camera so that it is eye level. Its entire path will stay at eye level and will not go anywhere.
Well, what I'm going to do is just set up 2 cameras on both ends, and I'm just going to let them run for, as long as I'm just sitting at home. I'll just let them run, and we'll see what happens. I might have to enclose the area so it traps a little bit of moisture in there to keep some heat or moisture going in there. Like I said, I'll put little thermometers all over the place, do all kinds of things, and see what we can make happen.
What do you plan to see? I mean, you're going to move a boat from one end to the other. What are you going? Why are you going to have the cameras running all day long? What are you trying to capture?
Well, I want to see if we get, maybe we get an infrared mirage. So I want to see how the infrared mirage builds and how it disappears if it does.
Oh,
See
I see.
if it mimics what we see out in the real world. See if it does what happens out there over long distance.
So you're saying
And
every
if it
time we
does,
see we have a horizon, every time there's a horizon, there is an infrared mirage associated with it?
no,
Okay, good.
no way. I would never say that. That's a silly
Okay,
thing to say.
just making sure. Yeah, I mean, I don't have good luck with it. That's a big project, and hopefully you get some interesting
And do you
results.
actually believe that whenever it's really clear outside and we can see further and we can see better and there's better visibility and everything looks flatter and we see further, that's when the most refraction's happening?
No, it can happen on either type of day. It doesn't have to be when there's a clear day.
No, but you have to claim like when we're seeing further, you have to claim that's when there's the most refraction. And so then when we go
Oh
out,
yeah,
the
yeah. When
visibility's
we see
not as
farther, that's the proper word. When you see farther, it's
yeah.
due to farther than we should based on the presupposed globe predictions. It's due to
Supposition.
so one of the things you can do. I have the luxury of being in a place where I can go to 7 to 10,000 foot lakes and things, and we can do it. And that we have 20 to 30% less atmosphere and temperatures where the temperatures of the air match the water. So there's very little, if any, refraction that you can actually measure. And I've done things like Ty posted the pictures, and you can see the hotels of Caesars and Harrah's that are, basically missing the bottom floors. All you see is these trees. And the interesting about the trees is you can see the openings of the trees because they're big, huge pine trees. And if you get close, you can see, oh, these are the trees I took a picture of 17 miles away. And where's the bottoms? So there's no miraging because it's too high. There's little air. You don't have any of these kind of. Although you can have it sometimes at Lake Tahoe, but not often. It's compelling evidence that the Earth is round. It's same kind of pictures he took, but go to a super high elevation lake and you'll have a whole different perspective of
Wait,
this
so you're
topic
convinced by photographs?
by tests in my photographs where I'm looking at things like
A photograph is a
shoreline
test?
and yeah, a photo. No, an observation is a test, and
An
then I do.
observation is a test? So everyone is
It is a
testing
test,
everything all
yes.
the time?
Yeah, no, when I make a change of the independent variable, which is the height above the surface, which is a change of the independent variable, it's a test experiment. Then I get another measurement and I
That's
take
not an
those measurements.
experiment.
It is an experiment. Once you change an independent variable of an observation and have it based on what you think a cause and effect relationship will be, that's an experiment. So I
An
changed it.
observation isn't an experiment.
Observation is an experiment. It's called observational sciences are sciences, and this is one of them. You can do a observational science where it shows that you can actually do an experiment for this type of goal of finding out if what the surface looks like by measuring the and observing objects in the distance where they are in your field of view. Then raise your observation point, which is the independent variable. Do the measurement again, measure that angle, and see if it comports with a flat or a round surface. Yeah, that is an. You're wrong. But thank you for trying.
Okay, so again, what's super funny is like when it's clear outside and it's more visible, and then you see it look more flat and you see farther.
Not
You
always.
believe that's stop saying that.
Why
I
not?
said
It's true.
it's irrelevant. I said
It's
when
very
it
relevant.
happens. No, it's not. I said when that happens,
Uh-huh.
you have to believe that it's the most refraction. It's so goofy, bro. Like you can tell when there's more refraction. You
How?
can literally tell because
How?
things are more wavy, things are displaced optically. It depends on what type of refraction's occurring.
Absolutely
But
not
just
true.
like okay, you can say that, but it's just obvious intuitively, bro. When
It's
there is more visibility and clearer conditions and you see further, you're more accurately seeing what's really there. You can see what's further away. And though if the water's really calm and it's much more clear outside and there's much more visibility, you see much further. That's exactly what you would expect. But that's exactly what you would expect if the earth were flat, right?
wrong. On the clearest days, and the clearest days where there is the most clear, most blue sky, and no movement on a day that matches the temperature. For example, at down there in Santa Barbara, like where the oil rigs were token, or at Lake Tahoe, where you get these eerie. I've been on there. I was just out there just a few weeks ago at a friend of mine's mansion. We were running jet skis out there. It was the most bizarre thing. So look at this lake. This this 20-mile long lake. Maybe it's 30 miles long. Yeah, about 30.
There's gonna be
And you're
another red
looking all the way
herring.
across it. There's no refraction. It's clear as day. And if you look across, you can see entire shorelines and buildings completely missing. Half of the hotels down at Harrah's and Calneva are not Calneva, but Harrah's and what's the other one? Whatever. They're half missing over 30 miles. And
So
and you
another
can
red
see it clear as
herring.
day. There's no refraction because that is a day that we expect to see that kind of where there
But
isn't
just a second
refraction.
ago you told me that you can't tell when there's no refraction, but visibly, but that was again predictably a red herring. I'll just ask the question again.
No,
It's
because I
very
was at
simple. Chill out.
little air, little
Chill out.
atmosphere,
Chill out.
very calm day. Know that there will be zero refraction or very little refraction. When we have a calm day at the sea
Oh, you
level
see how you
and the
did what you
ocean, hold
did? You
on.
interrupted
If
and
we
now
have
it's
the
your turn to
ocean,
talk
hold. If
again.
we have, come on. So if we have a
Look
day
what
like
he
that, in
does.
the
And then
ocean,
he says, hold on, and acts like
we
I'm
have a clear
interrupting
day. We
him.
have more refraction if there's a disparity in the water temperature versus the air temperature. You don't get it with it. You keep on saying one way, and it's just not that way.
You see what he does, right? Like he makes his point. I go to respond. He interrupts. And
Yeah, you're
then
right.
I start
Yeah, no.
trying to finish what I was saying. And he's like, hold on. Why do you always have to interrupt? Are you kidding me? You're just like repeatedly gaslighting the room. Like we didn't all just hear that you're the one that interrupted me. It's so goofy,
Cry me a
dude.
river. Come on.
No,
Give us
it's been like 7 years now. Like, figure it out. Okay.
You keep on
My
saying
Man, when I
question
can
was,
say something.
okay. My
I was
question
just
is
gonna
very
say that.
simple.
Okay.
My question is really simple, right? It's if the conditions are the most cooperative, if it's the atmos is less turbulent, if it's much clearer outside, if it's much calmer, the water's much calmer, and everything is very flat, and we see much further, that is what would be expected on a flat earth, right?
wrong.
Okay, I can't. This is insanity.
Because there are days where there's not that much refraction on those calm days. There's just as many as you'll find that there are these anomalies where these are strange days where you have a very warm air on very
I
cold water.
requested to
We
say
see these
something.
in Santa Barbara. Just a sec, Taylor. We see these in Santa Barbara. The very warm, strange, hot heat wave
Yeah, I
days.
second Taylor speaking instead of Zanuck.
Well, she's probably teasing
I've
me.
been
So go
trying to
ahead.
wait.
Go ahead. Time in.
Okay, so actually, ironically, windy conditions would give less refraction because the gradients are more mixed, and that would lower the temperature gradients predominance. Just saying. That's just some peer review papers I
That
read.
Yeah, I haven't seen that to be true in most of my
Yeah, because
observations,
the
but
temperature gradients. So if
So
it's
also,
mixed
Taylor,
up
you know some of the
from windiness, it helps lower refraction.
Well, then what
Anyway.
happens? What happens if there's less refraction? Why are those oil rigs half gone on the wind shop water?
Why don't you engage with the point of why she said there will be less refraction instead of just saying, no, my anecdotal red herring says no way.
Not a red herring.
So there's less refraction in the windy days.
Why
That's what
did
I
she
read in
say?
some peer review
Why
papers.
did
Yeah,
she say
okay,
that?
yeah. She said
Explain
that.
why.
Well, that's perfect because I live in a rather windy place, and down by the sea, there's an island about 37 kilometers from me. From sea level, I can't see the houses down by the sea. If I move another kilometer, about 1,500 meters further away, but up to about 74 meters, I can see the houses.
I mean,
Okay,
it
The
so
doesn't
why
refraction
did
make
done,
refraction. You still
so the
got
refraction done during windy days, which we very often have, should be rather low, shouldn't it?
this is very simple. Like, why did she say the refraction would be lower on windy days?
Because you're
Because
getting mixing of
wind,
the air.
yes.
Right.
So,
Okay.
so,
Do you guys
yeah. So
agree
that
with the
just,
wait? Do you guys agree with the
yeah,
premise? Yes or no?
yeah. I can see that
Okay. Okay. Zanuck, same.
absolutely.
Zanuck,
Yes,
you can
windy
see.
days,
Okay.
less
Cool. Okay.
refraction.
Okay. So what he's saying is he lives near somewhere where it's windy often, and he sees obstruction often. Right. She's not saying that because it's windy and that actually will lessen refraction, that's now the only and or even primary condition or variable in terms of if there will be refraction. Obviously, the reason that
No,
she made that
but
point is because we were describing ideal conditions and talking about the globe's claim of refraction when we see further.
It's a
so it would be a better situation than if it's windy than when it's a calm day, as refraction is less on windy days. Isn't that
That's
basically
what
what we
she's. That's
can
what. That's what.
conclude? Yes.
That's what she's saying, and I
Yes.
mean, it does make some
Yeah.
sense. Yeah,
Yeah.
I mean, I think it would depend on
Yeah.
many
Yeah. To me,
variables.
it does so to me too, which means my observations, which have been done for more than 30 years, because I drive
It doesn't
over
take
this
away
hill going
everything.
back home year after year, and I can see the houses on that top, and I can't see down by the sea. And since it's very often very windy, since I live on the west coast, it's windy more or less all the time. That should mean that the refraction is quite low, and it should be rather stable if the temperature is rather stable.
Well, it depends on like
Measure the temperature gradient still.
I just
depends
yeah,
on
put
like
it.
it depends on many
Yeah,
things.
yeah,
Like
yeah.
if there's haze there, you can have
Can
low
you
visibility for many reasons.
look at the
Yeah, it's still not going to
vent?
be saying that just because it's windy, there will be no refraction.
Can you? No, you're not saying
It
No,
doesn't
there's
I'm
make
not
sense.
saying that.
refraction.
I'm not saying that. And I suppose we agree upon is on windy days there is normally less diffraction than on calm
It
yeah,
days.
makes
post some
sense.
pictures. That's fine.
Can you,
Thanks.
I think it does make some
Taylor,
sense.
can you look at
Yes.
the picture I just posted in the chat?
Yeah, I'm
So
looking at it.
which one do you think has the most refraction?
I think they both have refraction.
Which one has more? You said in windy days, which is obviously the second
What do you
picture.
mean more? Like, I wouldn't know
Well,
unless you measured the gradient.
well,
According to the Journal of Surveying and
are, are,
Engineering.
are some of
Interviewed.
the now
Can you
this is not
stop
always
interrupting me, please?
you said
No, we
which one is
can't.
more, and I was going to explain, but you want to
Please.
keep on talking. Go ahead.
I read peer-reviewed papers on stuff like this. That's what I'm going to go off of, not just like some speculation. So according to the Journal of Surveying and Engineering, it says you need to get the vertical temperature gradient to know which way the light is bending. And I cannot sit here and speculate on this picture on which one has more refraction. I would say both of them have refraction. I don't know which one has more or less.
one oil rig is half missing, and the other one is in full entirety where it should be
Yeah, and
half
it's floating
missing.
in midair.
Not floating in midair. It's on the water, but you also see the cranes and things distorted as well. So what I would
And
say
I
that's
just spent
the
like
day I was
8
telling
hours
you.
explaining
That's a 90
Zanuck.
degree day. Hold on. It's a 90-degree day with the water temperature being 66 degrees and the air temperature being about 90. That seems to be ripe for refraction, especially since it's so calm. You would have this layer of air near the surface that would be in a temperature inversion. That's why I say the brown photo is refraction and the windy photo a few days later is not. Is that a stretch,
Must be
Taylor?
Earth curve, huh? So one refraction, one Earth curve. See how how inconsistent that is?
I'm convinced.
Wow, I not what I said, but you said it. Okay, fine. If that's what you think it's due to, I'm just
Don't
saying
you
which
think
one do you
it's
think
Earth
is more.
curve?
Which one represents where the oil rig should be more closely? You think?
How would I know?
Well, there's some certain tells, and I gave answers for that earlier. But
Well,
You think one refraction,
represent
one's
where
Earth
the
curve. That's inconsistent. You'd have to measure the gradient according to journals on surveying.
well, I have air temperature and I have a pressure, barometric pressure, and we know what the
What's the
hydrostatic.
gradient? Thank you.
Pardon me, we know what the hydrostatic characteristics of air near water with those type of values would be generally, and we would say that the one that is sinking there, that would be more representative of actuality because of the fact that it is blowing with less refraction, and the upper picture shows all sorts of telltale characteristics of refraction, being everything's being distorted, these miraging effects. But you can think, and then we have another picture where we have a calm day, and it's also hidden. So sometimes we get a calm day and it's going to be hidden.
Yeah, I just spent like literally 8 hours explaining that, Zanny. And then also when you're looking at one that's flashing and you've got like it's a sort of brown hazier day, as I also explained, that what you have is a temperature inversion above well above, like it must be at about 100 feet above the surface. So it's affecting that thing that's at 100 feet. It's not affecting the ground. It's not affecting the ground layer. It's affecting that layer that's 100 feet above. It's a temperature inversion layer. So it's not even on the ground, because if it was going down to the ground, we would see the entire thing miraging, and we're not. We're only seeing it starting to mirage from about 100 feet up. But anyway, the horizon's
No,
real close
the,
to
ang-
the
the
plane.
angle of the
And when
angle
the
of light.
horizon gets closer, you get that dividing line of perspective, and then once that horizon's closer to you, everything beyond that will then start to drop off. There you go, just explained it.
No, you explained it. You didn't give a reason. That's the difference. Explanation
He
is
did
not.
give a reason. He did give a reason.
What's the reason? The
His
divergence of
perspective.
the
Perspective.
divergence. So that's what he's got to go show evidence for. The divergence due to
Oh,
perspective
oh.
is something he has to test for and show evidence for it. Right now, he just has videos that we would all show to each other, and we would
Oh, so
claim
we
the
all
curve,
have
and
the
he's going to
same
claim the
evidence.
convergence. He's
Oh.
discovered something new. Nobody is, at this point is smart enough to have discovered it, but he's discovered it. And with
No, that's not what
ray
what
tracing and things,
specifically
they
what he
know what
said was
reflection.
people didn't even try to really because they just assumed they were on a globe.
You know what would be interesting to do, Paul, is draw a simulation for a round Earth, and you're a viewer. Do a simulation with the computer to say where these objects will be in your field of view. Someone already did this with Lake Pontchartrain, by the way. And Taylor, you should be interested in that. This is old news, but they did a simulation and found out that the bridge curved just like the observer would see based on Earth curve, not by and a little bit of refraction.
I cannot even take you seriously anymore.
So if someone did a simulation showing the sun going down over a flat plane, would that be cool?
You better show it changing angular size. Because
Well, it wouldn't have to.
when we see the sun set, why doesn't the angular size of the sun change?
Notice how he didn't say like, oh
Yeah.
yeah, well if I'm invoking a simulation, then of course I'd have to say yes. He just deflected to some other little problem he has with the flatter sunset.
Well, because if you see a flat Earth sunset and it doesn't change angular size, how can it be a flat Earth sunset? How can that be
Rolls
real?
for thee, not me, eh?
Yeah. Because actually, I'm going to mirror on my channel something that Iro Landucci did just recently in a presentation that he did. And anyone who knows Iro, he's also a computer modeler. What does he do? What's it? His job is like in computer graphics, isn't it?
Yep.
Yeah, so he does things to do with computer graphics, making models, all that kind of stuff, and he has perfectly mimicked the sun going down